here we go. Yeah, we're live. I'll get that link out. And just addressed everyone, so they're like, "What the hell's going on?" What's up, everyone? Basically, just gonna do a hangout, just BSing, nothing special. So don't expect anything special. Just hanging out. If you guys want a link, let me know, and I'll put it out there in the chat, and we'll be good to go. There we go. What up, Jay? All right, yep. Just try to get that link out to. What did Bansal need a link already too? Dang, I gotta go put that in the Discord. It's gonna be like the most awkward stream ever. Everyone's like, "What's going on? Why is he live? What's going on?" What I do want to do, and I'm trying to figure out how to do it and plan it out, is I want to do a 24-hour stream. But man, that is a rough thing to do. It's not easy. Oh yeah, it's easy on the tech. It's easy on the technical side. It's to keep yourself motivated to keep going. That's the hard part. But I mean, realistically, it'd probably be a lot easier for me because I have people that watch and come on the panels. More importantly, from different areas, so I could constantly probably get someone on here. But it's just that's a that's a tough task to accomplish. Yeah. Let's see, where is Bandsaw? What's up, Terry? I'm trying to find Bandsaw on here so I can. Oh, there it is. Found him. There we go. Yep, Bandsaw got the link. Yep, there we go. Yeah, yeah, this is gonna be a fun one. See how long I can last. Let's see. Just after it's almost 1 o'clock in the morning here. No, not at all. No, no, no. Yeah, it's gonna be see, because like I said, hey, that'd be pretty cool if I can just turn this into the 24-hour one. That'd be pretty cool. Well, that's like I was saying. Oh, you weren't in here at first. I was saying, luckily I have enough people that are from different parts of the world that they could probably cover around the panels to do that 24 hours. So, but like I said, I am thinking about it. I would like to do it. I just need a real good reason to do it. Let me see. What up, Jay? Say again? What's that? Uh, oh, I see. How much does that cost? Uh, oh, but you did that mainly for your 24-hour stream, right? Okay, I see. I'm gonna look into that. What's up, Rick? Which he is. Hey Rick, why don't you jump on my damn panel, man? Ah, oh, god damn it, they can't hear you guys. See, it's gotta be something. Again, the meaning yeah, they hear you now. The meaning of life was told and no one heard it. It sucks. Yeah, they can hear you now, don't worry.
Earth was flat, and you missed it, guys.
No, I didn't.
Yeah.
So, Bandsaw, are you flat again?
Well, it depends what you call flat.
Is he flat or level? So is you on the level or you're on the flat?
I really like how he just kind of just thinks and then goes into the divert.
I think he's flat because the only thing that flat earthers can do is either put a word salad or talk semantic discussions. So he might be flat now.
Yeah, but what's Barney's excuse?
What word salad have I spoken? Come on, you got to.
You're sounding like a globe head again.
I heard a couple croutons, some lettuce and carrots,
spinach.
We're going to supply our own mayo with that, though. You know,
it's all right if it's on a pizza. Spinach.
And I found out today.
Really, Rig.
Oh, he's in the chat. I keep forgetting the chat exists.
Yeah, it's there.
I found out that for one, Canadians don't even call it Canadian bacon.
Yeah,
no, it's ham. It's bloody ham.
I was at the delicatessen today looking at all the bacon, and I'm going, how can they get bacon wrong?
Bacon is bacon.
Yeah. I was looking at all the different types of bacon they sell, and it all looked like bacon to me.
Well, was it in strips?
Yeah, you can get middle ration bacon. You can get the others in a few other different styles. Middle ration and the strips, and the one with the round bit on one end and a little strip on the side.
Huh? There's only one type of bacon, and that's bacon. America.
It's all bacon. It's just the way it's been cut.
No, it's not all bacon. Because if it was all bacon, we wouldn't be having this discussion.
Okay, sorry.
You know why? It's faking. That's why.
There you go. Faking bacon.
Faking.
Faking.
Enough said. Perfect. Jeez. I don't even know why this is even a debate. I don't know why we're having a discussion of whether or not Canadian bacon is bacon.
I cannot believe Rig believes in the second moon landing.
Wait, there's a second moon landing. I'm so confused.
That is insane. He's insane.
I seen the first one on TV when I was a kid, so it had to have been real.
No, it didn't have to be real at all. We've been through this, Terry.
You just said when you were a kid, so how are we supposed to believe that?
Well, we were all there. There was a group effort.
It doesn't matter because you were watching on television. Doesn't mean it happened.
So we're all the kids that I was with and the parents and teachers were all in a group hallucination of some sort.
Watching it on television, exactly right. Watching it on TV, a recorded TV show, just like Jersey Girls or Jersey Shore. That's exactly what it was like.
Yeah, but not in the 60s.
Oh,
what do you think it was? Do you think we were watching a bit of the I Dream of Jeannie, the first episode, when it was black and white with the astronaut going up into space or landing or something?
Did you see them go into space? Did you?
I don't know. I can't remember what I seen. But I know that's what we're there for.
I wonder.
I think we saw a live TV show with the studio on the moon.
Can you see? Were they able to see the space shuttle through telescopes?
No, they just watched it on their little cathode ray TVs.
We didn't have B900s back then, did we?
Everyone looking through toilet paper rolls as little telescopes.
Get in here, Rig. Defend your slanderous words.
I don't think he'll show up. I don't know if he has his translator.
No. He's chicken. That's his problem. He's chicken.
Yeah, I do think he's a tad bit scared of being on panels. But you got to kind of understand, North Korean, Asian, Kim's probably always listening.
Exactly. That's right.
Well, when he comes into my Discord, he yells out from the background and, hey, who was that?
Here's a telescope observation of the shuttle. Oh, one.
Really?
Yep. Hang on, I'll put it up right now.
This will be interesting.
Actually, I won't put it.
What about all the bloody spacecraft in garages in Russia? Why are they still there, rusting away?
What did you just say?
You heard exactly what I said.
I really hope I didn't.
You did. It's a bit sus, isn't it? They never used any of them.
All right, there.
Where do we watch them?
There it is. That's the one I was able to find. Excuse me.
Gee, CGI is pretty good for the day.
Wouldn't it? Okay then.
And the that paper that Crash showed me with about the monopole, I sent that to my my resident physics professor, and he's going to he'll respond, and then I'll let you guys know.
You sent it to Barney.
No, to Paul.
Oh, to Paul.
Yeah.
Oh, interesting. Yes, well, Paul and I disagree on RPM and 1,000 miles an hour.
You what?
Oh, we had a bit of a disagreement on Terry's Discord channel.
What did you do now?
I was backing up Flat Earth Aussie Jesus.
I'm trying to, but he didn't let you.
Yeah, Paul didn't. This is true.
You were chomping at the bit to get stuff out, and I was listening to that.
But I backed off. I was polite. I backed off.
Yeah, but Rich was drinking a bit, so that's his excuse.
Rich is always drinking a bit.
Yeah, but not when he flies.
Hopefully not.
We'll just say no, he doesn't. Nah, never does.
All right, cover your bases for insurance purposes.
Well, that answers my question. I guess you can see the set. They could see it. There's one I was originally looking at.
What are you looking at? A shuttle.
Shuttle through observations of the shuttle from Earth.
Okay then. Okay. So you got a shuttle picture.
Yep.
Okay.
With a timestamp.
Yeah.
Yep.
Why are we showing this?
Because you do remember I said I wonder if anyone ever saw the shuttle through a telescope.
Oh, I thought we were talking about the space landing, the moon landing.
Well, that's what kind of got me thinking about space in the shuttle.
Okay then. Sorry, I lost your track of thought.
Well, Sean's just answering his own question there, Bandy.
Yeah.
Yeah, that's cool. That's what we do on Aussie streams. Answer our own questions.
Well, this was from Loomborough, New South Wales, Australia. Took this photo. Oh, that's to do with the stars.
Where is it? Yeah, the other one was done. The shuttle one was done in Florida. Wait, where are all those little dots? What are they showing?
They're illuminated objects.
Oh, see, I don't like that because then they even said they're believed to be probes that are in space. Aren't generally those probes pretty damn small?
Yeah, well, the newest ones that are going up there, those new satellites they launched now, they're only what are they, 100 mil by 100 mil now? How are you going to see one of them? And they're a satellite.
I guess you don't.
Come on, let's get back to the moon landing. And
Why?
About that.
Why? They landed on the moon. Get over it.
Where?
Where?
Exactly. Where?
That's well. I'll see if I can see telescope observations of the objects on the moon. How clear those are.
Objects on the moon. Oh, right. Okay. Is the moon out tonight? I might be able to see them.
Got a telescope?
I can borrow Riggs. He's got one from Aldi.
Well, that'd be a real good one.
Ow. That hurt. Where is that? There it is. All right.
We've got the cricket on tonight, Terry.
Yeah,
Cricket.
It's
not even a fun game.
Baseball for Australians.
Wannabe baseball. I never understood that game. I tried once. It just didn't work for me.
No, the person tried to bowl the ball at me, and I just stood back and I said, "I'm going to try to hit that." I couldn't even see the ball coming.
Real men play cricket. We've got the cricket on tonight, Terry.
Yeah,
Cricket.
they have live
telescope
tracking of footage of the moon at the moment. So, but that's not showing anything on the moon. They're not zoomed in far enough.
I lost the hangout. Hang on.
What'd you do?
I don't know.
There it is. Found it.
People like Woz play baseball.
Where's Woz at?
Victoria.
What screen am I trying to share? I don't know anymore.
I don't know.
All right, I see. I'm not lost anymore. I got it.
But just don't use a flat Earth map.
Really? Is there one out there?
There you go. Yeah, it's called the AE map. It's just a
don't
projection.
Don't even go there. That's not verified.
What's not verified?
The AE map.
Yeah, it is. It's verified
By
to be
who?
the globe. Well, first, if you what you can do is you can get the an AE map and then wrap it on a sphere, and it will work.
Put them in the ground, cast a shadow, get a protractor.
That
Is that moon the right way up?
Cool. They're pretty cool images.
Hey, Bandy, I think the moon's around the wrong way.
That's because we're on the other side. Makes perfect sense, you know. Where the moon travels, we're on this side of the moon and they're on that side of the moon. Why it looks different.
So this is where Apollo 12 landed?
Really?
11.
That says 11.
Okay.
Well,
Zoom in. Zoom in.
Fuck. I hate you.
Zoom in.
God.
Oh dear.
Zoom in. Like you gotta what do you got? You gotta circle around a pimple. Like that's not evidence.
He said circle around a pimple.
What do you want to see one of the astronauts waving to you?
Oh, come on, seriously, you got to circle around a pimple. What's that? I could put a dot on anything and say that's where I landed.
Yeah, where's the tracks for the lander that they had there driving around? You should see the tracks for it.
Oh, really?
I don't know. They should be still there, actually.
So they say.
See, the biggest issue I would have, hang on, I want to show you this real quick. And I'll go to Stellarium.
Let's see. Shawn thinks they're as dodgy as too.
Well, see, here's the thing. I don't really 100% back the moon landings. But mine's more based on the understanding of how they made it there and back at the same amount of time. That's my issue.
Yeah.
I'm just going to go, hang on one second, I'm going to pull up Stellarium.
I've got a lot of issues as well as that.
Yeah,
No, we're talking about flat Earth stuff, Ben.
I
so
know.
not personal issues.
I opened that door and I was hoping you would just fall right into it.
Dan, so you already fell, and look what happened.
I know. 2 weeks, my friend. 2 weeks, and I'm up and about.
2 weeks.
What do you mean
Okay.
up and about? Why
You've
are
been
you
doing
not
some.
now?
You've been doing some weight bearing.
Oh, just resistance work bands. Then I get over the garage and I'm going to make myself my own walking stick.
Oh, that's right, the walking stick. Yep.
Yeah,
All right, let me
that's
share
my first
this.
project.
That's CGI.
Look at it. How do they get coloured writing in the sky?
Don't you see that writing in the
It's
sky when you look up?
definitely CGI.
Yeah, when I look up, I see that.
Not that colourful. Really?
Yeah.
You got to post me some of those shrooms.
Maybe the text is upside down in Australia.
No, we're looking south. Oh yeah, it depends where we're located.
Right now. I'm in. We're looking at from San Diego or West Coast. Where I'm at.
Well, how do we
But-
confirm that? Because
Exactly.
we can't
See?
see that from here.
Yeah, a little dot right there.
Yeah,
Well,
but
go to Australia.
Yeah, you'd have to
Seriously.
go to Australia,
Come
yeah.
on. Oh my god.
go to Sydney or Wollongong. I'm in Wollongong.
Am I pretty close? Can you see the real red dot right there?
I don't know. Doesn't it come up on the screen where you are?
Uh,
Anywhere? Doesn't say somewhere
no,
written there.
not really. Oh, hang on.
All right.
Time
Go to-
zone, country, city.
I saw Melbourne. Is that close enough?
Can't you?
Yeah, go to Melbourne and I'll tell you.
Yeah, only because Bandy's down.
Yeah,
that
and I'll
way.
look out my window and I'll tell you what I see.
Can't wait.
I'll see if it marries up. All right. I'm looking right now.
Melbourne, MELB.
Why can't I just find it? I don't have to spell
OURNE.
it. Yes, you started.
Oh,
in the-
jeez.
Sean.
What?
Oh, dear. Type.
Seriously.
MELBOURNE. Oh. And
R-
NENE, Victoria, Australia. Or Melbourne, Australia. That should work.
I don't like either one of you guys.
Yeah,
See, it doesn't even matter. It still makes me want to freaking search through everything. Do it my way. If you don't like it, go to hell. Why can't this be good enough? It's right on the coast. Isn't that good enough? Why does it change so much? I think Earth has to be flat. It doesn't make sense.
Exactly right. I tell you, my sky doesn't look like that. I can tell you that right now.
It's better. Especially if you guys on the east coast of Australia.
No, looks nothing like that.
No, Bandy's not on the East Coast.
Where's he at?
I'm in Melbourne. Oh, God, how many times do we have to tell you?
I'm in the stream. I hate you guys.
Okay, then. See ya. Bye.
All right, here we go.
Melbourne. There, look.
Where are you?
Melbourne.
There, go.
You mean that one?
Yes.
Jesus Christ.
Have you taken your medication today?
Twice. Where's the moon?
Oh,
Wait, there's no moon.
Well, if I
really?
go outside and I don't see a moon, I'll verify that.
Yeah.
No moon. Wait, yep, there
So-
it is.
Hey, Bandy, how are you going to see
gonna
outside? You'll have to get
be-
up out of your chair.
Well,
Directly
I
above.
can.
Yep, right above you.
So
Right?
that's where the moon is.
Oh, there is a
There's
moon
a-
out. What direction
Okay.
are we looking at?
Hold on. I'll verify this, right? We'll do live verification.
Northeast.
What northeast. Okay. What
Okay,
angle in
then.
the sky? Keep moving
Hold
it
on.
around. I'm trying to read what angle it is or whatever.
Hold on, I'm gonna be a bit noisy.
Okay, I'll be back to just to verify.
You also know, when I was going through this, something else I noticed on here is it actually has an albedo rating, which isn't what you get from a source, a light source.
All right, fine.
Okay, then I just
The moon's
yes,
in the sky. Fine.
yes, it looks exactly like that on what you see there, and it's about a 12:30, 1 o'clock position in the sky, and it's I'd say angle. I'm not sure on angles.
Hold on. I'm going to match these shadows up. Hold on.
I can match the shadows. Geez, look at the angle. If you look at the angle on the moon to where the sun makes the shadow, geez, it'd have to be a fair way away, wouldn't it?
Yeah.
Why?
Because of the angle of the shadow.
What's the angle of the shadow got to do with anything? You know the moon's self-illuminating.
Oh, geez.
Why is why is half of it dark then?
Wait, did he just mute
Because it's
himself?
like a lampshade.
Like a lampshade, huh?
Maybe. I don't know. I haven't been up there. Just like astronauts haven't been up there.
Now, see, Sean, that moon is upside down for you, isn't it?
I believe it is. Let's find out.
Yeah, you know why?
Wait,
Because he's
how
on
the
the other
hell?
side.
Is it daytime? I'm so confused right now.
Oh my God.
He's just looking at it from a different angle, that's all.
That's right.
No, but seriously.
Did you not listen to Flat Earth Aussie Jesus?
No,
He
never.
explained the moon perfectly well.
I don't know if I listened or not.
Oh, wow. So you might have learned something about perspective.
I'll do a slick. My perspective is different to his perspective.
You know, Slick Rage quit the other day.
Yeah,
Yesterday.
I'm going to go ahead and say that that moon is upside down. Wait, what the hell just happened? There it is.
Really?
What? You turned it around.
No, that's my moon.
Okay.
Yeah, because you're on the other side of the line.
Which line is that?
The Capricorny line.
Now, Sean turned around and looked at it upside down with his bent over backwards. He'd see it the same as we do.
I don't want to know about Sean bending over, but he's on the other side of the line.
But Bandsaw, how is that possible on a flat Earth?
Because you're on the other side of the line.
No.
Yeah. Have you even... actually, Sean probably has, but maybe Terry hasn't. Have you ever tried to visualize the line?
What line?
That line. The Capricorny line.
I'm lost.
Okay, fine.
Sean,
I'll pull up Google Pro as well.
I've got to go and get a coffee.
Now you look at the line from down above. Right? You get the flat Earth map, the basic record, and you can see the line.
What? You're talking about the equator?
No, that's the equator. That's not the Capricorn line and the Cancer line.
Oh, jeez. Can you guys hear that right now?
Yeah, sounds like a kettle boiling.
Yeah, hang on.
Or a steamer of some sort. The line of sanity, Carl. Oh.
Ah, the sprinklers went on outside.
God, and it's only Thursday. Anyone would think we'd been drinking.
Something's wrong with me. I want to look at... I like Google Pro. You're able to go do so many things.
Can you?
Kind of. Once I figure it all out.
What's that worth? Was it a free download?
The free one. I want to find you... Where the hell is it? Because I know you can, like, look from different places. Oh, there it is.
You know, the funny thing is I'm pretty much in between you guys, and I can't see no moon at all at the moment.
Oh, really? that's a bit bizarre.
On the flat Earth it is, but
All right, the moon.
Have you got clouds in the sky, Peter?
I don't know
Yep.
what I'm looking at.
There you go. You're not going to see the moon if you've got clouds in the sky.
if there were no clouds, I wouldn't be able to see the moon either.
But we can't verify that right now, can we? Because you've got clouds in the sky. See, Terry and I have already verified the moon from our half.
So confused. All right, we're not going to use Google Pro. I don't know why it's not working. All right. What was I going to say? Or I was trying to figure out. Yeah, bandsaw. Gotta explain
Yes, my
that,
friend.
man.
Explain what?
How come the moon appears to be upside down?
Because you're on the other side of the line.
What line?
The line that the sun and the moon follow. There's a line.
What
And
sort of
you're
line?
and we're on our side and Sean's on his side.
But then shouldn't we see other sides of the moon?
Why would we see other sides when the moon is apparently tidal locked? We only see one face.
Well, the thing is you would have to then seed for space because it'd have to be far away for us to see the same thing, yet see it differently.
It could be far away. It's like 250,000 miles away. That's a pretty long way.
I hate Solarium. Make this easier.
Oh, Bandy, did you tell Sean about how why the moon doesn't make the Earth spin because of the gravitational forces?
Why it doesn't?
Or does or doesn't? What wasn't that one of your things?
Well, the moon should spin a little bit counterclockwise because of gravity. It should.
Why?
Because it's locked. Because gravity is a force.
But it's
It's
way-
a force.
the way it was.
Gravity-
Absolutely.
Gravity's
it's
a force. Exactly.
Absolutely.
And so you've got two forces acting against each other, right? And because of that, the moon should be moving in a counterclockwise direction. It's fluid dynamics. Very simple.
But there's no fluid in space.
Don't need to have fluid. You've got two forces and they act as a fluid. You can think of them as a fluid.
No, you can't act as I
Yes.
don't think you can use a force as a fluid.
Yes, you can. Of course you can. You can do it with two fans. It's exactly the same principle.
Yeah, but what's the fluid?
Gravity.
You're saying two fans.
Yeah,
What's
we got air. We got air.
Well, air's the fluid, isn't it?
Yeah, well, with
There's
gravity,
no air.
you've got,
There's no air in space.
it doesn't make. You don't need air. You got gravity. That's the fluid that connects the two.
But gravity's not a fluid.
It doesn't have to be a fluid. It's a force, all right? And the fluid acts like a force. My God, we've already been this for. We went through this on your channel for like 3 hours.
Well, Sean said he's got plenty of time.
Oh, plenty of time. Go ahead.
Yeah, yeah. And so it should move in a counterclockwise direction because of that connection.
I was gonna save it with pointless words, but then I realized that's probably a bad idea when it comes to showing it.
You know I'm right, Sean.
Oh yeah. Wait, about what? Nope.
There you go. There you go. See? Yeah. See?
Yeah.
And how come these other guys on the panel haven't chimed in yet? Are they still got their head banging on the table going?
Yeah, that's exactly what it is. All right, so
No
are you ready?
face palm protection provided.
No.
Hey, Bandsaw, are you ready?
Yes, my friend.
Okay.
What have we got here?
Hang on.
Oh, look at that. They're pretty pictures.
It's CGI, Bandy.
You're pretty fancy with the computer, I must say, Sean.
I'm definitely not. I just pretended. I pretend very well. All right. Let's go see what happens when I do this.
Right.
So that's the Australian moon.
Yeah.
Where's my moon?
I don't know.
In the sky.
In your sky.
Actually, it's
sky.
around my horizon. Bam.
Whoa, that's low. And I wonder why it's so low in the sky. That's weird to work
Look at
out.
that.
Yeah. And ours is so high in the sky. How do you figure that one out?
It's
All right.
easy.
Bandsaw.
Yes, my friend.
The one on the right is my view. The one on the left is your view.
Cool.
Explain.
Can you flip the one on the right around 180 degrees?
Yeah, if he looks at it upside down.
You're like this?
There we
No,
go. Look at that. They look the same now.
Yeah, but that's not how it looks like to me when I go outside.
Yeah. The one on the left is yours, and I just flipped it.
Yeah, but that's not what it looks like.
Yours looks like that, Bandsaw.
That's how ours looks. Yeah.
Yeah, I know.
And this
Because
is is right now. So you have
That's
to
right.
explain
Yeah.
that.
Whereabouts in the
Because you're on
sky?
the other side of the line.
Whereabouts on the direction it is in your sky? Ours is about 12 o'clock. It'll be nearly 12 o'clock soon by the time I go back out again.
Mine's
About 12, 1 o'clock in the sky.
Mine's about
So it'd be just
Three-ish.
right to the north. Ours is
Because where
right-
are you, Sean? You're in Texas, aren't you?
San Diego.
Or did I get that wrong?
no
San Diego.
California.
California. Oh, yeah, down lower. But see, you're like right up in the north. We're way down in the south. And
Yeah, but
between
where he's
between the-
looking at it in the sky, it should tell us
yeah,
direction somewhere there.
Yeah.
Yeah.
You see the red dot
Trying to find
Yeah.
it.
up here.
all right. Now, if you drew a line right through the middle of that map, right, you'd be on one side of the line and I'd be on the other side of the line,
Yep.
correct?
Mm-hmm.
Okay, then. So you're looking at from your side of the line and I'm looking at from my side of the line. That's why it looks different.
Okay, but here's the thing. If it was local, like it said, and it actually was that close, what would end up happening is that you would see one side of it and we would see the other. But it being 239,000 miles away would make more sense to why we see the moon with the way I see it and you see it differently.
What do you mean? I'd see one side of the moon, you'd see the other. Are you saying I'd see the dark side and you see the light side? Is that what you're trying to say?
If it was local, like Flat Earth believes it to be.
Why? No. Why? When did flat earthers say that the moon spins around?
No. Hang on, I'll show you.
If you know what I mean, because you're saying that
I
I'd
know-
see the
I
dark
understand.
side of the moon. Yeah,
Yeah.
cool.
Well, we haven't got a working model for a flat Earth map, so it's all just supposition.
That's all right. We're making one right now.
Yeah, with our help.
Well, come on, that's
Okay.
what friends are for. God Almighty.
No,
Yeah,
I'm
that
going
one.
to
Is that about the best one they've got? I think.
get my little pencil out, and then we'll do
Yeah.
it this way.
Yeah.
I know it looks a bit dodgy that model, but anyway.
It's very, I know. It's good for now.
Yeah.
Yeah, okay. We'll use it for one of the
Okay,
better
so
thing.
Ooh. Okay.
Oh, look at that.
Okay.
That's fancy. I
So-
love how you did. Oh, man, you are cool with that mouse.
so the issue is from
You can't. The issue is you can't draw a circle.
that. Well, that's for sure, obviously.
Yeah. Now
So-
look where you are
Mhm.
on the line. Look where I am on the line. You're on
Yes.
the inside. I'm on the outside.
Exactly. So
Yeah, that's right.
if we had a ball and we're looking
Yeah.
at it, and it's between us, you're going to
Yeah.
see one side and I'm going to see the other. So from here, you're going to see one side. From here, I see another side.
Well,
You can you
That's-
pause that animation?
he probably could.
Say again?
Can you pause that animation?
This one, no.
Oh, okay.
Oh, okay. It's like a GIF or something.
yeah. I'm just in my photos right now. If I pull it up into
Oh.
somewhere else, I can. If you need me to.
G'day, all.
Hello.
What's
Hello.
up, True? How you doing, sir?
Not too bad. I've got a good representation of what you're trying to explain there, if I can share.
Oh, absolutely. Let me go
Oh,
ahead.
happy days.
Sharing is caring.
True blue.
Just got to figure out how I do this. There we go.
Yeah.
Hey, True Blue.
Hang
Are
on
you
a
on my Discord, True Blue? We're looking for more Aussies.
Yeah, I'll get there soon.
Okay.
Good.
All right, you're good to go. All you just got to do is start presenting. Go to the
All
green screen. Oh, there he is. Perfect.
Whoa, look at
Got
this.
the wrong one.
Okay then.
What one can you see there? I got the wrong one.
We've got text and a couple of animated pictures. Not animated.
Yep. So you can see from the North America and like South America.
Mm-hmm.
So you can see my mouse there.
Yep.
No, we can't see your mouse.
Can't see my mouse.
No.
No, it probably won't show up, the mouse.
Oh, okay. In any case, if you look at the blue moon above America, the blue represents North America. The red one represents South America. You can see the moon in the middle on the triangle.
Yep.
So the people from North America, you can see the view they've got. People from South America, you can see the view they've got. Completely different views.
Yes.
If the Earth was flat.
Yep.
We don't see that.
That's as good as an explanation. That's exactly what I was trying to explain.
Yeah,
Thank you,
that's
sir.
also assuming the moon's only 3,000 odd miles.
But see, the thing is if you now take the ball that's in the one that has both colors, if you take that ball and you take it straight up as far as, about 239,000 miles away.
Which is, you look at the bottom there, you can see exactly what it means.
Yeah.
So 235,000 miles away, we all see the same side.
Yep. But
yes,
because we live on a ball and from space, you appear upside down. That's why you see the moon 180 degrees in reverse.
Yeah. Cool.
So, Bansal, how's it feel to be back on the globe again?
So what's that North America and South America I'm looking at?
Yeah, North America on the right and somewhere near San Diego on the left.
One side of your line and the other side.
And that's the flat map that you've done that on.
Yeah, that's a flat map. That's actually comes from Flat Earth Deception site.
Yeah, but how do we know that that's the map?
Well, see, the thing is, it doesn't even need to be an accurate map. It just needs to depict what you would see on a flat surface, on flat land.
Yeah, that's the AE map.
It'd be handy if it was an accurate map.
Well,
don't hold your breath. Yeah, I was going to say, can you explain how accurate we could make it for what it's already used?
Well, you'd have to get some trusted flat earthers to go out and make a pretty good map, wouldn't you?
What, some pilots and some navigators?
Well, no, you'd probably want some like map makers, I reckon. You don't want pilots; they're a bit dodgy.
Like
we know
some
a couple
surveyors.
of those. Yeah, some surveys. Get a couple of theodolites, a few plumb bobs.
I don't know if the flat Earth people have got their own theodolite or not.
I do.
So then you understand how the horizon works.
I know how the theodolites work, very much so. I have to use them all the time.
Then how the hell are you a flat? I'm so confused.
Oh, Shawn, come on. Because they need numbers. We know this.
Look, don't bring facts into this, Shawn.
Right?
Sorry, guys.
If this was a factual show, you'd just have to say 2 or 3 things at the start, and then we'd have nothing to talk about.
Facts are overrated. They're overrated. Facts.
Oh, I was once told by a flat earther that blah 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 blah. Facts will never change their belief.
Yes.
Yeah, facts and belief are 2 different things.
So, Bansal, you still got a little bit of flat in you, do you?
Oh.
Did you spell that right?
I'm flattered hard.
Oh,
I
how do
think
you spell
hard.
that?
I think I'll always be flattered hard. I enjoy it.
All that we did that night was for nothing.
No, it's never for nothing, Shawn, at all. You know this. Don't be so negative. You're like a glass half empty kind of guy, aren't you?
I am.
Bloody hell.
I am. Because I'm the one who drank it.
Yeah, well, it depends if you're taking the fluid out or putting the fluid in.
Well, yes. Yes. Well, see, explain this gravitational force that doesn't have an effect on the moon and make it move anti-clockwise to me.
Right, let True Blue have that one.
Wait. Did you say
See, that doesn't make sense at all.
No.
Sorry, what was that question?
It's going to be hard to understand because it didn't make sense at all.
That's why I'm asking. That's why I'm asking again.
Come on, Bandy.
Terry knows the technicalities of it.
Yeah, but it's not me that's making the claim.
I didn't make a claim. I'm just saying something doesn't make sense, right?
Ben, are you sure you're from Melbourne?
Oh,
You don't live near Byron Bay at all, do you?
No, his name's not Ross.
Hey.
It's not Ross. Sorry.
Ross and I, we're like blood brothers, right? Don't you be knocking Ross. He's a cool guy.
You missed out on a good night on my Discord for that one.
Yeah.
But all right, so you got gravity being a force. You'd agree with that? True,
Yes.
Yeah. Yes. All right. So it's a force. We don't think of it as a force. It is a force. 100% is a force. All right. And the moon has gravity, which also has a force. You'd agree with that, wouldn't you?
Yeah.
Okay then. So the Earth spins, rotates, moves, whatever your word you want to associate with it, but it moves, right? It spins around. Now the Earth spins faster than what the moon does. Would you agree with that?
Yes.
Yeah, good. Okay, because we're gonna have to find common ground for this. So I'm glad.
Even though the moon don't spin.
Exactly, right? Exactly.
Well, you mean the moon going around the Earth, right?
Yes, but the moon's not spinning. But the moon we have gravity, they have gravity, and they're both connected by gravity. Now, the moon does not move in a counterclockwise direction at all. And it should, because they're connected with gravity.
So confused. You said that.
I'm confused.
I've heard you say that 6 times tonight, and it still makes zero sense to me.
Basic fluid dynamics, like an automatic transmission, guys. It's basic fluid dynamics.
But the problem is that the rotation of the Earth and the rotation of the moon. See, I don't even know where to start.
But gravity's not a fluid.
Doesn't have to be a fluid, it's a force. And all the fluid is acting as a force in a transmission. It just acts as a force. That's all it does, right? Which is exactly what gravity does. It makes those two surfaces connected by a force. So they're
not connected though.
They are connected. They're connected through gravity. You can't say they're not connected through gravity because we are told.
When you say connected, you're almost thinking as a physical.
Well, no, I'm not, because in an automatic transmission, the two surfaces are not connected either. There's fluid between them, which connects them, right? Which creates that force.
No. Because
right?
when you shift, when your automatic shifts, that pressure plate connects it.
Right, through fluid dynamics. All right, you know this.
But how is that the same as the Earth and Moon?
We're gonna have to try to work out how gravity acts like a fluid.
It's a force, all right? It acts as a force. There's two forces acting against each other, right? That's what's happening. They're acting against each other. And because they're acting against each other, right, they're connected, right? It's like a physical connection because there's two forces there, right? So they're physically connected. Even though they're not physically connected, they're physically connected through gravity.
Oh,
right? You can't.
Hang on. They are affected by each other's gravity, if that's what you mean.
And they're connected through gravity.
But see, when you
right?
when you say connected, you're making it seem extremely physical.
Well, you're thinking of it as physical.
Because you
right?
see connected.
Let's get physical.
Physical.
Yeah. Wolf asks, what are the two forces?
With what two forces? We're only talking about one force, Wolf.
You keep saying two forces. You said both forces.
Well, it's gravity. It's one force, but you got gravity 1 and gravity 2.
Thank you.
There we go. Two forces. The two forces of the one gravity. Okay? So they're both connected, all right? And the Earth rotates, right, around, and the moon is connected by gravity, right? And the moon should spin in a counterclockwise direction, even just a little bit. And it never does.
I got it. The problem with that is that the moon's gravitational pull is nowhere near enough to do what you're thinking.
Exactly my point. I'm glad you brought that up, Shawn, right? Because Earth's gravitational pull is much, much stronger. And because Earth's gravitational pull is stronger, it should make the moon move in a counterclockwise direction. Great point. Thanks for bringing that one up.
That we wouldn't be able to notice. It's not going to happen because it's tidal locked. You're saying it almost as if it's going to change directions for no reason. Now the road, I couldn't tell you exactly why things rotate the way they do, and I think that's what you're inching up to. But
it doesn't make sense.
It's not about not making sense. It's just about the fact that I don't know. I can't give you an answer for why. But I do know that other planets do rotate in different directions, don't they?
Being so closely attached to the Earth.
Find out.
Yeah, I'm Googling too. So I have Googled this before. But they just put it down to being tidal locked, right? But the whole counterclockwise movement isn't really accounted for. And we probably need someone like Paul or Barney in here to...
So it says...
what page are you on?
Oh, perfect. Pull this
what page are you on? Okay.
Let me see. It says retrograde motion is general orbit or rotation motion of an object in the direction opposite of the rotation it is primarily. That is the central object, right? Okay, so it's showing a diagram. Hang on. Just want to know how many do what. Okay, so it says all 8 planets in the solar system orbit the sun in the direction of the sun's rotation, which is counterclockwise. When viewed from above the sun's north pole, 6 of the planets also rotate in their axes in the same direction. So basically they all rotate because of the sun's rotation? I don't know. Hang on. I'm confused. Yeah, we need someone smarter than me.
Yeah, and smarter than me. That's what I kept on saying.
Well, don't look at me.
Okay, we've got one person left on the panel.
So it says the moon.
No, we've got 2 people.
Oh, J.A.
Okay, here we go.
Okay.
It says the moon is in retrograde orbit. So let me go ahead and pull this up real quick.
Yeah.
And this is showing what the moon is doing in relation to everything else.
Apparently your mic has a really high-pitched whine in the background, Shawn.
Mine does?
Yeah, that's what they're saying on the stream.
Who's saying it?
Wolfgang.
Well, that's his speakers.
That's your speakers, Wolfgang. Yeah, it's oversensitive ears. We'll get some up in the mix.
Hang on, let's see. Let me know if it gets any better now, Wolf. I just turned my mic down a little bit. So see the orange one, the orange dot? Make that bigger. That is the moon.
Mm-hmm.
I'm trying to get the screen bigger.
I'm color illiterate. Which dot are you looking at?
That orange one.
The one that's going in the opposite direction of everything else?
Yeah. Yeah. Exactly. See my point? Now, because they're connected, right, it should be moving in a counterclockwise direction because those two forces are acting against each other. That's what
the hell is all
is
that
a little
shit
bit weird.
flying around it? Doesn't even make sense.
What's that other dot next to the Earth?
Yeah, that's what I'm thinking. Let's find out.
Is that the ISS?
ISS. It's only 400 kilometers up, apparently. Can't be in that picture.
Doesn't even make sense. Hang on, let me get fucking find something better than this.
Oh, an hour to go. And the POMs are going to...
Yeah, but is it shown on non-TV or you have to have pay TV?
I've got a site you can use, Terry. You got to have
It's not porn.
Fox. No. Well, actually, you got to wonder because Wiz gave me the site, so you got to wonder. But there's a lot of pop-ups, so you got to close the pop-ups all the time because they're always popping up for some strange reason.
Well, if I do the link through Firefox, it might not get them.
Have you got an ad blocker or whatever you call it?
Quite smarter than me.
Well, yeah.
We're waiting. Come on, Wolfgang. Come in here. Come in, Wolfgang, and knock this out of the park. Yeah. He'll come and explain it to us. Come on, Wolf.
Well, if he comes in here, he can test his headphones.
Exactly.
It says every planet in the solar system, except for Venus and Uranus, rotates counterclockwise, as seen from above the North Pole, that is said from the west to east. This is the same direction in which all planets orbit the sun. Uranus was most likely hit by a very large planetary toward early in the history, causing it to rotate on its side 90 degrees away from its orbital motion. Venus rotates backwards compared to the other planets, also likely due to an earlier asteroid hit which disturbed its original rotation. So all planets rotate in counterclockwise.
That's interesting.
Yeah.
And it says that anything that doesn't most likely was hit. So that's pretty interesting.
So technically, which way does the moon rotate if you're looking at it above?
Counter.
Looking.
Because it goes, yeah.
Yeah, but are you understanding what I'm saying about turning counterclockwise, though?
Yeah, it's rotation, right? It does rotate.
It's rotation.
It still does.
No, it's tidal locked. We always see the same face.
You always see the same face, but you have to remember.
Exactly. That's my point. That's my point. We see the same face. It should move counterclockwise.
But
Sean, be careful.
I love it when you agree with me, Sean.
Sean, you dig your own hole, Sean.
About halfway through it, I realized what just happened again. It still rotates. That's all I have to say.
When viewed from a different what? What's the word? No, don't tell him. Don't tell him. It's something I've been getting him on a few things.
Are you talking to me or Sean?
No, you wombat.
What?
When you're looking at the moon to be rotating, where would you be looking at it from to see the rotation?
Are you talking about a word that you want me to say? Are you trying to get me to say for like 6 months? Is it that word we're talking about?
Well, I'm not going to try to put words in your mouth because that doesn't work. No,
exactly. What word are you? What does it start with?
It starts with a letter.
Is it in the first half of the alphabet or the last half of the alphabet? Come on, Wolf. Come in here and explain this non-counterclockwise moon rotation that we have. It's hard to find anything on it, isn't it, Shawn?
Yeah, it's
Yeah.
Well,
something
I
that
won't
really
use that.
explains it.
Yeah, it's not just me.
Yeah, okay. I won't use that other word singularly. I'll use two words that might mean the same thing in your
Okay, then.
world. Viewpoint.
Oh, viewpoint. Yeah, well, perspective is a far better word, though. Push. Yeah, we've got to push them to the edge, Carl.
Yeah, I was doing a bit of pushing then.
Yeah, I look for some answers on this. In all seriousness, Shawn, I couldn't find anything that was satisfactory.
Well,
Really,
it does rotate. That's all you must remember.
look, whether or not it does or it doesn't explain why it doesn't rotate in a counterclockwise.
It does rotate in a counterclockwise.
No,
By the way,
no,
the
it
high-pitched
should.
wine is louder here.
Oh, here we go. Wolfgang.
Oh,
What's up, Wolf?
Wolf!
Yes, sir.
Hey,
I don't,
go.
please guys, I don't claim to be the expert on this.
Well,
And
That's
you are
all
the
right.
expert
I'm not,
tonight.
I'm not
Well,
even sure I understand the question.
Well, you're speaking now, so you're the expert. Go for it. We'll all mute ourselves while you explain.
So, what is the problem? Like the question. Please
Ben
make
solved
it clear.
the problem.
So we rotate counterclockwise. And because the moon is tidally locked, he doesn't understand how it still rotates.
So we see the same phase of the moon most of the time. So while the moon is orbiting us, it rotates on its own, same like in the same ratio, so that it doesn't turn from our perspective.
So basically,
Rotates on its own one way, and it orbits us to one way.
yeah.
So it's that's basically why the tidal lock is there.
So
and
like
all that.
basically, imagine it being on a clock. So when it's at 12 or 6, it's actually in its half or rotation.
Yes.
Mm-hmm. Yes, but the moon has, what is it? Is it a quarter or a sixth that of gravity of Earth? One of those two figures.
1/6.
There you go. See, I was pretty close the first time. The second time, right? Which is less of the Earth, right? Now, because the Earth has a stronger gravitational pull to it, right, and it's spinning counterclockwise, that's acting upon the moon, right? And the Earth is spinning faster than what the moon is. And those two forces, right, which and gravity being a force, right? Now you have mass attracting mass, which is a little bit which is a little bit like magnetism, but it's not magnetism, but we're going to use that as the analysis, right? And because they're connected, right, because one mass is rotating faster than the other mass, that are connected by a force, it should influence that other mass to
It
spin.
only should do that in your mind, I'm afraid.
Yes.
Yeah, well, of course it's in my mind.
So I wrote it down.
Because you don't see
my
that.
answer, and so here's the answer. You ready? Gravity doesn't affect, or the rotation of a planet doesn't affect gravity's pull. So just if the Earth, because the Earth is rotating at the equator at 1,000 miles an hour, so to speak, it's not generating more gravity at any more.
The gravity
any
doesn't
other time.
transfer.
No.
Listen.
Yeah, no, I'm not saying that the Earth or the Moon generates more gravity at all. I'm not inferring that at all.
Well, Bandsaw,
But the
how?
gravity is not like a fluid between those two.
But it acts like a fluid because they're two forces acting upon each
But it
other.
doesn't.
But it has to because they're two forces. They're connected.
So it has
They're connected.
Who the heck
They
told you that if it's a force, it has to work like a fluid?
Because that makes logical sense.
Oh,
Fellas.
because it has to be logic. Okay, my bad.
Well, why? What do you mean? Because it's logical sense. It's not logical. Oh my
Now, Bandy, if you're talking about forces like gravity, like with the ISS and satellites that are up in space that are about 200 odd kilometers up, the amount of gravitational force on those objects would have to be a lot greater than what you're saying for the moon to have any attraction to the Earth's gravity.
Sorry, Terry. Can you just repeat that? Because I had an Indian call center calling me trying to sell me cheap power.
Shit, I only get one brain spurt at a time.
Well, yeah, I did apologise, Terry. Come on.
Unless somebody else reworded what I said, what they know.
No. You go.
Sure?
I said, yeah, no, and I do apologise because I did get an Indian call centre.
Oh, you know what? My old brain doesn't like to repeat 3 seconds like a goldfish.
Well, mine ain't far behind you.
Okay.
These are so fun.
Go on, I've been serious. So's Bandy, actually.
We've been deadly serious.
Right, now the Earth has a gravitational pull.
Yes.
Now, the objects in space that are a couple of 100 kilometres or a couple 100 mile up, like the ISS and satellites,
yeah,
they would have to be pulled towards the Earth's gravity a lot more than what they are to have any effect on the moon. The effect of the moon to pull the moon, to affect the moon from the distance.
The ISS
and other satellites up in space that are orbiting the Earth.
Yeah.
The gravitational effect on them would have to be a lot greater to have any effect of gravitational pull on the moon.
Yeah, but we know that the ISS is constantly falling when it's in orbit. It's constantly falling down to Earth.
Yeah, but not straight down.
No, but it is falling down all the time, and that's why it has to have its little rocket boosters apparently to give it a boost to push it further away from Earth.
It's losing altitude while it's in its orbit.
And how periodically do they do that?
Well, I don't know actually, but that's what Scott told me.
I thought you were about to say me. I was like, I didn't say that.
Yeah, no. I blame the people that give me this information, and Scott's the one. Sorry, Wolf. Sorry, buddy.
Yeah, I would advise against using word down when talking about ISS and orbits because it's always relative to down. So it is losing its altitude while it's being on the orbit.
Well, okay then, Wolf. What's wrong with using the word down? Because down is down. It's coming back down to Earth.
When you talk about ISS, you mean falling down. You could mean falling down towards the Earth or falling down and missing the Earth, aka the orbit.
Well, okay, I get what you're saying. Well, it's coming back towards Earth. Is that better?
Yes, that's losing altitude.
Yeah, it's losing altitude, because it's getting pulled by gravity. Yeah, and it has to have its little rocket boosters periodically pushing it away.
Yes.
Yeah.
That's my understanding.
Yeah, that's what was explained too. So we know that there is apparently a force acting upon the ISS, being gravity, that is responsible for this. And we have two forces, gravity and gravity, Earth and Moon, acting upon each other. One's greater than the other. And the Moon really should turn around a little bit, I reckon. But both Shawn and myself cannot find anything on Google or Quant or Bing that really explains it satisfactorily at the moment.
Well, Bensor, how fast does the moon rotate?
Well, it doesn't. It's tidal locked. We just see the one face. This is my point.
I mean, sorry, wrong word. How fast does the moon spin?
It doesn't. It's just tidal locked. We see the one face.
We see the one face, but the moon actually spins.
Yeah.
The moon is rotating around the Earth approximately 27 point something days. The moon is also spinning once in that time.
Yeah, yeah. Right?
Right? So as the moon spins, the Earth is spinning, the moon is going around. That's why you see the same face. You probably need to do a experiment at home with you standing in one spot. Get someone else, you the Earth, someone else the moon. You spin around, they spin around, but they're spinning around 27 times slower than you are. That's going to be hard to do. You can probably do it on a computer model or something, but you will then understand that why you see the same face, because of the speed difference in the spin of the Earth and the moon. Does that make sense?
There is, as far as I know, there is like 10 to 15% of the difference of the phase we see from the moon. I mean, we see of the moon. Like we see little bit more than just the half.
Right, but it's very, very close.
Yeah.
Mm.
It's really hard to visualize unless someone runs a program to show it. Shawn's still searching, is he?
I was actually looking in the chat. What's up, guys?
Anything interesting?
No. I was going to ask Daryl what the topic of him and Sean Baker conversation was that they were talking about debating about. But other than that, I was just kind of listening. First, Bandsaw, you were looking.
What do you mean? I was looking. You were looking too.
Well, I understand that the moon does rotate. Just realize this: if it's tidal locked, right? And imagine the moon's orbit around us is on like a clock. Well, the fact that when it's at 6 o'clock or at noon, right, and we're staring at the moon and we're seeing it. Yes. Well, when it's at 6, you're halfway through its rotation. Because if we weren't and it didn't rotate, we would actually be looking at the backside of the moon at 6 o'clock.
Yeah, that's pretty well said.
Yeah. Look, do we ever see the dark side of the moon?
No.
No.
Well, there is no such thing as the dark side of the moon, really.
You know what I mean by the dark side of the moon.
Yeah.
Thank you. Once again, I'm glad you agree with me all the time. This is fantastic. All right. So we never see the dark side of the moon, ever. All right. So the moon goes around, apparently, the Earth, with that same face always pointing towards the Earth. You'd agree with that, wouldn't you?
Yes. I don't know if I want to agree with it or not.
You want a shovel?
Oh no! There's no hole. I'm not digging a hole. I just
right. So we never see the dark side of the moon. Right. This is my point. Right. This is my point. Right now, and because gravity of the Earth, right, is locking the moon, right, in orbit around the Earth, and it's 6 times stronger than the moon, right, and the Earth's gravity is 6 times less than the moon. There's a force keeping those two connected together, and those forces, right, because the Earth is spinning faster than the moon, right, would make the moon move in a counterclockwise direction.
I would say the problem here is in your understanding of gravity. Not trying to insult you or anything like that, but
No, you know, Wolf, I don't get insulted at all.
yeah.
You know, I don't get insulted.
Ah, perfect. Thank you, Jamie H.
You can try, but I don't get triggered. Terry knows this.
Yeah, I'm about to pull up a very good explanation right now.
Google title locking. Look, there is an animation wiki leak. Oh, is there?
Yeah, that's what I'm
Okay.
going to share right now.
Okay, cool. Exactly. Right?
What? Exactly what?
We only see one side of the moon. It's making me dizzy looking at both of those at the same time. Close one eye. That helps. See? You only ever see one face.
Yeah, the left one is what we see.
Yeah.
Now,
And if the moon didn't spin on its own, I'm using the word spin now, even it's wrong.
Rotate.
But
yeah.
like that
Now-
would be what we would see.
Now, what we need
Without
to
the-
do, but what we need to do now is have that GIF having the Earth spinning, right?
It wouldn't affect it anyway.
Well, I know.
If there
that's...
was fluid like between, if space was like more viscous fluid, then you would have a point.
Yeah, but the fluid is the
There's not
force
even
of gravity.
air.
The fluid
But
is the force of
gravity is
gravity.
Gravity doesn't act like that.
Well, it's a force. It's a force. Mass attracts
Yeah.
mass. Mass attracts mass, right? Apparently, this has been proven and tested year after year after year. It's a force. It can't be denied. It's a force. It's like magnetism, all right? It's a force. Otherwise,
But
everything
does
would just
magnets
implode.
work like you say?
Yeah, no, but I'm not saying. I'm just saying, right? It's a force, right?
Yeah,
It
we
has to
don't
be.
see it with any other force either, so
Yeah.
why would we see it with gravity?
Because, I'm not saying that we say it's a force. It has to be a pretty strong force to be
Yeah,
able to be able to lock a massive object like the moon, right, and keep it in place.
Yes.
It have to be a pretty strong
Well,
force.
it's pretty weak, but
How can a force be weak and keep water attached
because
to a ball?
yeah,
So
because
that
it
doesn't.
works with mass. It's
Mass
relative to
attracts
the mass.
mass. That's right.
That's why
And
you
the-
don't see like bowling balls attracting tennis balls because they are really tiny in mass. But then we have
Yes.
Earth, which is huge with great mass, so it has
Yes.
greater attraction.
That's right. So the Earth itself has got a massive amount of mass, doesn't it?
Yes.
That's right. So it's got a massive amount of gravity. Yes.
Yeah.
And the moon is less. So you've got a massive amount of gravity acting against a little amount of gravity.
You could say so, but yeah.
Well,
I'm trying to right now. Hang on. I'm trying to see if I can be able to stop and control that GIF. Because if I end it,
In our scale, moon has still a great amount of gravity, even though it's 1/6 of the Earth's gravity. It's
yes.
still pretty great.
Yeah, and it's less, right? But it's still a force. And so you've got two forces that are acting upon each other, right? And one force is moving faster than the other force. So that force...
The force doesn't move.
The force has to move because the Earth is moving. The Earth is rotating. So gravity has to rotate.
No.
Yeah, no.
I don't. It's like annoying because I can't explain it. Like I can't just tell you how it is, but
It just
I have
is.
to then just say
I kind of got to accept it.
No, well, not necessarily. You just have to find someone who can explain it better than I can, for example. But there, of course, there's still a lot of things we don't know about gravity and all that.
Mm-hmm. And the thing about that, excuse me, the thing about gravity is whether we know 1% or 75%, what we do know does work. Ooh, this is actually a really good one.
Well, it seems to work in a mathematical equation. I'll grant you that.
Here, try.
It works in real life. We can build things according to understanding we have.
This should probably, hopefully, is good enough. Okay,
we're all having fun though, which is the main thing.
Okay, so see how this is? See how where the people are on here?
Why aren't they falling off? The ones upside down.
I hate you. See, so yeah,
you kind of assuming there with that GIF that people are actually on the moon and have been to the moon
twice, or actually 12. Wait, 1, 2, 6 times. I don't know. I don't even know if they have or not. But the reality is that this makes sense to the moon's rotation. So watch this.
Are you presupposing that we landed on the moon?
Someone is.
Not me. Not me.
That's a fallacy, isn't it?
Exactly. Presupposition if ever I've heard one.
That's the one. Yeah, that's the one.
I don't like that.
Whereabouts are you, True?
Brisbane.
Okay, cool.
Bit warmer up here.
It is a bit nippy down here, mate. It's about 4 degrees at the moment.
Yeah, I spent a year down Melbourne.
Okay. My kids are in Gladstone.
Nice and sunny here today.
Oh, yeah. No, I've got my sister up here at the moment from Melbourne. She's loving it.
Okay, I actually found a word for this. It's synchronous rotation.
Okay, hold on. What was that, Wolfgang? Synchronized rotation.
Yeah, you can actually see it in the chat. Right.
I put it in the chat.
Jamie H posted.
Good one, search. Jamie. Good one, Jamie.
Synchronous.
You only have to put out the word and people. People are amazing.
Yeah, but not everybody puts out, Banshaw.
God, I just realized you guys can't even see what I've been doing.
Well, if you ask
I don't know. What have you been doing?
Well, I got my little screen and I'm drawing on it, but you guys can't see that.
Here's a cool one from Astro Girl West.
There, now you guys will be able to see it. See, I did all this drawing for nothing.
Oh my God.
Yeah, it's a lot, huh?
That's art.
Yep. The other question I've got is, how's those people breathing in space? They haven't got any.
They're blue. They don't need to breathe.
Didn't you hear there's atmosphere on the moon?
Duh.
Apparently there's water on the moon.
And the moon is in Earth's atmosphere. Did you hear that too?
Oh God, they changed the goalpost.
Yeah, that's what I meant.
Yeah. So Bandsaw,
yeah.
Who the fuck needs space?
For real, who does? See 12 o'clock?
I can see 12 o'clock.
See how the blue man is on the downside of that?
Yeah.
Yeah, he's down with 12 o'clock. Yeah.
Yeah. If you take this one right here and you put it at 6 o'clock,
yeah,
that's how you know it's rotating. You remember the clock thing I told you a little while ago, which I made no sense of right now?
The moon ain't rotating.
Oh, jeez, it is. I promise.
From which viewpoint, Bandy?
What are you talking about? From which viewpoint? Where's the North Pole on that Earth?
Doesn't matter.
It would matter.
Why?
I can't see it. My eyes aren't good enough.
We'll say
There. And I don't think the moon. Okay, so anyway, the moon doesn't spin. We see the same face all the time.
The moon does spin
From Earth, we see the same face.
at 12 o'clock.
Because it spins, we see the same face. If it didn't, we didn't.
No, but what I'm
see the same
saying
face.
is it doesn't spin with
Look,
the
see this?
counterclockwise direction that
see
it
this
should.
right here? This spot of the moon?
Yeah, I know.
Did
I
he
know.
pee
That spot
himself?
is the same thing as this.
Yeah,
Moon having its period.
I know.
And that's because it's rotation. That's how that
Yeah,
blue
no.
man ends up where it's at.
Yes.
Otherwise, the blue man would be down here.
Yes, but how much faster does the Earth move compared to the moon?
It doesn't matter.
Yeah, it doesn't.
You mean through space? The Earth moving through space?
Oh,
One
now
takes
We
20
have
days
been
and one
same
takes
as
24
trouble.
hours.
We have trouble in amongst the ranks.
No, look. This Earth takes 24 hours to rotate. The moon takes, I think it's what, 28 days?
27.4 for a
Oh my
lunar cycle, I
god,
think.
fucking Dean's
Yeah, I
here.
know.
Oh,
I know.
geez.
I just told you we've got trouble amongst the ranks.
Now, don't get too serious, Stingray.
This
Hey,
is a
Stingray,
light-hearted
why don't
project.
you bring one of your damn models out and show it?
Well,
Yeah.
I don't know. Just
I've got a better one for you, Stingray, too. I want to
is
pick.
it,
I
wait,
want
wait,
to.
wait a minute. It's a sniper scope or something. I've got no idea what it is. It looks like
Oh, you have
crosshairs with a sniper
to
scope.
start from the beginning, Bandy.
Yeah, and I've got a bone to pick with you, Dean.
Uh-oh, why?
Yeah, what? Exactly. You and your refraction models. I got a bone to pick with you.
Wait,
Okay.
are you guys still at war with each other?
No, we're never at war, Dean and I.
Well, I know Dean's kind of been upset lately.
I know. You
Have I been
sound a bit.
upset, have I?
You've
I don't
you've
think
sounded a bit cranky on a couple of streams, Dean. Is that because you miss me?
Mhm.
Well, yeah, you did. Like I say, you destroyed my favorite flat earther. So yeah, got a problem there,
What's this?
obviously.
Dean, ask him if he's a flat earther again.
Are you a flat earther again?
Oh, I think the side's looking a bit undernumbered at the moment.
He's been answering that like that all.
Yeah, that's better. I like that.
He,
You know,
he wants to put a bit more intellectual honesty on their side.
Exactly.
yeah. No, that's one thing
It's
that
much
I'll give you
needed.
credit for. That's the. If anybody had asked me, have you ever met an honest flat earther? It would have been you, and you being the sole case.
Well, I can hold my head high then.
So, do you want the short story or the long story? What we're talking about, Paul?
Wow.
I mean, Dean?
Sure.
The moon and the Earth should be attracted to one another, which would affect each other's rotation.
Like he's thinking gravity as some kind of fluid between Earth and the Moon, so that the Earth's rotation should have some effect on the Moon.
Oh, so you get kind of if these were gravitational waves, there was some kind of energy friction between the two, or something.
Yes, like fluid dynamics type of thing.
Automatic
all right?
transmission is he
Yes,
brought up.
yeah, kind of, and the moon should kind of move in a counterclockwise direction. You know where I'm coming from, Dean, don't you?
Yeah, it's kind of like water and pressure,
Exactly. Thank you. See?
except that's not gravity, and we can easily demonstrate that.
You just did a bandy on bandy.
But that's fine. That's why we're here. We're here to enlighten the masses. That's what we do. I've still got a bone to pick about his refraction.
Oh, what's up with the
diagrams.
what's up with the refraction diagrams?
Oh,
Have I got? Wait a minute. Have I got any refraction diagrams?
You've been showing refraction diagrams with your magnifying glass and
Oh,
stuff.
lensing. Yeah, atmospheric lensing. Yeah.
You know
Sorry,
you know what I'm talking about. Yes.
I do now.
And I can't remember whose stream I saw it on. And anyway, I watched it and I thought that's a bit dodgy what you're doing there.
Is it?
Yeah, it was a little bit from my perspective, right?
Mm.
Because you had a magnifying glass, right, which represented the atmosphere, correct?
Mm-hmm.
Am I correct there? Right.
Mm-hmm.
But the trouble is, right, you needed like 1 billion magnifying glasses, not just one.
What you wait a minute, to
Yeah.
make up the atmosphere. The problem with 1 billion is a magnifying glass only works because it's converging the light. So if you imagine a tube is going into one end and then somehow a cone is coming out the other, and that's because of refraction. So the problem is if you have 1 billion of them, all you're doing is taking this uniform light and separating it. And that separation effect would cause you to see, it'd be like, well, that's what a kaleidoscope does. You'd see many different, whatever that it is that you're looking at, many different ones.
Yeah, well, maybe so, but maybe that's why the Earth appears to you to be a sphere.
I don't know how you went to geometric sphere from a kaleidoscope showing me many of the same objects.
But I think you need to model something that's looking through atmosphere, because like all those little bits of atmosphere is acting like a little magnifying glass. You'd agree there? Yes.
No.
Don't, Shawn, I want to talk to you again. Did you agree with me?
I'm gonna go ahead and let Dean take over.
So let's define. Okay, Banzo. Let's define a magnifying glass. A magnifying glass takes a tube of light, and it converges that tube at the other side down into a cone. And the reason why it magnifies is it's actually doing that. Or it can go the other way. These are what lens elements do. A tube can go into one side, and then it can come out a large kind of filter, so it's actually getting the radius of that tube is getting bigger on the outside. And that will be the magnification effect as well. Now, the reason why, and it's the same thing with a glass of water, you can move backwards and forwards and you will get an upside down world. But then when you get closer, you'll get a magnified world that is the right way around. And that's because of this convergence of light. So if the atmosphere is doing that, then it is centric to the observer. And if you move left or right, you will get a very different effect, just like you would with a magnifying glass. So you take a magnifying glass, you look in a direction, you move your head left to right, leaving the magnifying glass in the same thing. You see a very weird thing happen with the motion of the object that you're looking at. It will not be consistent. You will not see consistent parallax because it's screwing with the light. So no, I completely reject the premise that the atmosphere has millions of little magnifying glasses or acts like one big magnifying glass, because one big magnifying glass would only work for one observer and no one else, and only if they didn't move.
Yeah, but I see it more as multifocal lenses myself.
And then we're back to the kaleidoscope.
Right, because down the bottom, right, because you've got a different thickness, so closer to the water, right, you've got it's thicker, and as it goes up, like multifocal lenses, right. So you've got one prescription down the bottom, in the middle there's another prescription, up the top there's another prescription.
Yeah, okay. Yeah. I'm gonna agree with you, and I'm gonna I can agree with you to say that can magnification happen? Yes, but it's not lens-like. So to me, lens is a uniform effect. Yeah, so it works just the same in any direction. Now, the atmosphere is not a lens. It's like a sheet. Now, can magnification occur there? Yes. Will it happen uniformly? No. It will only happen in the direction of the pressure differential. So height. So what we can get is we can get not only magnification in height, we can also get compression. So yes, if you got down to it, and if you restricted the word magnification to only one axis, in other words, a square in the distance could become an elongated rectangle, but only upwards and downwards, not laterally, then I would agree with you. The atmosphere can magnify things very, very slightly. But other than that, no, it's not a lens, and it doesn't uniformly magnify like a lens does. But there is an apparent single-axis magnification in some cases when you get mirage effects. Mirages are actually doing exactly what I just said.
Yeah. Yeah, I look at it more like multifocal lenses. for some strange reason. And I don't know why I've got that stuck in my head, but you know why I do have it stuck in my head, don't you?
Because your glasses are stuck on your head and they are multifocal.
Exactly, right.
Yeah,
and that's how
I got there.
and that's how I look at the atmosphere, because like you got it's different thicknesses going up and all that sort of stuff, and the light's coming through those at different angles and all that sort of stuff.
Yeah, the issue that you've got though is you can easily work this out. This is not an unknown. So Canon, Leica, Konica Minolta, these all make amazing glass which control refraction and amazing lens groupings which control light. So they have to understand all of this. It's not an unknown and it's not a new phenomenon like a lot of flat earthers say, oh, we don't understand this. Well, I'm sorry, we have for thousands of years. So the issue that you've got with
But are you
kind of
talking
describing the issue you've got with describing this effect is because it's so known and because we can calculate it. We can, given the atmospheric effects of the day, I can tell you whether there's going to be compression. We can model it to test the model against reality. Now, on an average day, even though there is a pressure differential, the differential is not enough to cause visible effects that can be seen with the naked eye on the horizon. Because standard atmospheric refraction is 1.003. And it doesn't matter whether it's 1.004 in some places or 1.002 in some places. The difference between that, as in the fractional reduction in light speed, will not cause a significant effect. It has to be extreme and get into the extreme severe range to start causing effects. Now, and then there's one visible telltale sign that it is doing so. You'll look at an object with straight lines and they won't be straight anymore.
Yeah.
They'll be wavy and bendy and they'll be animated.
So what's extreme conditions?
Extreme atmospheric refraction.
Just out of curiosity.
I'm not actually sure of the numbers, to be honest. I think something like the difference between standard atmospheric and let's say 1.1, I would consider quite an extreme change. Because at that point, I'm actually modeling, I haven't finished yet, but I'm modeling atmospheric refraction. So not using a lens, but using a large volume. And I can get it to bend, to magnify in single axis. But that's rather than magnify, which is a uniform effect, it's just stretching upwards and compressing downwards. I can get it to do that. I've not finished my example yet, which is why I've not shown it to anyone. So.
You're disappointing me, Dean.
Oh, I better have a coffee. I've only just woke up actually, so it's a bit weird.
They're short of numbers, and they kind of need help for the big debate coming up.
They are actually. Do you know something, Bandy? I watched the Netflix documentary for the first time in the last week, and there's two things that happened to me this week or this weekend last. Is I watched the Netflix documentary and I recognized either voices or faces of 40-odd% of the people in that.
No way.
Yeah, I even saw Earthy seriously flat ejaculating in his pants as he's meeting Mark Sargent. It's like I should not be able to watch a random Netflix documentary and name these people. And then the second thing is I watched a video. My girlfriend sent me a video, and it was about the origins of flat Earth. And then another video that was coupled to it, which was 10 best reasons to believe in flat Earth. But it was a parody. It was taking the piss.
Yeah.
But one of them outlined that there are probably only about 100 people that believe in flat Earth. And I thought, well, that could be a little bit low, but it's probably not a lot more, to be honest. If I can look at a Netflix documentary and pick 40% of the people out there, and I've only been really involved in this in 4 months, how many more people can there be? So yeah, I completely sympathize with you saying, or empathize with them with the number problem, but there's 7.6 billion people on the other side. I don't think one person is going to make that much of a difference, to be honest. If I'm being serious.
Yeah, I know, but I feel a bit sorry for them too. And I like taking the piss.
Yeah.
So we've been having shits and giggles. It's been good. It's been a good afternoon, actually.
You got a debate on Crasher's channel, aren't you, sir? or something.
Yeah, I do on the Cavendish experiment, but that's an easy one to smash.
Is it?
I'm sorry. Yeah, I'm sorry. I'm up
What
against.
was that, Merle?
I'm going to smash it. I'm going to get my crew onto you. Apparently, that's what he says. Yeah. No, I'm not a fan of the Cavendish experiment, and neither is a few Globies. They're not really all that impressed with it either, actually, because there are.
What do you mean impressed?
Well, there are flaws in it. See, it might give you the figures.
What would be,
What
the,
would be the
flaws?
flaws? Oh, everything, just the way it's set up. It just looks dodgy as anything, right? And we're debating the original Cavendish experiment. So that is as dodgy as anything in a pig shed in the middle of a paddock in the middle of nowhere.
I mean, the problem that I've got with that is why does everybody run to the Cavendish experiment that's like hundreds of years old?
Didn't, Dean.
When you can rent lab time with a scale that accurate now that you can prove the same thing in a fraction of a second.
I know that.
It's ridiculous.
You know that. I know that. You know that, right?
Yeah.
But what's his name? Terry Christ Puncher or something?
No, Christ Punch is the one you're debating.
Yeah, he's the one that wanted to take me on with it. I had him dancing around circles a little bit, and I told him that he needs to read the whole Cavendish experiment.
And I take it you're doing the same, right, Manda?
I've actually already read the whole thing.
Okay.
Cool.
Cool.
So I'm one of probably the few people that were on the flat earth side that have actually taken the time to read the bloody thing instead of just quoting one sentence out of the thing.
Yeah.
I
just stay away from that argument because it can't be. I don't know why. It begs belief. It's like someone saying how we realized that compression, we can harness force from compression. In the early days of the Industrial Revolution in steam engines, when we can just look at an internal combustion engine right now. Why the hell are we looking at something so old and so outdated that uses?
You know why, Dean? You know why? Honestly, come on, seriously, this is like a sport, isn't it? This debating thing.
It probably is a little bit.
Exactly right. So if anyone's really honest with themselves, that's what it is. Everyone wants to get into the gladiator ring. Everyone wants to throw a few punches. Everyone wants to be right and prove their point and all that sort of stuff and come out victorious. That's exactly what it is.
Andy, at the moment, you can't put your best foot forward.
Not at the moment. Hey, but come on, let's do push-pull.
No.
Yeah.
No.
I've done some more research into that.
Has True Blue done the push-pull with you, Bandy?
No, we don't have enough time because, hey, Dean.
Mm-hmm.
Yeah. Whereabouts are you located again?
Not bloody Australia.
Yeah. What part of England?
Middle, so just about 60 miles north of London.
Well, the Aussies are going to give you a lesson tonight anyway in the cricket.
Yeah, I don't follow cricket really. I used to play it as a kid, but not anymore.
What sort of person doesn't follow the cricket? Really? Come on.
I know who Jiminy Cricket is, but that's about it.
I thought the only people that follow cricket were Australians and Indians, and everybody else just humours them. I didn't realize.
Slick talking yesterday.
Yeah, I'm
cricket.
I don't follow sport.
Hey, anything Australia takes a pommies on with is serious.
Well, yeah, we've got to get them back
seriously.
We've got to get them back for what they did.
How come this stream is running anyway, Shawn? That's why I joined. And they're like, how the hell are you streaming? What time is it for you?
I don't know. It's something wrong.
It's 2:30. I'm actually just hit a wall. That's why I'm not talking. I'm tired. But The Aussies convinced me to go live.
Yeah, but wait a minute. They've got their own Discord. You know this, right? They've got an Aussie Discord where they do this shit all the time.
we egged him on.
Yeah.
I haven't got you over there yet, Dean.
See what they did, Dean, is they Bandsaw threw me in with his nonsense, and then we talked about some more nonsense, and then
continue with more nonsense.
Yeah. Then we continued with more nonsense, and then we just made reality happen.
It just went kabang.
Realized that they could be doing this over at their Discord, and then I realized that I'm tired and I don't know what I'm saying right now, so it's okay.
But see, this is what.
Wait, really quickly. Anytime anybody sees Schrodinger's cat again, he kind of got at me for not watching his videos on his channel and subscribing to it. So I subscribed and I started watching random videos every now and then. I just watched one called "Stupid FE Girl Cannot Get into Remedial Class."
What the hell?
Huh?
I know, but it's like going after this. Like, she must be like 15 or 16-year-old girl, and it's taking the piss out of her. And I think we should not, we should defend her, really, because she doesn't deserve Schrodinger or Cliff getting on to her this much. I'll link it, actually. It is funny and she is a bit dense, but I'm not. Oh, and I watched your video, Shawn, for the first time of you leaving Flat Earth.
Did you?
Yeah. Well, you had to cut it short.
Yeah. What's called? What did you think?
Do you want the manly opinion or the diplomatic one?
What about a bandy opinion?
Oh, that's easy. You cried like a girl, mate.
I did.
Did you cry, Shawn?
I have emotions.
Oh my
I apologize.
God. You
did you make a lot of friends then that you felt really close to in the Flat Earth community?
Yes, and then even worse, I have realized that most of them are full of fucking shit.
Yes, I know. But are they still friends, and do you still tolerate them, or is that?
No. I've had.
Oh, that is sad, actually. That is
probably about half of them turned out to be full of shit. Seek and Find used to be one of them.
Right. Okay.
Well, that's one thing I noticed too. I think I told you that, Shawn.
I mean, I still talk to a lot of them. The guy Jay that keeps popping in and out every once in a while, he's like my little brother. I don't think anything will ever happen like that. He's a flat earther. We've actually never gotten into a discussion where it got bad. So I mean, there's a lot of flat earthers I still talk to that are cool, but there's also a lot that I realize are full of shit, and you can just tell in their arguments which ones are which now.
Yeah, but there's a difference between full of shit and then being hostile because you don't share an opinion when you were once friends and shared the same opinion. Oh, yeah. I would expect any friend of mine, if I changed opinion of them, if we disagreed on some subject, I would expect the friendship to be stronger than that subject.
Absolutely.
You would hope so.
Yeah, you would hope so. And
is that not the case that you found then after leaving Flat Earth?
Well, I found out who was real and who wasn't.
Right.
Yeah. So, yeah. I mean, you probably see it in my chat every once in a while. You'll see some flat earther come in and talk shit, or you'll see a flat earther come in here and say, "What's up?" And I see it when I go around to different live streams or different other places. It's like I can tell. I know which ones are which now. I'm starting to be able to tell. For instance, in my chat, New Perspective, that's a flat earther. He's been cool with me since I left, or before that. I mean, for a while now. And I have respect for him. So I don't think I've never seen him talk shit. I've never talked shit about him. And my choice is my choice. That's how it should be.
Yes.
Whereas there are flat earthers that go out of their way to talk shit and call me this and call me that. And unfortunately, yeah, a lot of them happen to be people that I considered friends.
Yeah, that is a bit sad.
But it's a shame how people turn. Like snakes.
But
it's a shame how they turn like snakes.
Oh yeah, big
bunch
time.
of snakes, all of them.
Well, you say that. You say that. Yeah, you say that. But like Bandsaw here, we could have disagreed on anything, and we could have still sat down and had a chat about anything else, and had a beer and got on really well.
Bloody hell.
Yeah. So that isn't the case with all of them. There are some people that put friendship above, differences of opinion.
It's ridiculous to me.
Yeah, I find it
but at the same
sad,
time,
actually.
The way I see it is I'd rather know which ones those people are, because they're obviously they were never really friends. They were just pretending, like they pretend it's flat, and then they can all go F themselves.
Well, I think, imagine if you were friends with someone like Pete, like proper friends with Pete, and you shared his opinion, he'd be really friends with you. And then if you changed your mind, there's a strong possibility that he'd tolerate you, but there's no way he'd be friends with you because his belief is stronger than any friendship that he can form. My belief in a globe probably isn't, because it's not it's not.
It doesn't matter to you.
Yeah, it's not that it doesn't matter. It's that a human friendship bond to me is a lot more than the shape of the planet. The shape of the planet is what it is, and life moves on. But my interaction with a person is something that will echo through fucking time.
Yeah,
I cannot change the geometry of the planet, but I can change every moment from this moment forth through interactions with other people. So they're far more important. But when people don't think that, that's when you get, when people take the flat Earth and it's to such a degree where nothing else matters, then that's where you've got a problem.
Well, it becomes preaching, and who wants to be preached to as well, really? There's far more important things in life, like you say, Dean, friendships, having a beer,
beer's way more important.
Well, man, having a beer and bloody well talking about bloody well, refraction at the same time and having a bloody good old laugh about it, whatever, those things are way more important, and friendship's way more important than any of this rubbish. Like I said, I think it's just a gladiatorial kind of arena that isn't really lending any good to anything. Like, it's fun. Like, I enjoy it. I enjoy getting in the side chats, trolling a little bit, triggering people. I'm
not gonna lie, it's kind of fun trolling.
Yeah.
I didn't think it would be, but sometimes you get kind of bored explaining to flat earthers every day.
Well,
so
it's kind of enjoyable, actually. I actually like trolling the Globies, and you can be nice about them, and as soon as they start abusing you, right, you know that they're triggered straight away, pretty much. You just keep on being nice to them, they just keep on abusing you anymore. And I'm sitting behind the keyboard here just chuckling to myself. Is that the best you've got? Really? My kids call me worse than that. Yeah, my daughter gives a better argument than that. Come on. Oh,
yeah,
crazy. But anyway, it's getting late, my friends, and the cricket's just started. Terry, I've sent you a link in Discord for the cricket.
Okay.
If you're interested in watching players batting, none for 4, first over. That's
so
the important thing.
You're watching it, Bensel?
I am, mate, at the moment, yeah.
To see the first ball?
No, I missed it. I only just turned it on now. What, was it a close one, was it?
Oh, no, Warner hit a 4 on the first ball.
Oh, okay, yeah. I did notice he was 4 not out, but, I didn't see the first one. I just tuned in with the third ball. Hopefully it's going to be a good game.
Hopefully.
Hopefully it's going to be high scoring with a bit of luck.
It'll just be confusing for you, Shawn.
Oh yeah, I have no idea even what I'd be watching.
No.
So I started watching Gridiron. And boy, I'll tell you what, that was confusing when I first started to watch it.
This is football.
Confusing, man. It's just like two lines running at each other.
Yes.
I ended up getting on Google and Googling the rules. It's like I figure out what a first down was, and there's another first down, and there's a second down, and there's another first down.
I don't get why you guys keep running around kicking the ball. It's like it looks right, and then you guys just stop and start kicking it.
I understand why you pansies have to wear helmets and pads.
Oh, that's not just because we want to
Yeah,
go home
Aussie rule.
and know our
Aussie
names.
rules football is pretty pretty mad, isn't it?
It's gruesome.
Yeah.
For sure.
Can you imagine if they turned it into an American sport and they just started strapping pillows to all their appendages and running around and bouncing into each other? That'd be awesome, wouldn't it?
It would be, actually. It would be. Oh,
This
cool.
should have the Aussies should have a take the piss day. Let's convert this into an American sport.
Exactly. Actually, that'd be good just for shits and giggles with a few beers.
We could always play league like they play American football. You know, whenever the other side gets the ball, we swap. You get the defense team on, and we get the ball. You swap. You get the offense team on.
Oh, God, they've got about 622 players on each team. They only play like 30 seconds per match each.
I think the biggest thing that annoys me is you get to the end of a game and there's like 3 minutes to go.
Oh, God.
35 minutes later, it's still got 2.5 minutes to go.
Exactly. Yeah, no, it does my head in, actually, that game. But actually, they get quite a few Aussies over there as the punters, I heard.
Yeah, they use them as kickers and punters, yeah.
Oh, wow, I didn't know that.
Yeah, they kick really well, Dean, so we use them.
That's because we play football over here.
No,
We actually kick the ball.
It's called soccer.
Oh no, I'm talking about Australian rules.
Oh, aerial ping pong.
What?
Aerial ping pong. Oh, my God, Terry.
What?
Oh, no.
You guys are so confused.
I'm going to book a holiday. I need a holiday. Not enough.
Finch has just gone out. LBW.
What? God, I'm so Aussies confused the crap out of me. I'm never doing an Aussie show again.
Sean, go put some spinach on your pizza. Man up.
That is disgusting. Why do you even say that?
It's gourmet. It's gourmet pizza, my friend.
No. Gourmet pizza is pizza that is made at a nice restaurant, but regular toppings.
Mm-hmm.
No pineapple, though.
No, that's blasphemy.
Oh, let's
Pineapple.
agree on something.
Hawaiians don't eat pineapple or pizza with pineapple on it.
Oh,
Therefore, it's
a
not
hamburger
Hawaiian.
with a lot, with beetroot and pineapple.
What the fuck did you do? What?
What? Oh, I suppose you
Yum.
got bacon and eggs on that as well.
Oh, for sure. And cheese, bit of lettuce, onion. Oh, my mouth is salivating just thinking about it.
And then he's like, and cabbage.
No, that'd ruin it.
Some mushrooms. Oh,
Yeah, mushrooms, yeah.
Oh, yeah.
Yeah. Well, what kind of mushrooms?
Well, it depends what shop you get them from, but hopefully the ones that don't make you feel like you're a giant walking around a coffee table for 6 hours.
Yeah, that's exactly what I'm talking about.
Yeah, I know what you're talking about.
The ones that make you think the Earth's flat.
Those little blue meanies can, I don't know, it's a strychnine in them, I think. But I think that's more the ayahuasca, isn't it, Terry?
Oh, ayahuasca, that just sends you loopy anyway.
Apparently.
We've got evidence. We got evidence for it.
Most definitely. Most definitely. Hi, Daryl.
What's up, Daryl? How you doing, sir? I think Fight the Deception is going to jump on too. I'm not sure.
Oh, awesome.
Hey, Daryl.
How you doing? How you
Hey,
doing, man?
how y'all doing?
It's been a minute, huh?
Doing good.
I haven't talked to you in a while.
Yeah. Seemed like we just haven't been on at the same time, it seems like.
Yeah, I haven't been around too often. I'm just now getting back into the swing of things.
That's right. I remember somebody on one of those Discord channels was saying you left them. It was saying you went ghost for a while.
Yeah, I was moving, and then I had my birthday, and just this and that. So.
Aha.
Oh,
Awesome.
you're a year older now this year.
I unfortunately, yeah. And it just doesn't stop. That's the worst part.
You get a surprise for your birthday?
not a surprise. I kind of knew it was going to happen, but I don't want to be too graphic.
Did you have to open your present?
Address, yeah, but I don't. Is that relevant?
Well, I'll just be in general.
Yeah, at this age, I don't want presents. I just wanted to do it and go to bed.
You don't want the wrapping or anything.
No, definitely not. That just takes all the fun
Creating
away from it.
extra work.
There wasn't any batteries included.
Yeah, there was, but that's just called playing. Oh, you have no idea, my friend. Yeah, trust me, the shape of the earth don't matter in here.
Oh.
So,
Go ahead.
Go ahead.
And earlier I was talking with Sean Becker about some of the claims he made. Interesting, just having fun. My sleep schedule got thrown off, so here I am. It's 4:40 a.m. and I'm still up.
Gee
So,
whiz,
I figure I just get on and find some flat earther to
harass.
toy with. Yeah, I guess so.
Bandy, step forward.
Yeah, mate. No, we were just having fun. We're having shits and giggles. We're just filling in time.
I was going to say you can step up to the plate, but I said no. I should say no. Roll up to the plate in your wheelchair.
I was feeling sorry for the flat earth side, Daryl. I thought they needed some numbers again.
You transition back over briefly just to help them out.
Oh, man. And then Dean comes in and just fucks everything up.
Dean, you're ruining the perception.
It was all right. It was all right when it was just
You're
Sean.
ruining the
When it was just
perception,
Sean.
Dean.
That's right. It was all right. It was just Sean. Sean was agreeing with me. Right? He was
We're on
having
the moon.
applause.
What the?
We're playing with the moon.
Oh yeah, when you were forcing me to agree.
Well, I'm forcing you. God, my God, you exaggerate. Forcing you. Yeah, we've got it recorded.
What type of force was it?
We've got
liquid
it
kind.
recorded on. We have it recorded on both streams, both Crash's and yours, that you were agreeing with me. We can rewind this.
Please do. One second.
Oh, that's close.
Trying to finish writing something. Hang on. All right. Pay attention again.
Oh no!
I was taking notes. I'm preparing for a geoengineering stream tomorrow.
Oh, cool.
Okay.
Warner's out. If anyone's interested.
Who?
Warner and Finch are out. It's 2 for 10.
Well, how's this one for Sean? They won the toss and they're going to bat.
Oh, they're batting. Yep.
Yeah, but they won the toss.
That's right.
That term
tossed
doesn't mean what they mean.
Yeah, they won the coin toss. Congratulations.
Oh, okay. I thought you might have thought it might have been something else.
No.
Oh, you mean like a salad?
Oh god. Oh my god.
Is that what you assumed I would say?
Yeah, salad, yeah.
Yeah, see, if you Aussies were around more, you guys would have been able to been here for the Rumpus Challenge.
Oh, yeah?
I was.
Oh.
Yes, you were. I'm gonna tell you now, you were insanely close.
Who won?
Really?
Oh yeah.
I didn't even have a photo.
I had a couple people decide because I couldn't objectively. So I think it was Menace and Tesla's Apple. But I think it was Shawn Hawkins and you, True, that were just neck and neck on the backside. I think it was see, I got it written down somewhere.
Geez, all I had was all I did was colour the jersey and put a wine glass in my hand.
But it was creative. And then, when I asked why. I asked the three people why they picked Tesla Apple, and they all said, "Because it's it looks like the original one. And I went, well, yeah, that's
Yeah.
what it is. And he just put like the apple, and he was like, well, that's clever. And I'm like, oh, okay, that's why you picked it. And you're like, yeah. I'm like, okay, that makes. Good job, guys. I'm gonna do. I got another one coming up. It's gonna be pretty badass. And this one is gonna. I'll actually have a giveaway gift before I even announce it. It's gonna be wonderful. I'm gonna start doing more of those, just because it's fun.
Yeah, it was fun.
I just gotta find someone else to mimic, like a Dean or something.
Or a Pastor Pete.
No, I have a feeling if I did a Pete challenge, it would go way too far. I could only imagine. That's what I'm gonna do. I'm gonna find it'll be someone that just is very unexpected and didn't expect it to happen. It's gonna be fun. Either that or something. I don't know. I didn't realize it'd be fun. I thought it'd be stressful, but it's actually fun. And all you guys are gonna ever win is gift cards, so congratulations. That was like the worst part. I'm like, what kind of gift cards do you get? And my girl's like, you have to get Amazon. And I'm like, why would I get Amazon? Why not like Best Buy or movies? And they're like, she's all, don't most people not live in the United States? I'm like, fuck.
Yeah. Yeah, I think Amazon would be better.
Yeah, I'm gonna do Amazon next time.
Yeah. We can actually get it now.
Yeah. Well, you still can. It's just gonna take a long time for you guys to get those packages.
Oh no, we can go. They've got a Australian Amazon warehouse now.
Ah, nice. Yeah, that's what I'm definitely going to Amazon. It doesn't even make sense not to.
You could be really evil. Oh no, I won't say it because that'd be like proper assholeish. You could like go and buy, because I didn't know that Radio Shack isn't a thing anymore in the United States.
Yeah, they got rid of it a while ago.
Yeah, but you could probably find on eBay like £1,000 worth of Radio Shack vouchers, and then to everybody that isn't in the States, they'll think, "Fucking hell, it's worth actually just traveling to the States to redeem these or something."
Oh wow.
Yeah, that'd be
nice. Was it? I know. The best part about when Radio Shack closed down out here, there was down where here in San Diego, there was at least 3 stores that like halfway through emptying them out, they just left. Doors open all night, and people just walked in and just got what they needed, looked around, realized there was no register, and that was the end of those Radio Shacks. It was pretty crazy for a minute.
Wow.
But I mean, it wasn't nothing serious. It was just, stupid component parts and doodads here and there. Nothing, no GPSs and shit like that. But yeah, that's what I should do that, huh? Find a store that doesn't exist in the UK and then have only UK winners.
Yeah, Matlin's doesn't exist anymore now, which was our equivalent to Radio Shack. It's called Matlin's.
Well, to me, it seems ridiculous. Why? I mean, Amazon is so great. I mean, I can order it and get it tomorrow.
I can order now all the way up until about 12 midday and get it the same day. Yeah, it's pretty awesome, that.
I think mine, I was looking on it earlier. My hours are weird. Like, it doesn't, like, I have to like hit it at the right time for it to work. But for the most part, yeah, I can get it next day, and I have to figure out exactly what time it is that I get it same day still. Like, I'm pretty sure if I ordered something right now, I'd get it today. Because it's 2-3 o'clock in the morning right now.
Talking of which, Shawn, I'm going to say thank you.
Sir, thank you.
And I'll think of something else, and we'll do this again.
Okay, sounds good.
For sure.
We'll finish the gravity conversation.
Yeah. Yep. We'll finish something. Maybe we'll start something new. Who knows?
And a bit of push and pull.
Yeah, a bit of push and pull. bit of Cavendish, bit of Newtons. We'll get it all in there. It's good for shits and giggles. That's for sure, guys. All right. I got cricket to watch.
Catch ya.
So 2 years old.
See you,
Ciao.
see you, Bandy.
Have a good one,
See you
sir.
later.
See
See
you
you
later.
later. Okay. Bye.
There you go. Cricket's more important than you, Sean. Just to show you.
What the fuck? Why is Jiminy Cricket more important?
And more important than the shape of the earth.
Yeah.
Well, that is true.
Well, the pitch is flat.
Is
Yep,
it
must
level?
be flat.
Is it level?
Ooh, it's debatable.
Is it?
How long are you going to go on, Sean?
I could end it any second right now. I'm actually exhausted
I should get some
Oh.
sleep.
because I know I'm gonna go live later on today. So, like I said, the Aussies forced me to do it, and like all the Aussies are like, "I'm out of here now." F you.
Yeah, well, I'm on holidays at the moment, so I've been watching Jose at ungodly hours of the morning.
Yeah.
I'm think I'm gonna watch the Jose's replay from his dog having the puppies.
Did he
Did he
actually
have
have? Yes.
Yeah, he
I don't know.
streamed it.
Oh, nice.
Yeah,
Oh,
but
wow.
It was like 8 hours ago.
I know he was doing it. I just didn't know if he had actually streamed it or not.
Yeah, I can link it.
Yeah, please. Yeah,
It's on the YouTube chat.
Okay, awesome. Yeah, if you guys aren't going to chat it up, I'm probably gonna end it because I like to wake up and be ready to stream. Because what you call it? I do plan on streaming tomorrow. So
You mean today?
is that? Yeah, God damn. I'm so tired right now. Like,
tomorrow for us.
like an hour ago, I went, "You should not be streaming. What are you doing?" And it was too late. I'd already started.
Hey, Sean, Fight the Deception is asking for a link.
Oh, I'll stay for him.
Wait, what?
You guys should actually go watch Jose's debate stream, the last one, when Dysfunctional Navigator came in.
Oh no!
Oh
no,
my
no,
God.
no, no! I listened to that shit. I ain't
Was
watching
it
Did you?
114? What
Yeah.
episode was
Yeah,
it?
yeah, I think so. Yeah, whatever the last one was, I think it was 114.
Okay.
Yeah,
Well, I'll
refuse.
be going to watch it.
Okay, sir.
Thanks for the stream. Was nice chat and.
Yep. I'll see you later on. I'll probably see. I know I'll
Yeah.
see you around.
See you, Will.
Yeah.
Yeah.
Yeah. Bye.
Have a good one, sir. Yeah. Yeah. Fuck if Fight the Deception wants to come on. I'll stay up. I don't care. I want to have a conversation with him. I kind of called him out in his own emails. I don't even know. I'm so tired right now. But he is somebody I would want to debate because I remember that conversation you guys had with satellites.
Mm-hmm.
And yeah, seems like an easy win.
Well, according to him, my understanding is, according to him, he won though.
No, he lost bad. I just remember going, do you like? I remember him his evidence was showing us stuff and him saying he didn't know what it was. That was his evidence. That's what I remember. I remember him saying things didn't work, even though they did. Or he said things were impossible, even though they weren't.
Yeah.
It was kind of like one of those things. But the main thing was that he kept presenting evidence that he couldn't explain.
That's right. Like that wire video. That was the funniest one.
Yes, exactly. The wired one, and then the ones with the it looked like he was looking at something with infrared.
Oh yeah,
night
yeah,
scope
yeah.
or whatever, night vision
Yeah.
or whatever it is.
Yeah,
And
yeah.
he was like, "What is that?" And he's like, "I don't know. That's what I'm asking you guys." I'm like, "What?" This is your evidence.
That's exactly the conversation I had with Sean Becker there. Oh man, it's a common federal. He's like, dude, you only believe what Einstein says. I'm like, interesting. I'm like, okay, well, how do you know that? Well, don't you believe what he says? What you asking me for? You just so like, the Great Lakes are 600 feet below sea level and they flow downhill. How is that possible on the globe? I'm like, well, what's the problem with that? Doesn't level mean level? I'm like, what the fuck?
Yeah.
What are you? So yeah.
Fight the deception. I'll try sending it to the email and try going it coming in here through there. I don't know why it's not working for him.
One interesting thing about the video that Fight the Deception made and that Paul on the plane made, he tried to get away from it later when I brought it out because he was saying, "Oh, you was going back to Paul on the plane," but that's the video he presented. Did anybody else notice that in Paul the Plane's videos when he's saying that they're faking weather patterns or whatever, that actual page says it's monitoring like ambient temperature or something like that? Like the actual page that he's using for his point says something different.
Oh, of course.
Of course, it's common with flat earthers. I remember Res Rhetoric was debating somebody about they were trying to say the Earth curved, things disappearing at the bottom of some kind of refraction or something. And they like look at this picture from very far away, and in the actual description of the picture itself, the people were saying like this is a rare refraction phenomena that we could only see once or twice a year or something at the proper time and location.
Yeah,
And it's like
longest picture, the
yeah,
furthest distance. Yeah.
like, dude, you presenting the picture, just read the damn description. It's like it's crazy, man.
It's the same way as the whole gravity force thing. They're all arguing for general relativity, which is gravity still.
Mm-hmm. Or when they always want to quote like Sean Becker there, he was like, even Einstein said something. Even Einstein said you can't see the curve or something like that. So I'm like, well, what was Einstein's position on the shape of the Earth? Then he goes to talk about something else. So I had to ask him like 5 times to finally answer the question. Yeah, it's crazy. Then he started maligning Einstein. He's like, well, I don't remember the stuff he was saying, but a whole bunch of slander. I'm like, oh, but you quote him when it suits you, right?
Mm-hmm. Well, just ask him, do you believe that you're smarter than Einstein? And then have him prove it.
Hey, but hey, Conspiracy Cats, when he was debating Nathan, I guess that was Nathan Thompson, he blatantly said, these other people know more about thermodynamics than me, or I understand I don't know as much about these people, but yet he's still saying thermodynamics proves that space can't be real in the atmosphere, whatever he said. So apparently they don't know that they're not as smart as the people. They don't even know that they don't even know the subject is better, but some kind of way they will still believe they can draw better conclusions or dismiss their findings. It's just absolutely illogical, man. You saw that video, right? With him, with him versus Conspiracy Cats.
Yeah, I just saw it.
He literally said, "I understand I don't know as well as these people," or something like that. It's crazy, man.
Yeah, it's like I've been telling people, it gets to the point at certain points where it's like, we can't have this conversation. You don't even know what you're arguing for.
Exactly. Yeah.
And once you get to that, it really is. Like I said, I honestly am in the transition of getting this stream into the subjects that I normally do, like geoengineering, weather modification, like those things. I'd much rather talk about government and all that kind of crap than flat Earth. I mean,
I understand.
Realistically, as far as I'm concerned, I've already debunked flat Earth. A lot of people have.
Dozens of times over.
Uh-huh.
I understand, man. My show Sunday, I think I talked about astral projection or something, and Wednesday I talked about the proofs of the globe. So yeah, man, it's just starting to become a waste of time. I'm like can't go to sleep and extremely bored. I was like looking for one, like yeah, come on, so I could get a laugh real fast. But so what? Fight the Deception is working on coming right now.
Yeah, I sent the link into his email in the email that we have back and forth. So we'll see if that works. What was I gonna say? The only upside to this streaming thing is that I'm still learning. So I mean,
yes, true.
That's the only good part. Luckily, I mean, I have really smart motherfuckers that come on my streams most of the time and just have a lot of really good shit to say that I can learn and everything. So that's the main reason I still do it. But that's why like Seek and Finds, Mind of God, like that's why you don't see him here anymore, Cause I got to the point where it's like, you guys are, you're not helping. You're not aiding to my knowledge. You're hindering it.
Yeah, but Shawn, you don't see them anywhere anymore, to be honest.
Because everyone's sick of them. Well, I know that's why Seek
Yeah, but
and Find doesn't show
that doesn't
up.
work. That doesn't work with Pete.
With Pete, oh, yeah. Well,
I
see, the thing is, I can kick Pete, and he's understanding of it. I kicked him yesterday, and he understood.
Yeah.
What's up, Terry?
I was just going to ask, is it okay if I drop a link to my Discord in the side chat?
Oh, fuck yeah, absolutely, sir.
Yeah, because Wade's Underworld is an Aussie that I know of.
Yeah. He's the guy that came out with that badass Flat Earth versus the Globe Earth meme upload thing. It was pretty funny. I played it it was a while ago. I played it. It was pretty cool. Yeah, he's cool, dude.
I think I know how to do this.
You just share it, copy and then paste.
Yeah, that's what I'm doing.
You know what? This brings up another thing that I commonly run in with flat earthers. Like they will make a claim, and then you point out how silly the claim is, and then they act like you're somehow. It's like, how dare you? I'm like, what the? You the one that said it. I mean,
well, that's the whole like it's like have you ever been to space? No, but neither have you. So how do you know it doesn't exist? Or how do you know there's a dome if you've never been there?
Mhm.
Or like it gets frustrating, and
It has to be a dome because there's pressure inside it. Pressure has to have a container.
gravity's the container. But then you got to understand how gravity works to a certain extent to understand that.
Is that a real flat earther talking, or is that somebody trolling?
No,
Me.
Yeah,
no, I'm just here for the for some reason I don't know.
Yeah, he's just
he's
just drawing. That's cool.
Even I don't know why I'm here. Why am I here?
Yeah, we're flat Earth free at the moment.
Okay.
You're escaping the cricket.
Yeah, that's true. Yeah, that's true.
You're here because it's only 8 p.m.
That too.
8 p.m. No, it's 3 a.m.
Yeah, you're in the past, Shawn.
You got your clock wrong.
No. Your guys is definitely wrong.
And your moon's upside down.
No, your moon's upside down.
Yeah, turn your moon around the other way.
Your stars rotate the wrong way.
Oh, jeez. Australia doesn't exist. What?
And I don't know what this northern pole polar. What's this polarity you keep going on about? I've never seen it.
Me either.
I've seen it.
The fun. Jeez. Just think, Australia doesn't exist. You have a conversation with Aussies, and somehow flat earthers think it doesn't exist still.
Don't we get paid by Disney or someone?
What? You do? They pay much better than NASA, I heard.
Oh, okay.
I know one argument that needs to be won on flat Earth and put to bed because flat earthers think this is a real thing, and they think they've explained it and proved it so much that why is anybody even asking about it? And that's the things disappear from the bottom up. Arwin calls it natural concealment phenomenon. It's like,
what
the hell are you on about? So yeah, Jose got me and Arwin together on one of his shows, and I started asking him about the sun and the apparent optical phenomenon that is the sun, that independent of any optics can give out energy that we can measure independent to an observation. So it's not an optical phenomenon, or if it is, it just coincides with the source of the energy as well. So there you go. But then he went on about natural concealment, and then I made him rage quit when I started drawing a diagram. Because I want a flat earther to explain things disappearing from the bottom up and come up with a formula with me for it. But no one ever has, but they just think it's absolute proof and it's proven and they don't need to do anything.
Yeah, you're going to get a lot of that. See if that link works. I don't know why Flat Earth or Fight the Deception can't get in.
Can't you invite him based on his email address?
I don't think so. Not only for friends, but I'll try. Or I don't know what his email is. That's the problem.
I thought you just said you'll email him the link, so he must have got it, right?
Well, no. I went to the email that we had together and sent it, but it's the same thing. I'm not sure if it's. I'm pretty sure it's on his end. I'm not sure if he's on a cell phone. I know cell phones, tablets, and computers all do the same, or all do different things when you hit that link.
Mm.
But I just put the URL into the chat rather than the share URL, and it's different. I don't know why, but it is.
Hmm.
Because that's what I learned that one a while ago. If you share this one, with the invite box, that link works. But normally,
wait a
the
minute,
top
wait a minute.
one
He's
doesn't.
on. Sorry, Sean. Sorry. He's on an Android device, and it's just taking him to Google Play. That's because he has to download the Hangouts app in order for that link to work.
That's weird.
Hmm.
Yeah. So it's a separate app for the Hangouts in the Google app.
When it comes on Android.
Yeah. Wait, it is on iOS as well. I've got a Hangouts app on iOS. So.
Yeah, but when you do that, you can go. It'll ask you if you want to go through a browser. That may be it. Fight the Deception. When you hit that link, paste that in one of your browser apps. It may work
Chrome.
that way. Yeah.
Yeah. But it's better just getting the app, the Hangouts app.
Much better. Much better.
Yeah. It's just better to use a PC.
Or a Mac.
Mac, I don't know about them.
Jeez. Dang, every day you just make it worse for yourself.
Yeah, well, I'm an Apple developer, so
I'm
not going to do that on on Windows, am I? So
no bias there.
No, I've also got a gaming virtual reality rig, which is a Windows PC. So
Okay.
I've got both. I've got a Linux workstation somewhere as well.
Well, I could tell you right now, I hate Android. I don't even know why.
Have you got an Android phone, Sean?
I got both.
Which is your daily driver, your personal phone?
Apple. iOS, yeah. Just so much easier. I don't have to worry about being hacked every 5 seconds.
What iPhone have you got?
That's just a 6S. I am also a person that hates upgrading.
You mean you hate spending money?
Oh yeah. That's what I meant.
Yeah.
Hey, Sean, the other Sean is saying he has trouble getting in too.
Really?
Mm-hmm.
I have no idea why.
Maybe they don't like Sean's.
Mm-hmm.
Dude, let me see. I don't know why. I'm not gonna lie to you guys. I'm too tired to give a fuck. If you're here, you're here. If you can't, you can't. I'm not going into the extras. Usually I'm like Googling, trying to figure it out, but I'm tired, man. Fucking Aussies. What's up, Dreads? How you doing, sir? My boy Dreads is in there in the chat. He must be getting ready for work or something. Yeah, but like I said, yeah, this is what's happening right now is exactly what it's the flat Earth conversation has come to. Oh, absolutely. Wade's no problem at all.
Wade wants to drop in to test his headset.
Yeah, Fight the Deception. I already emailed you the link, but if you need me to do it again, I will.
Hey, y'all, if y'all would take a moment, maybe y'all can help me out here. Maybe y'all can help make sure it's not just me. This is what Sean Becker said. That's what he said right there. So I'm asking him, okay, you said that the Great Lakes are 600 feet above sea level, and they flow down to the ocean, how is that possible on the globe? I'm asking, why is that a problem? And he keeps saying, well, you're forgetting the part about the 10 states that are flatter than a pancake. So I'm like, okay, so you said 10 states are flatter than a pancake, but you said this about the Great Lakes. Why is that a problem? What are you saying? And for some reason, he's still saying, I keep forgetting the first part. Is it just me, or is it possible to address the Great Lakes without having to keep talking about? Is it possible to address the Great Lakes and stop avoiding it totally and only wanting to say 10 states?
For me, that 10 state statement is dishonest, because flat isn't something that you can exclusively use to determine how straight and level and flat something is in relation to something else.
But just about the lakes, though, like, is it possible to simply address the Great Lakes part and explain why it's a problem that water can be above sea level and flow to the ocean? Is it possible to just address that point by itself?
Wait a minute. So the Great Lakes are above sea level. What are the heights of the Great Lakes? Let me have a look.
Well, you're saying it's 600 or 700 feet above sea level. I looked it up. That's pretty much accurate. And you're saying, and they flow down to the ocean. How is that possible on the globe? I'm asking him to explain that, but he keeps saying you forget. He's not. He's acting or seems to believe there's some kind of, I don't know, some kind of dilemma with simply explaining that comment.
I'm confused by the question.
Yeah.
It makes it actually makes a lot of sense. What's up, Wades? Do you want to test that?
Hey, Shawn, how are you, mate?
Exactly. In other words,
how you doing, sir?
It
Are
makes
we working?
sense.
Yeah, yep, we hear you.
Thanks, dudes.
Yep,
How
no problem.
about
Cool.
how about me? Can you hear me?
Yeah, we hear you.
I can hear
How you
you.
doing?
Sean, can you hear me?
I can hear you.
Okay, yeah, thanks, guys.
No problem. How you doing, Fight?
Could be better, could be worse.
Yeah,
What, despite the deception?
Yeah.
How are you able to get on? What you had to do?
He had to email me the link.
Man, it's too early in the morning. Everybody's sleepy. The system's sleepy. Everything's sleepy.
Hey, my
No, I
brain
don't.
hurts.
This is another thing I always notice flat earthers do is consistent. Like, they make a claim and you point out the claim doesn't make any sense. And you're like, well, no, it's the other part.
Sorry, I've just been looking at the Great Lakes, and it flowing through Montreal. It goes through Montreal, doesn't it? And then out into the ocean that way. But it does actually flow, believe it or not. I think it actually flows, well, in topological data on Google Earth, it flows uphill slightly in some areas. And that sounds really counterintuitive, doesn't it?
Well, that would be more just the force of the body of water behind it, or upstream.
Yeah. So you can have water flowing uphill so long as the downhill leg produces enough force to get it over that hump. And you do get natural oscillation humps on riverbeds as well. So it's always actually at some points flowing up and over. It's just a force that takes it, and that up and over might not necessarily be shallow enough for you to figure out, hey, hang about, this river's actually going up a little bit.
That's kind of where how lakes are made, and then how rivers wind. All the above. It's just how it works.
But that flat as a pancake, that statement, the state's statement, is a bit weird to me, because you describe flat as in having. I describe where I live at the moment, which is Buckinghamshire, and a place called Milton Keynes, incredibly flat, because I come from Yorkshire, which is more northern, and it has hills. So it could be a topological description. All the states are incredibly flat because they don't have much ground undulation or mountain ranges or hills. So they are therefore flat. But that's no indication that they are, single direction flat.
I mean, one reason why I didn't even bother addressing that is just in my experience with the flat earthers. Sean Beck, which 10 states are you talking about?
It's hard to follow people inside chat when they're talking.
Yeah. Well,
Yeah.
Dean, you do know that whole term "flat as a pancake" means it isn't very flat.
That's been debunked. That's been debunked.
Yeah, right.
I think a billiard ball's smoother than the Earth.
Yeah, stuff like that.
You mean the Earth is smoother than a billiard ball?
Yeah, I knew it was one of them.
Yeah.
Yeah.
Yeah, one of us isn't lacking sleep right now, so there you go.
Touche.
So I don't believe that he's actually been to those 10 states and verified that.
Got to clue us in that we're all not reading.
Huh?
You gotta let us know what you're talking about because we're not reading.
Sean Becker about the 10 states.
Oh, he said he's been to 10 different states.
They never verify stuff. When do they really?
Exactly, but so that's why I didn't even worry about it. But I mean, the idea that something above sea level can flow down to sea level, that seemed monumental to me that he thought that's a problem. So that's why I was like, you know what I'm saying?
Travel downhill.
But yeah. But you know, I mean, I don't believe he went to those 10 states anyway. And
What
of course,
I'm guessing, I'm gonna take a wild guess and think and go. Is he trying to say north?
he said to the ocean. So I'm just letting him back up his position. I'm starting to get tired of trying to fill in their own gaps in logic for them. I just let them just wallow in their own ignorance and hopefully they can, you know.
Well, they'd have to show evidence or a photo of a water rise, not a waterfall.
You guys can look
to the ocean.
You guys can look that up though. I mean, there is. I haven't been to all 10 states that they're claiming that, but I know that the one for sure that they did was Kansas, and it was a university that surveyed the entire state of Kansas, and they rate a pancake, I think it's 0.996 flatness.
Yeah.
And Kansas was 0.997 or something like that.
Yeah, it was something along those lines. And what you call it? I think MythBusters and a couple other things did it.
Also, Florida, I think, was even flatter than that.
Yeah, I think Florida was the flattest or something like that overall.
Yeah, but how are they using the term flat though?
I'll pull it up right now.
Is
no changes in elevation, probably.
Oh right, yeah, that's cool. That fits.
I would imagine.
Yeah, so it fits the globe perfectly. There's just no change in elevation, which would make it very flat. So there you go.
They say the same thing about the Nullarbor Plain here.
Yeah, I've had arguments with somebody about that one.
Yeah.
How does it not apply to a flat Earth though?
Yeah,
it can do. There is no difference between the two.
Okay, so it's not really much of a proof for a globe, right?
No, but it's what we'd expect to see. So.
Oh, go ahead. I'm sorry, my bad. Trying to find it. Yeah, it says let me see where the number is. Oh, there it is. Oh, no, it's example. Oh, conclusion. There it is. It says, simply put, our results show that Kansas is considerably flatter than a pancake. And here is the little. Oh, they're not going to show me. All right, hang on, I'll show it.
Who cooked the pancake?
Not Uncle Buck. No one knew that reference, really.
How would that same area compare to, say, like the ocean? I wonder.
Well, the ocean should just be flat.
Yeah.
Yeah.
That same size, the state of Kansas, if that was on the ocean, would it be similar? If that makes sense.
No, it'd be a straight line. Don't you know the flat Earth people have used the Google Pro as proof of flat Earth?
They use Google Earth to measure distances. Yeah.
Yeah, it says we were able to estimate that Kansas flatness is approximately 0.9997. Which makes zero sense because I didn't read the rest of it. But I'm
wait a minute. That diagram
And
there
if I
showing
won.
that diagram showing Kansas and a pancake. I think that's just for effect. That's a disingenuous comparison because obviously a pancake has got
Divots.
it's got walls. So obviously anything that's not got walls to build up to a plateau is going to be flatter than a pancake.
That's what I said. Who cooked that pancake?
Yeah, it's ridiculous.
It's an inconsistent way of putting something in perspective. Really, I mean, using a pancake is ridiculous.
I think it's more of a study of a expression.
Yeah,
that's it.
And was it Stingray that started talking about the different states and the flatness? Was that you?
Yeah.
This is why I avoided it because I knew. So look at the conversation we had. Have y'all been paying attention to the conversation? Like
no.
Asked him about that, and he says he knows it's flat. I asked him which 10 states, which ones you verified. He's like, I verified everything but what did he say? Alaska and what's the other one? Can't find the other comment. He verified everything but Alaska and another one. Okay, well, how did you verify it? I've been there. So say what? So you were there and you just suddenly had the flash of understanding that it's flatter than a pancake?
Wait, what were his? Can you name off the list of states he said he's been to?
He said he says he has to look them all up. He doesn't know them all.
Oh, okay.
But he says he's been through all of them except for Alaska and another one.
Oh.
So then I asked him, okay, well, how did you? Oh, he said everything but Louisiana and Alaska. This is at 5:18 on my screen. Everything but Louisiana and Alaska. Ask him, how did you verify this, that it's been flat? I have been there. So just being there, you just suddenly had a flash of understanding that it's flat. This is what he says.
This is like I drove through it and it seemed flat.
Exactly. But look, this is what he says. I says, so just being there, you just suddenly had a flash of understanding that it's flat. This is what he says. I flew to Amsterdam and looked out both windows and saw no curve. This is his response. You know what I'm saying? So I already knew it was going to be a waste of time. Most likely he just read something on some website or some YouTube video.
Yeah.
Well, if he's only looked out 2 windows on a plane.
No, he said Amsterdam. No, he said Amsterdam. He just said
yeah, but when he says he was flying across and looked out both windows and saw no curvature, it took a sample of 2. The plane has got a lot more windows. Maybe it was visible in all the other windows. He just missed it.
But the fact
he should have went up to the cockpit and asked the pilots, could he look out the front?
Yeah.
Oh, you flew over the states? Like you flew over those 10 states, Shawn Becker?
Did you do a grid pattern?
How high do you guys believe that you should be before a noticeable curve should be visible?
With what, naked eye or optic? And if optic, what field of view and focal length?
Very good.
With
that matters.
naked eye, with
22 kilometers.
Yeah, it seems like it, Carl.
Naked eye, 22 kilometers. I would absolutely notice curvature, which is about 78,000 feet, I think.
I can tell you. B-Ball for real did he just got a drone, and he did a video, an upload, and I started taking screenshots, and he said he was at I think it was 220 feet above sea level, and I took a screenshot and I drew the line with my ink press, and there's the noticeable curvature. You can see it.
Oh yeah, if you use tools, Shawn, you can see it at 100 foot. If you want to work out that there's curvature there, you can do it at 100 foot, but that's not naked eye. Naked eye, 22 kilometers.
Yeah.
Using tools, 100 foot, you can do it. 300 foot, you can absolutely do it using tools. But then using a camera, you do need to work out the field of view as to how much curvature you would see, because you're looking for minuscule amounts of curvature, because every flat earther that criticizes the globe model doesn't really understand it. Like saying that the states are flat, therefore it's flat. Great. What did you expect to see on a globe Earth? And how did you verify that it wasn't, given the magnitude of the size? There's just no answer to that, because you have to understand the globe model to be able to criticize it, and they don't.
I understand the globe model.
So
I
how
don't know.
many? So curvature wise, how much would you expect to see laterally at average viewer height, 6 foot, looking out across an ocean?
You mean before objects start disappearing? Or
No,
what?
no, I meant lateral, left to right lateral curvature. How
Oh,
much curvature would you expect to see stood at 6 foot,
Okay, Mies.
looking out over an ocean?
I wouldn't expect to see any.
Okay, cool. What about 100 foot?
I still wouldn't expect to see any. You can be in a plane and not see curve. I mean,
But wait a
although you
minute.
don't-
We
although you
are
don't have
seeing.
a-
Wait a minute. Yeah, we are
you don't
seeing
have a-
curve. We're seeing curve. We're just not noticing it. The human eye, given a 35-degree detailed field of view, will only detect 3 degrees of curvature. That's it. Anything below that, we will dismiss as a straight line almost. It's only definitive at 3 degrees. 3 degrees is 22 kilometers. But even at a few kilometers, you're seeing 0.4 degree, 0. Let's say 2 degrees. So you are seeing it. And that's why you can take a photo of it, compress it, and realize that it's there. Your eyes are seeing it. Your brain isn't perceiving it. There's a big difference.
It's the old pool cue trick thing.
Have you guys seen a video by Life is Short?
Yes. Is it about diffraction limit of light? Hallway.
It's about angular resolution and
Yes.
it's
I've seen
about
that.
all the
Yes.
where he mathematically,
No.
you know, you haven't seen that?
No, I have, but you said he mathematically, and he doesn't actually mathematically do anything that we're not aware of, but then he comes up with some very weird and spurious things. So, for instance, he conducts an experiment that is flawed from the beginning because of his understanding of how light will propagate through glass, given the radius of that glass being significantly different. And I can demonstrate that for you if you want. I could show you
the angle of incident.
Whoop, oh, Jesus, wait a minute. I'm gonna share it and draw.
Have any of you other guys seen that video?
I haven't.
Actually, there's 6 of them actually in the same series. It's pretty interesting. You guys might want to check it out.
So is he talking about angle of attack?
No, it's so it conflates a few things, but I'm just going to share now. So who is it that I'm talking to? Is it Fight the Deception?
Yeah, hang on. Let me get there so I can share it. All right, you're
All right.
beginning.
So you read it. So we've got 3 issues, yeah? 3 issues that absolutely invalidate anything that he can come up with in that experiment. That being someone quite familiar with math and equations, he even gets the equations wrong, actually. He even gets a ratio wrong. Not significantly, but it is. But anyway, so he's comparing not apples to oranges. He's comparing apples to the seed of a grape. That's my analogy. And by that, I mean, he's got one lens that is this big, and this is the DSLR lens. Now, what he does is he lines them both up, center line lenses. And then he's also lining up at the other side an iPhone lens. There we go. And then this is the iPhone lens. Now, is this a fair comparison between 2 things? Absolutely not, just based on this premise alone. So if you imagine that we have light coming from down here, and it's traveling like so. This gets seen in a DSLR. It does not get seen in a tiny iPhone lens unless, lo and behold, we move the iPhone lens up to, what is it, Shawn? The angle of incidence, the incidence line, whereby then it will get shown when you move it up. Awesome. So that's problem number 1. Problem number 2.
And what was the problem with that?
The problem is this red line is light coming in, yeah? So let's call it light from the laser. Let's call it light from an object. It could be anything. This lens here, I'll tell you what, I'll color them so we can see what we're on about. So the green lens is the DSLR lens, yeah? The blue lens, or the wait a minute, let's have a lighter blue. The blue lens is the iPhone lens. The red line is light. Now this red line will be focused to the sensor of the DSLR via that lens, and it'll get recorded. It will not get recorded by the iPhone. Do you understand that?
And the reason for that is what you said?
It's not getting into the lens. We've got two different lens sizes. The
Okay,
entire...
I understand. I
Yeah.
understand that, but if it's obviously closer to the ground, more of that object is going to be obscured at the other end.
Say that statement again.
I think you're talking about two different things here.
Yeah, so what I'm on about here is this is what invalidates the experiment in saying one thing can perceive something, another thing can't perceive something. There is actually another aspect to this. And the other aspect is that the lens element is shaped like that because it takes in light from a field of view and focuses it down to the back of the element, which straightens it out. So we've got a large field of view coming into a narrower field of view, and that's how lens elements work. They control refraction of light. So the issue that we've got here is the field of view. So on the DSLR, we've got a wide field of view as well, which means light coming in at this angle is going to get seen. Light coming in at this angle is going to get seen. On the iPhone, we've got less of a field of view. Or more, it doesn't actually matter. The point is there is a huge difference. Now, are you ready? So that's point number one. The lenses are the wrong sizes, and it's not even a fair comparison. So point number two is sensor. And point number three is, let's say, I'm just going to put the word auto, and then I'll put underneath it AF, EX, and FL. Right, so on one side, on the sensor, on the DSLR, we've got a huge sensor this big. On the iPhone, we've got a sensor this big. What that actually equates to is on the DSLR sensor, we've got and just for the sake of argument, we've got a sensory receptor on it that is actually this big. On the iPhone, it's that big, that dot at the right-hand side. So now it's not as good at determining light. It can't sense light. The other thing that we've got is the iPhone is a crappy iPhone, and I think it was 8 megapixel. And the sensor on the DSLR he used was 21 megapixel. Which now means that if we divide this up into sensor strips that are going to be scan line red when the sensor takes reading, an object that is this tiny across here is actually not going to get red on the iPhone. But because there are more per square area on the DSLR, this is now taking up more of a ratio of 1, 2, and 3, and 4. So it will get registered. So that's a sensor size and sensor interpolation disparity that it's got. But this is the most interesting. Auto, AF, EX, and FL. So the one thing on the DSLR is I control the exposure. I control the f-stop and the timing. I control the focal length. I have complete, utter control. What do I have on the iPhone? Nothing. Great. So now we have to understand how an iPhone works. We've got a sensor and we've got a DSP, digital signal processor, that's reading from the iPhone sensor that's behind the lens. And the lens is looking this way, like so. Now, the AF, what's it doing? Autofocus. So basically, this sensor sends out a pattern. And it quickly determines what's in focus and what isn't. And it's got a weight to it. Now, most AF focus patterns will look like 1 point, 1 point, 1 point, like this. Now, when the iPhone is low, the ground is taking up this much. Sorry, wait a minute. The ground is taking up this much, which means all of those autofocus points are actually on the ground, not at that far wall, which would be here. So now, anything that's outside of that focal range has a chance to be blurred or not even registered, coupled with the compound effects of the sensor size as well, and interpolation of the sensor. But now when he lifts it up, this ground goes down to here, which means now the bias of the autofocus is here on the wall. So now it can actually change focal length and focus on the end of the hallway a little bit better. It doesn't matter whether it absolutely focuses or doesn't. The fact it's not taken into consideration or considered is the problem. Now, the other thing is this, exposure. You do not get a chance to alter either the aperture or the timing on the iPhone. You do on the DSLR. So now this image on the iPhone runs through the digital signal processing chip to an image processor, and the image processor decides what the exposure is, which is the aperture and time. Now it uses a similar, it's not a focus pattern like this, but it uses a sample pattern, I think, on an iPhone like this. It's not a great deal because of the processing power, but it works out the exposure compensation based on sampling points on how it needs to alter aperture and time. The DSLR doesn't, it's fixed. So now the iPhone has the ability to be able to you know, auto level, auto color balance, and auto expose. So when you lift it up based on these sample points, more of them hitting the end wall, it's going to bias towards the end wall. So even in color processing, it's going to say, hell, I'm going to pay more attention to this end wall than I am the floor now. This is not something that happens with the DSLR. So it is a dishonest test to me, or a blatantly misinterpreted results because of these three elements alone. And I'm not even a professional photographer at this stage, and I can tell you that this is wrong.
Why is the camera angled towards the floor?
It doesn't matter. This could be pointed that way and it could be straight. Doesn't matter. The field of view would actually hit the floor. But if you look, his was actually the iPhone camera was leveled about like so on the floor, and then when he lifted it up, which is like this version, the floor was like here. So you do get that bias and change. But these sample points for the focus and these sample points here will bias anything close anyway. If you look, the image processor and the DSP will always bias because the algorithms say if something's close up, that's probably what you're wanting to take a photo of based on the surface area that it's covering. So the auto exposure, auto color balance, auto leveling, and auto focus points will always kind of bias in a weighted sense things that are closer, because most people take damn selfies and pictures of people with mass amounts of background in.
So if you take that same iPhone and bring it closer to the object, say it was a flashlight at the end of a long hallway, or I saw one where they did it inside of a Walmart or something, I don't know, but
yeah.
So or let's put ourselves in Kansas, okay? And someone that goes away from your, or you know, they're a car driving away on a highway. How far away before you think it's gonna? Which way should it disappear first? Obviously, it's gonna disappear bottom up because
no. Wait a minute. Stop.
The Earth is there.
No, stop.
Yeah.
Nothing ever disappears in a geometric fashion from the bottom up if you are above the floor. That is basic reality and geometry 101. So if you look at my screen right now,
it'd be good to remember that it can't work, because that would be the same thing as a rocket shooting into the sky disappearing bottom up. It makes no sense.
Yeah, so it's really easy to invalidate. We can invalidate it really easily because all we have to do is come up with a relationship. Yeah, I've got an object here. The hypothesis is that it will disappear from the bottom up, starting at this section. Yeah, I've got an observer over here that's looking in this direction. They are looking straight along here. Why is this bottom bit, which I'll just piss around in red, why is that disappearing? Let's try and logically come up with an answer.
Okay. Just like in your diagram you drew a minute ago with the camera that was facing down towards the earth, kinda. Okay.
So wait a minute. So what you want to do?
You can see more. You can see more.
Wait a minute. Let me just do that. Let's do it one step at a time. So what you're on about here is
you can see more surface area. You know, the higher you are on a flat surface, the more surface area you're going to be able to see. So you're going to be able to see, you know.
Now, are you ready? No. Let's say not higher, not lower. Let's work out this example. So the hypothesis is this: I'm looking at this area here, and I cannot see it. This is my field of view. I can see all of the blue, but I cannot see, for some reason, the red part of this object. But I can see the blue part of this object. Why might that be?
Yeah, there's a lot of different reasons. For one
Give
thing,
me the one where the magnitude of the effect is greatest, and let's deal with that.
I'm going to say atmospheric conditions.
So atmospheric conditions, define that first. Let's say what are atmospheric conditions.
Yeah, you could be at sea level and it's going to be worse.
So atmospheric conditions, you mean particulates in the air that cause kind of a hazing?
That's one thing.
Right. Okay. So
moisture
is that?
In there,
wait a minute. Stop. Yep. So does that? Yep. Wait a minute. So does that bias? Why does that bias the bottom of this object? Given that the distance between me and the top and me and the bottom is probably 0.00001%. And why is it an apparent effect with a termination line? Why is it not linearly all the way up the object? In other words, it would be faded at the bottom, but visible at the top, and it would gradually get more visible at the top. So why is atmosphere coming into this here then, when this is not what we see? Do you understand what I've just explained?
What do you? We see it all the time. What are you talking about?
We do on the ocean when the ocean is curved.
You see it out in the desert.
Oh, so what you're on about now is mirage effects, yes?
Well, yeah, there's all kinds of mirages.
No, that's awesome. So mirage effects, let's go back. So do you know how mirage effects work? Or what is a mirage? Or what's actually happening?
Yeah, temperature. It has to do with the temperature and the,
not what causes it. I meant, not what causes it. I meant what's happening.
In my opinion, I think you're seeing horizontally through a layer of thick gas because the heaviest gases are closest to the earth. Okay. And so you're looking through literally, however far of a liquid, atmospheric layer that you're looking through. It's like looking through a piece of glass,
So you're saying distance relates to seeing a mirage?
Well, not necessarily. No. You can see a mirage in a short distance too. But all I'm saying is the mirage happens, from the bottom up.
But wait a minute. What about so let's just
a big reason.
Let's just cover the first assertion, and that's that heavier gases are at the bottom. So the atmosphere consists of nitrogen, oxygen, and argon, and other gases.
Mhm.
And they don't separate. That is what we call the atmosphere. So we have the we don't have the heaviest of them at the bottom, and then we don't have oxygen midway, I guess, and argon right at the bottom, and then nitrogen in the middle, I guess. We don't have that. It's all a mixture. So it's just air, an atmosphere. That's what we'll call it. Now there is a pressure gradient that goes down.
So you're saying heavier gases don't don't
not given
lower.
not given the effects in what we call the atmosphere. If in a controlled environment with no other outside forces such as wind currents, it's easier to mix them, put it that way, and keep them mixed in our atmosphere. Otherwise, we'd be breathing argon. I'm pretty sure argon's the heavier of all the gases in the atmosphere, right?
So if I pop a balloon, what happens to the helium? It just mixes in and stays down here. That's what you're saying?
No, helium is incredibly is different to nitrogen, oxygen, and argon, and carbon dioxide.
But all the ones you're describing have similar.
The mix. The mixture of them and how they're bound together and mix. Yeah, the turbulence of weather patterns and air currents and all kinds of things. I don't claim to know it entirely, but it stays in a general pattern. Otherwise, like I say, well, just do you believe that we're breathing argon right now? Because argon is responsible for 1% of our atmosphere, which would cover the ground.
I don't.
And I think argon is the heavier gas. I might be wrong, actually. Might be carbon dioxide. Damn it! I'm gonna have a look at this now.
Which one's the heaviest? You said.
Yeah, I'm trying to think. I thought it was argon.
Sulfur hexafluoride is pretty.
No,
heavy.
I don't. No, I meant that makes up our atmosphere. That might be the case if we were near a thermal vent, but
I think
not.
It's mostly nitrogen.
I thought argon was heavier. Wait a minute.
Yeah, I'm googling it now.
Yeah.
Damn. Pretty sure nitrogen is. There's more nitrogen than there. I think there's only like 12% oxygen, or.
Well, conservatively, there's 20 to 23% oxygen content, 75 to 80% nitrogen, and then the rest is like 1% argon, and then something else. But anyway, going back to this example, because the idea was what is a mirage effect, and a mirage effect is quite simply this: is because of a pressure gradient and possibly heat differentials that cause different densities in air pockets, the lines from this actually bend up to our eye. Whereas looking above, it doesn't bend as much. And then inferior mirages are pretty awesome because what they start to do is bend so much that they come in at the top. So this is the pattern of light that's coming in. So yes, you can have something that is messing up the bottom of an object. I will give you that. But are you ready? Here is the killer fact that no one's ever got round.
Your diagram is the exact opposite of what they say. Like the guy that did the Chicago skyline, the news guy. His diagram had I'm pretty sure, I could be wrong about that, but I'm pretty sure it was bending it up in an arc, supposedly.
Actually, wait a minute. Yes, I'm sorry. I'm doing this on a flat plane at the moment. So if I were to put it on an arc like that, all of these would be inversed and go around. But I'm trying to give you the benefit of the doubt at the moment. So this is what refraction does. But I'm just showing, if we want a straight line, how this image would get assembled. This isn't the way I think it works. I think it works on an arc like this. So anyway, and obviously all of these would be bent accordingly. But this is how the vectors of these lights intersect and change, which is why this object looks very different when it reaches my eye. But what everybody fails to understand is this object has also done this. It's moved down. So it's not that the red part here is now, inversed or messed up or blurred or looks like a watery mess because of shimmering effects of refraction. It's hidden here and it's moved down.
Okay, think about this for a minute. If you drive on imagine you're looking down a straight road that has telephone poles right
Mhm.
as far as you could see. Say we're in Kansas again, okay? And if you look up, there's a street light directly above your head.
Wait a minute.
And
You're going to describe to me perspective.
Just wait. Okay.
Yeah, but
exactly.
Yeah, the thing is, I'm a 3D
They're
artist, so I
getting
absolutely know what perspective
closer.
is.
They're getting closer to the horizon.
Right, stop right there. Stop right there. I know it.
Quit
I'm really sorry.
interrupting me.
I know exactly what you're going to say. I'm going to draw it for you. I am going to draw it for you. And it isn't that I'm just trying to be expedient with time here because I've got to make a business call in a second.
So how do you not believe that eventually there's going to be a point where they're going to intersect visually?
No, they'll get to a vanishing point, correct. They will not be obscured partially, ever. So are you ready? No, this is geometric law. This is actually the law of perspective. Parallel lines will only ever converge, they will never diverge. That is a geometric law and a law of perspective. And I'm going to draw you this perspective diagram right now. So we've got observer A here looking at these 4 blue lines, and we've got a red line here as the ground. Now the ground actually does this all the way across, and this is our perceptual horizon. Now, these blue lines here start out like so, then start out like so, then go like so, and then go like so. That is perspective. That's just what's happening. What will never happen, ever, is any of these, which we'll call 1, 2, 3, and 4, and this is 4 in the distance, 4 will never get partially obscured from the bottom up due to perspective. It is a geometric impossibility. And I'm sorry that someone's told you that it isn't. You've got a 16-year graphics artist that understands 3D and has programmed 3D stuff telling you that that is absolutely impossible in reality. If this was possible in reality, it will be the world's biggest phenomenon because it contradicts everything that we see and everything that we can predict. Now, the only examples that a flat earther ever comes up with to combat this is when things go over a curve. So the boat's here, the observer's here looking this way, and we can now only see that much of it. Or they move the observer down below the table or something. In which case, yes, obviously, your angle of seeing things now is like this. So things will disappear from the bottom first. That's just geometric law.
If you're looking down a long hallway, you can't see all the way to the other end sometimes.
Yeah, that's just
You're
angle
saying
of
that's curvature?
No. I'm talking here about things disappearing from the bottom first. That is completely independent to angular size. Angular size is not things disappearing from the bottom up.
But visually, that's how it works, though.
Yes, except angular size has got nothing to do with things disappearing from the bottom up. Angular size uniformly makes things smaller until we cannot resolve them. It doesn't think, hey, I'm going to fuck with this object from the bottom before I fuck with it from the top. That is impossible and implausible.
Okay, visually, all those lines meet up in the very middle, the very center.
Sorry, say that again.
If you're looking down a long hallway, okay, and you can't see to the other end of it, that's not because of curvature. right?
No, correct. That's angular
and
size.
and visually to our vision, the thing, all the the lights, the hall lights, and the doors and everything, as they,
Wait a minute. Don't get me wrong. You're arguing a point that I agree with you on, so I think we ought to stop arguing on this. No, wait a minute.
Well,
look. No, look.
you're
This, I'm
trying
going to
to
take it
tell
down
me.
to nothing.
Why
Look,
are you keep interrupting?
Nothing.
Why are you keep
Nothing.
interrupting me?
No, I'm agreeing with you, but it's got nothing to do with things disappearing from the bottom up. So yes,
then why can't you see to the other end of the hallway?
Angular size.
What?
Number 4 will have got so small that I can no longer see it. But at the point of me being able to see it, I will see all of it.
Yeah,
that's angular size reduction.
The hallway is flat, and
it doesn't matter whether it doesn't matter. Flatness has got nothing to do with it. Flatness has got nothing to do with it. It's angular size.
Results.
Can you tell me why angular size has got anything to do with biasing the bottom of an object? Yes or no? Why does it favor the bottom of an object?
Because that's the only physical object that would be able to. I mean,
wait a minute. We zoom in to ships, right? And we can see huge ships that are obscured. That's to say we have a horizon line here and we have the hull of a ship that's almost missing most of it. That was terrible English there. But almost missing, huge sections of it below the water. Now, angular size is the amount, is the angles between the top here, the bottom here, and you can also have it this way as well. And it's measured in arc seconds, or it's measured in degrees based on field of view. Doesn't matter. The point is, why am I missing this if I can see the top? It's impossible.
Oh man. Well, we can see like bodies of land that are.
That's not what I'm on about. I'm on about this boat now. Why can I no longer see the hull of this boat?
The boat is in the water, and the water undulates. It's not. I mean.
Okay, so wait a minute. Let's deal with another perspective law here, and this perspective law is awesome because are you ready? Look at this. So we've got an ocean, and we're going to look out across this ocean. I'm going to say that, and this is a law of perspective. Now we've got a ship here. Actually, this doesn't look like a ship, so let's have that. We're looking
There's a lot of reasons, but I mean.
Wait a minute. We're looking front on from the ship, by the way. Now we've got an observer that's hit here.
Why don't you want to address objects that don't move? There's not so many variables, like land.
Well, because cameras allow us to freeze moments in time, thus making the object not move. So there is no difference. So if we look at this ship now, and we've got a field of view like this, and we can see all the way to this ship. Now, if there is a wave here that is lower than this parallel line to the ship, so we've got two parallel lines, this wave height, if it is lower than that vision, the maximum amount that it can ever cover of that vessel is its own height when it's next to it. That's it. There is no other there's no other argument here. These are the laws of perspective of parallel lines. If the wave was higher, then yes. Oh, wait a minute. I've just got to nip to the front door.
I mean, basically all the pictures that I've seen pretty much have waves and all kinds of stuff going on.
Oh no, the laws have waves, but this law that I'm showing you right now is law. The wave that's higher than the vision line will cause obstruction closer, but the further it goes away, I will now be able to see this part of the object. This is just what perspective is. This is all perspective is. Now, if you guys wanted to prove flat Earth, you would just have to explain one thing.
How do things converge into disappearing in a hallway that's flat?
Just angular size. Angular size. Distance. Angular size is derived from perspective, and it's something that is incredibly well understood. But angular size uniformly makes things smaller. It does not favor left to right or up to down or the bottom of an object or the top of an object. It really does not.
I disagree with that.
You don't have to agree. You are just plain wrong.
Well, you know, he's charted it out mathematically, and it's comes to within what, like 20 miles of the globe math for the circumference of the Earth.
Who has?
You must not have seen the video I'm talking about, huh?
The life is short diffraction limit of lenses, yes, I did. And that was the one that I was describing that's got many flaws when he did an experiment at the tunnel. If there's another one that you're talking about, then I don't know.
No, that's not the one I'm talking about.
All right, yeah, no, I've not seen the other one. I just watched. Yeah, that's terrible.
I thought you said you saw it.
No, the one with the hallway, and that's what was on about with the iPhone lens versus the DSLR when he's on about diffraction limits of optics and things that he got wrong. So here's the thing. Do you want to prove flat Earth? Because this is really easy. Flat Earth is incredibly simple to prove. Do you want a foolproof way to prove it? So, do you accept the laws of parallel lines? Yeah. If we have two parallel lines that are equidistant, they will always be in physical reality the same distance, and they can never diverge. So underneath, I'm going to draw the perspective version of this. They can never diverge. They will only ever converge. In other words, they cannot do this. Oops, that's a bit wrong.
You mean crossover or?
Yeah, so this is convergence coming together. Divergence is if they carried on and went like this.
Yeah.
So these two lines, A and B, which I'll label A, oops, it's a terrible A and B, that are parallel, can never diverge, as in that. They will only ever converge to a vanishing point.
Like railway.
They will always maintain the same distance going away, or relational distance to each other, and that's it.
Okay.
Now, all you need to do to prove flat Earth is this, and this is really simple. I don't get why people don't do it. Let's take an ocean, and let's get survey data for a boat. This boat, we need to know its draft, and it's based on its weight, and then we need to know its deck levels and the highest part of it. Yeah. So let's say that the highest part is 100 foot. Yeah. Now all we need to do is find an observer height that puts us at 100 foot. That's it. 100 foot. And we need to look at the top of that. And then we need to record this going away. Now, based on the laws of parallel lines on a flat surface, this top section here, which is the center point of our view, which we'll call point A, will never ever leave that line, ever. Because when we're looking at it in a perspective view, and I'll draw the perspective view down here, our center focal point line here, when the ship is close, the stack is here like so. When the ship is further away, the stack is here like so. Or when it's further away even further, it's going like this. And it's getting smaller towards the vanishing point, which is the center point of A. Now this stack, point A, will never leave that line. If any flat earther does this, they win the argument. Just film that ship going away. But what you will find in reality is that this doesn't happen. It doesn't stay on that line. At some point, it starts getting lower than that line and lower than that line till it gets obscured by the ocean. That is impossible on a flat surface and only possible if it's a curve?
Block for block used to
Well, the
what
farthest
you
it
see
can,
down the bottom.
the
You mean
farthest it can,
I haven't
the,
heard
f-
what happened to him.
the farthest the line
Fell
can
off
go
the
down
edge.
is.
Yeah.
But the problem is the farthest that the observer could look down is the horizon.
No.
Mm.
We can zoom in at things that are over the horizon, obscured by the bottom, obscured on the bottom by the ocean. The ocean is, the curve presents us with the horizon, unless there's extreme atmospheric densities involved, like fog or something like that. Our horizon is always the curve, because the horizon also, the distance to the horizon, matches exactly what we would expect to see on a curve based on our elevation. If we go up higher, we can work out how far the horizon is away and test it. It's really simple. And it matches the curve perfectly of 1 degree per 69 normal miles or 60 nautical miles or 110 kilometers or whatever. Oh my God, I remembered that. That was awesome.
The thing is your observer there, if it's looking at point A, okay, the point A is going to constantly be changing from when it leaves shore to when it meets the horizon. The observer would be constantly having to tilt their head down just a little bit.
These are the laws of parallel lines. They don't do that.
Not if you're on a flat Earth, you wouldn't.
Yeah. So on a flat Earth, these two parallel lines will always converge, never diverge, and that center line is always going to be the center line. If something sits on it close up and moves exactly parallel to that line, intersecting that line, it will never diverge from that line. That is just the law of perspective. If it's moving the same, if it's moving directly away from you, it will never leave that line. Plain and simple.
Like I've never seen railway tracks cross over.
So it's really easy just to prove flat Earth. I don't know why people haven't done it yet.
But visually they do cross over.
No, they don't cross. Parallel lines never cross.
Visually to your vision, yeah, they meet.
They meet. That's converge. Correct.
Converge,
they never.
yes.
Thanks, Monkey Sage. I appreciate
That's
that, man.
exactly what I'm talking about.
All right, yeah, they will converge. So you see point A here. You see point A here. It will converge. Except I promise you this: you will always be able to see it until it drops below the horizon. It will not disappear due to angular size, and it will move away from that parallel line that it should have kept with. That is my assertion. And the only reason I can make that assertion is it's traveling on a curve. It's not traveling on a flat surface. And this is just so easy for anybody to demonstrate me wrong. But this is just what happens.
What about if we're going to cover that? You can also cover why do we see the horizon line at the set distance that we see it, and yet we can still see it. We'd still see a ship if it was a flat Earth. We'd still actually see a ship further past the horizon if the Earth was flat.
Well, we do though. We see ships that are well past the horizon.
Yes, but you don't need to see the whole ship.
Oh, wait a minute, Terry. Wait a minute. Terry, look at that. That's the one that I did for bandsaw.
Oh yeah, we're working out the
leveling. Yeah.
Yeah.
I just look into it. Oh yeah, no, I've looked at. Oh, right. So here's another. Yeah. So I've actually done this diagram before.
Did you hear?
75 foot.
Yeah.
If you able to simplify that, Dean? What I was saying about the horizon line, because people say you can don't see forever or something, but we see horizon line when we look.
Why don't you go to the life is short, or actually you can go to my channel. There's a playlist called Angular Resolution. There's 6 videos.
Wait a minute. Very, very importantly, angular resolution. No one has got a problem with. I can explain to you exactly what angular resolution is. I can tell you it as well.
Listen, that's what I named it. Okay, it wasn't.
No, there is a thing called
I wasn't being.
angular resolution.
Okay, well, this has to do with angular resolution. It's a playlist on my channel that I just, wrote a quick name for. All right,
Yeah.
but don't let the name do misjustice. There's 6 videos in there, and he explains both. He explains how it works in your world and how it works in our world. Okay. He explains both, both versions of how perspective is working.
There's only one version of perspective. There's not multiple.
Okay. Well, why don't you?
No, I say that. I say that with authority. I absolutely do say that with authority. I can actually draw isometric drawings, then use calculations to convert them into a perspective. I can do view frustum matrix alterations on a camera to actually create a 2D scene from a 3D. This is not something that I'm idly mentioning because I watched a YouTube video.
This is not just a Jude. Why are you judging the video before you've even seen it?
No, I'm not. I'm just saying I don't. I'm just saying, in this field, I'm an instructor in this field. So it's not that I'm too egocentrical to look at a video. It's just that every video that I looked at that tries to argue for flat Earth is nonsensical and not based in reality. I will humor you and watch yours, but it's just most of the time it's just an impossibility. I'm just going to show you. I'm going to show you this right now, and then I'm going to have to go and get on with some work because I'm going to make some business calls.
It's probably
have a look.
Best
have a look at this.
I've seen.
Have a look at this. Can you see the Hunagayan spirit here? So this ship on the right. Yeah. Can we see this?
I don't know if that's a ship or not, but
it is actually a ship, and you can look up the details. You can look up the plot point course on it. You can get its weight, and you can get the deck heights. It's actually got 8. It's actually got 8 decks above the main load deck, and we can see 7 of those 8 decks. We're missing 1 interim deck and the main deck of the ship hull, and we're seeing the securing cranes.
You sure it's not sinking, that other ship?
100% positive. Now here's an interesting thing.
And what's the distance?
9.9 nautical miles.
Oh, okay, I see that now. Well, if ships are disappearing in 9 miles, then why can we see land that's 40, 50 miles away? That
because land is 2 reasons for that.
I'm talking about over water.
Yeah. Land can be a lot higher than the height of this ship. This ship is 100. This ship is 100. Wait a minute.
No. Wait a minute. But it's not. The land, can be. There's.
Are you ready? I can tell you why. There's 2 reasons. One, A, the land is a lot higher than the ship, and it's been misidentified. Wait a minute. Stop. Or B,
it's been misidentified.
There is refraction happening there that is causing light to bend. Now, I can guarantee you that if B is the case and it's extreme and we wouldn't expect to see it, then we can also tell that what we're looking at isn't. Let me just finish. We can tell that what we're looking at wouldn't be reality. Do you know how we can tell it's not reality? Is because all the straight lines on it will be wavy and bendy. And it's that simple. If you look at this ship now, I can rule out massive atmospheric refraction because I can see straight lines on it. I can see straight lines on those arresting cables on the Hunagayan Spirit. I can see straight lines up to the pilot house and the wings that come out from the pilot house that someone told me what they are, but I've bloody forgot now. And the weird thing is, and this must be coincidence really, the 53 foot that's hidden purports exactly to the observer height and calculations on a curve. It's a bit weird that, isn't it, how this always matches exactly.
I bet it does. Did you take the picture?
No, this was on Metabunk. I'll link you to it and the details and the survey data if you want.
Man.
Is there any other information like viewer height and all that?
Yeah,
sort of-
yeah. It was.
Have you guys seen Dr. John D? Videos that he's been making?
Yeah, and he's been debunked as well by misidentifying stuff.
Misidentified stuff?
Yeah, the long observation that he did on the south coast of where I live, England, he misidentified terribly some things. And the atmospheric refraction is actually what you'd see, and he's actually stood quite a way up from the ocean as well. I know that. I used to work in Brighton, which is, and I used to walk on that beach.
He shows all the footage. He's right on the beach.
Yeah, no, he's on the beach, but the beach is about 30 foot higher than the water. I know because I've had barbecues there. It's that simple.
Yeah, the tidal heights change a lot over there.
Oh, I understand. I understand that, but no, this is times when there's water. The water's. I mean, it's not right up to him, but
I think the problem here is you're looking for
30 feet.
You're looking for confirmation bias. Can you explain why I'm missing a huge portion of this ship at the moment?
Dude, I don't know where this is. 9.9 miles, dude. You're crazy. You could see way farther than that.
No, I'm not saying we can't see that far. I can see a lot farther than that.
Then I don't know what you're trying to prove with this.
I am missing the hull of this ship. I'm missing 53.
Miles.
I'm missing 53 foot of this ship. Where is it?
In 9 miles?
Yep, 53 foot exactly, or near enough, give or take a couple of foot. Where is it? Is it sinking?
A fight the deception. You'd have to show me something that a piece of land with an elevation of 53 feet that you could see from so much further. Because I get what you're saying. The difference is that 53 foot tall boat, that's what you see at 9 miles. We can see further, but when you see further, you're seeing mountains thousands of feet tall.
No,
yeah, this ship is 120 odd foot high, and we're missing 53 foot of it.
I'm saying over water. We can see. How can if there's?
I'd have to see the image. I'd have to see this image that you.
Yeah, give us an image and we'll look at it.
Yeah.
Just link an image and let's have a look at it now.
I'm on my phone.
I've got an image you can look at.
Yeah, go for it.
Hey, no porn. We're talking about land.
Yeah, I'm talking about over water, but okay. How about you just go to my channel, and there's a video called it's called Bro, Do You Even Perspective?
Anyone got a link for that?
Oops.
Find it. Oh, you're doing that?
I'm doing that right now.
Okay. You're awake, Sean. Sorry, I didn't mean to wake you up.
No, I'm good. I've been doing some research and stuff.
Okay.
I'm just going to have to bow out of this for a second because I've got to make some work calls because I'm actually working while I'm doing this. I shall be back shortly.
Well, we'll get all this ready, and when you get back, we'll have it all ready for you.
Or just carry on without me.
You're presenting true.
Yeah, so can you see this is the turning torso building? I think it's in Sweden or somewhere. So you can see on here, he's given all the information down the bottom. So he gives viewer height, the distance, and the segments. You can see he's segmented the building. So you look at the first height, he's 25, let's use miles, 15.5 miles away.
No, our avatars are blocking half of the bloody info.
Yeah.
Bug.
I can't do anything about it.
No, sorry.
Maybe I can.
Fight the Deception. What was the name of that video again?
It's called Bro, Do You Even Perspective?
Okay, I see it.
If I make it smaller.
It's probably mistitled.
Can you see that now?
Yeah, I can see it.
Go one more again. You're nearly there. Can you go up?
Difference is it?
You can't go up, can you?
Can't go up.
No. And you just have to go smaller like you were just doing. That's all you can do.
Still not going up.
There. Oh,
This is one of the reasons I'm going to start using
there.
the Google Meets, because you can. This isn't a problem in Google Meets.
Okay.
So even in these, you look at the first height. The viewer height is 12.1 feet. He's 15.5 miles away. Right? You can see how much in A. You can see how much building C. If you go to B, he's now 17.6 miles away. And you can see the bottom starting to disappear. The next C is 21.6 miles away, viewer height of 9.5 feet. You can see more of the building disappear. And it continues all the way across. He's got a video of that, and you can easily find that in YouTube. Just type in turning torso. But nothing on a flat Earth would explain why the bottom, or so much of the bottom, is disappearing, considering that the building is 190 meters tall. So where is the bottom of the building?
It's still there, but just can't see it.
We can't see it because of the curve of the Earth. But on a flat Earth, how would you explain that much of the building disappearing?
Interesting question.
Can't really see the picture now, but it's just popping up with everyone's icon.
Yeah, probably hard to see on a phone, but it.
Okay, I see it now. Let's see.
When he's 39.8 miles away, virtually half the building has disappeared.
Okay, so what are the distances again? I can't see the distances there. What's the distance on A?
A is 15.5 miles.
15 miles.
And I'm going to.
Too bad it wasn't only 10 miles, and we could see how many feet is missing from this one compared to.
Yeah, you can virtually,
the one he showed.
Well, the observer height is 12.1 feet, so he's virtually seeing the bottom of the building there.
No, I understand. I'm talking about. Never mind. I was talking about comparing it to the numbers that I don't know who I was even talking to.
Oh, Dean, with the vote.
Yeah, the boat guy.
Oh, okay, you'd have to. Okay, you want a comparison? Okay.
No, I was just saying, because this is the problem. The problem is it's inconsistent. Okay, like you're showing these pictures here. Now I can show ones that are that goes against what this is saying, and then there's ones so it's not consistent. It's not.
But in those, do they give you all the information? Like if you go to the video,
raw video footage.
Right, raw video. But do they give you all the information? Do they give you the view, observer height, the distance, everything else, as well as when you look at this video?
Oh yeah.
If you look at this video, he sends links in and he tells you exactly what the tide heights were, exactly what the temperature was, weather conditions. So he's covered everything, but nothing can explain that much of the building disappearing.
Whose video is it?
Let me find it.
Is it Wolfie's?
No, it's not Wolfie's. Turning torso.
Anyway, I mean, there's all kinds of reasons that could be happening. I mean,
I could make up a lot of reasons too.
Oh, I'm not making any up. I mean, I know for a fact that as you get farther away from something, it gets smaller and closer to the horizon. Period.
Yeah, it gets smaller. But as in the boat before, you could see the full width of the boat. It wasn't getting too small to see. You could see the full width of the boat from stern to bow. What was missing was the bottom. Now, when you're talking about vanishing point, the whole boat is going to get smaller, including left to right.
Yeah, it'd be a tugboat nearly by that size.
Right, but the bottom's disappearing, not from side to side. You can see the whole bow. You can see the stern.
Yeah, the cargo.
Same with the building here. You can see the full width of the building.
You guys should check out the video on my channel. I mean, he can explain it a lot better than I can,
But would they explain why you don't see the compression?
dude, he explains a lot, man. And he explains both. He explains two different versions. The version that's, you know.
Yeah, but I've never heard anyone explain, unless he's the first to explain, why doesn't it compress left to right?
That's how vanishing point works. It doesn't just go from top to bottom. It goes all directions. Can you see what's on the screen now?
Yeah, I see it.
Right. So if you look at, I can't change.
Dude,
Sean,
if you try to show me fucking,
yeah, he's presenting.
If you try to show me fucking,
Yeah, I've got to redo that.
The reality is not reality though.
Why?
Your picture, because it's not. You can see all the way across the whole thing. You can see if you go.
Well,
to the
if you have a look at the image there, have a look at the flat Earth model.
Go ahead and look at the footage that was taken all the way across the whole entire thing. You can see cars on the other
well,
side
I'm showing you what you can see. The bottom there is the photo, and the top left you can see what it would look like on a flat Earth model.
It does. There's pictures just like that.
I've never seen one like that.
Oh,
I have never seen the top left picture there.
No.
On Earth, what I've seen is what you can see on the right, the sphere Earth model, and the actual photo reality down the bottom.
Yeah.
I know. I could find a bunch of pictures that.
That was a while ago. That one was done. That picture.
I can show you.
Yeah, it's a long time ago.
I can show you a bunch of pictures of the one on the left.
Well, if you can show an actual picture or photo taken of similar to those.
That was an awesome example with the reality flat Earth versus sphere Earth, by the way.
Oh, you got it right at the end.
Yeah, except there's one thing I'd add to that.
If you look at the bridge, it goes across.
Well, Positron Bridge.
What's that?
No, wait a minute. There's one thing that I just want to add to this.
There's another thing too. All those lines aren't in a perfectly straight line. Okay.
No, yes, they are.
Perfectly straight.
If I got a ruler out and I checked that, I can do that. They look pretty dead straight to me, unless my ruler's crooked. But I got
no, they are straight. But here's another interesting thing. What would be good if someone? What would be good here is if someone actually came up with a reality photo for the flat Earth based on the flat Earth model, given atmospheric refraction, because what you would actually see slightly, even with standard atmospheric refraction, all the way up to severe, you would see those bending upwards in the distance, because that's the nature of how refraction works. So it wouldn't actually just be flat; it'd be slightly curved up.
Yeah.
Oh man. You just use refraction for whatever you want.
Oh, refraction is a thing. We all use it to see if we're wearing glasses, so it's something that we pretty well understand and use on a daily basis.
And also on a flat Earth reality, if you were seeing the vanishing point like on that image, that vanishing point wouldn't have a distinctive line like the horizon does.
Do you guys know
it'd just be a blurred image for the distance that'd be.
Do you guys know how far of a distance that is of those power lines?
What's it, 6 miles or something?
You think
I
they're gonna
don't
see curve?
know,
You
but
think you see curve in 6 miles or 9 miles?
Now, wait a minute, just so that you understand this, we see curve in
That-
1 centimeter. We just don't perceive it. It's only over longer distances, depth-wise, that we see it. We see the effects of the curve. We don't actually see the curve. That there is bending a fraction of a degree away from us. We only see it based on, we only see it because it's obscuring things. We don't actually perceive that there's curvature there because it's such a fraction of a degree. 1 degree is 69 miles. Wrap your head around that.
I already know, dude.
We see the effects of 0.05 degrees of curvature. That's what we see.
Why can't you share the video I was talking about?
The video that you're talking about?
Yeah.
so can you see what's on the screen now?
You don't even know the argument that you're trying to argue against.
I if I play the
It's not the one. It's not the video. It's not my video.
Yeah, that's what I'm worried about.
Oh no,
If
no,
you're
I was
talking
just gonna
about-
say because if I play a video, you guys won't be able to hear it. I'd have to play it over my loudspeakers, and I can't do that right now because it's late here. But
Won't you get a copyright strike if you play audio?
Yeah, that's what I was worried about.
No, I don't think so.
It's not It's not copyrighted.
Is any of us able to play it, Sean, in the same way?
You don't even. You can look at the pictures. You can look at the pictures too, but he's explaining it in a.
Is it
Yeah.
the is it the one that you on your
Pictures
channel fight?
It's called. There's a playlist called Angular Resolution. Okay, it's a misnomer. It's not. You know. I just named it real quick, and
I see it.
And I never changed it. Okay.
It's hard to
But
explain something unless you've got
This guy goes through all the math. He goes through all the math.
Well, we
you
don't
know.
need to hear it. We can read math.
Yeah, I mean, these are long.
It is. That's what I'm saying. Is it's not something we can go through on this show.
I'll share the link though to the playlist.
But yeah.
We'd
take
have to
a look
pull
at
out
it.
all the maths part of it, and then.
Do you understand the maths part of it, Deception?
Not all of it. I'll admit, not all of it.
So, can you verify
really
yourself that it's true? Or is it just the fact that it uses maths that makes you believe that it's absolutely true?
All I'm saying is check it out. I mean,
No, I'll check it out. But I'm saying, why do you believe it to be true if you can't understand all of it?
Go ahead and debunk it.
No, I'm asking for your opinion, not whether I can debunk it or not. And I'm asking for the reason of you believing what you believe off that video.
Just because from my experience and all the things that I have learned, and I mean.
So it could prove a globe Earth then, the video, for all we know.
Yeah, I could, sure, if you think so. I mean, he goes through all the math of the globe model too.
I've got a question. I've got a question for you. Do you and sorry for us being short earlier. I've got a headache and I'm trying to get rid of my headache. Do you believe in a local sun and moon?
Yeah.
How far away do you think the sun or the moon is?
I don't really try to speculate on distances to something that
So
no one's been to. No one really knows. I mean,
well, people have been to the moon, and we can radio range the moon. You know that, right?
Nobody's been to the moon, and I'm not.
Just guys, just a point here too. Sean might want to go to sleep at some point.
Yeah.
You guys are good for right now. I'm gonna power through for right now. I
I think
think what I'll do is I'll wait until
So-
like Arwen or somebody goes
What is
live or something.
25, 4:30 for you?
Yeah,
Yeah.
it's 4:30 right now.
God almighty.
I'm good. I got my third win about 20 minutes ago. I'm good.
Well, I put up with Flat Earth Aussie Jesus till 5:30 odd one morning on Discord, so I think you can handle it for another half hour.
I think so. I'll be all right. Don't worry about me. I'm good. You guys
I
just
thought you're in
Just
I thought you're in
checking.
California,
yeah, I am.
and you're saying it's 5:30 there.
No, 4:30.
4:30.
Yeah.
It's 4:30 in California.
Yeah. I promise I'm not lying.
Oh yeah. Like it's 5:30 here. I thought you said 5:30 a minute ago.
Oh no. I may have, but you know.
Oh,
I'm on
there's
my
an
third
hour
win.
hidden. There's an hour hidden by the curve.
Yeah, right.
Sean, it's all a dream. It's all a dream.
Not even funny. I was actually last night. I was listening to Flat Earth Dude. He's like a Flat Earth 24/7 stream, and they were messing with somebody that was sleeping on the Hangout, and I was thinking, I really wouldn't want to fall asleep, and then somehow someone subconsciously hypnotizes me and shit. That scares me.
Oh man.
so. I've got a question about this local. Do you know? Do you not agree that we can radio
Hey, thanks,
range
seriously,
things
Fred, I
based on the
appreciate that.
return time of a radio
Don't
signal?
resist your wonderful abortion. Test D. Globe.
You know,
When the cop says you're going too fast because he can ping you and get the radio range back, or that a radar dish on the front of most commercial airliners can't detect even modest densities of clouds and things and weather fronts.
I don't know how the magnetic field around the Earth could affect that. I don't know. I mean, it's like there's been so many things that have been basically fabricated that I've
Do you know if
you know
do you know if the magnetic effects, or we can test the return continuity of a radio signal and know that it's been affected or not, right? You know that. So we could actually determine that if we sent this radio ping out and something magnetic or electromagnetic interfered with it and it came back, we'd be able to detect that pattern and think, hang about, something weird happened here. You know that, right?
well, the thing is I know that they bounce signals off the ionosphere.
Given a certain wavelength, you'd be able to do that. But it'd be a very weird dispersal pattern because it's not a physical solid, continuity derived thing. It's a little bit. It's not got much continuity to it, so therefore I would imagine the signal would break up quite a lot. Although you would get a return. But the point there is we can radio range a car. Planes can radio range each other with the ACAS avoidance system. We can radio range the moon, and we can radio range the sun now, only in the last 10 years, I think. So when we radio range the moon, and many people have done this, including ham operators measuring return signal as well, or bounce signal, and it's come out to, 250,000 miles, 250 or 238,000 miles or whatever it is. So that's a hard fact to get round. And then
but what is no? But wait a minute. What is the standard? What is the the thing that you're measuring it against for distance? Like
the time. Time.
Okay, but listen. On Earth, there's atmosphere. Okay, it takes longer to travel through a different kind of atmosphere, right?
Depending on the wavelength that you use, you will have different effects of that. But yes, but we know that, and I think the difference is so incidental you can almost disregard it
in comparison to space.
in comparison to a near vacuum. Yeah. So the difference between this, so what you're on about there is we're on about the same thing, and it is called refraction. The same refraction that is optic in the visible electromagnetic spectrum will affect in some way, depending on the wavelength, because you can control how much it's affected. Depending on the wavelength, refraction will affect other electromagnetic waves. So we can choose electromagnetic waves that don't get affected by that much at all. But even in standard atmospheric refraction, it's a fractional reduction in light speed of 1.003, which doesn't actually make that much difference. And if it does, you can account for it. And even with an error tolerance, we're still at hundreds of thousands of miles away for the moon and millions for the sun.
But what I'm saying is, what is the control
Time.
distance? No, but so these.
If I know that you can travel at 10 miles an hour, and I say go to that post and come back to me, and it takes 2 hours, can I determine that, hey, that's 20 miles that you've traveled? So that is 10 miles away. It's really simple, that, right?
I guess I didn't hear you.
So if you can run at 10 miles an hour in 1 hour, and you can do that constantly from when you set off to when you stop, and then I say run to that post and back that I can see in the distance, and you run there and you come back and it's taking you 2 hours, is it fair for me to determine that that post is 10 miles away?
Sure, I guess so. But
same principle.
Not really, because nobody's been to the moon.
No.
Okay.
I didn't know the distance before I set you off running to it. I knew how fast you traveled. That's it.
Okay, but for the context of what we're talking about, shooting radio frequency and bouncing it, pinging it off of an object, and having it return. Okay, with no medium in between, supposedly, because space is a vacuum, right? So
a vacuum just indicates pressure, not really medium.
Okay, well, the absence of particles.
Yeah, but electromagnetic waves do not require a substance to pass through. You know, light can travel in a vacuum. That's an electromagnetic wave. Radio waves can travel in a vacuum, and that's how we measure the baseline speed of them as well. So that's
okay. But light travels slower through a medium than it does
atmosphere.
Vacuum,
yes,
right?
because of the visible wavelengths of light. So we see.
Where is the control to measure that great of a distance, 240,000 miles, 230,000?
Mm-hmm.
Where's the control? How do you arrive at?
Are you ready? So we know that the atmosphere.
The speed of light changes. We know that.
Yes. But we know how fast. We can measure light in a vacuum, and we can measure light in our standard atmosphere, and we know the difference. We've sent up balloons and even the ISS, and we know that the atmosphere isn't really an issue above, let's say, 200 miles. It's so thin that we can almost disregard it. So the wave is traveling freely here. So we know we've got 200 miles of not so much atmosphere to go through, which might alter it in incredibly small amounts, because that rest of the space, it's traveling at maximum speed. So in that vacuum to the moon and coming back, it's traveled 99% of that at the fastest speed it can, and it still takes enough time to determine that it's over 230,000 miles away.
And have you done that yourself?
I don't need to.
You don't.
Thousands of people have, including ham operators. Have you ever seen the flat Earth yourself or seen the dome? So why do you believe in that? My evidence for my beliefs far outweighs yours, I would imagine.
I don't think so.
What evidence do you have for the flat Earth? besides the rhetoric of "I can see farther than we should," even when you probably can, and on odd occasions it's due to severe refraction. The only time I've ever heard flat earthers arguing, "Hey, look, I can see way farther than I should," and all this, is they're pointing to extreme refraction where there are no straight lines on buildings anymore. It's like, yeah, that's not reality. The buildings don't dance like that, nor do builders build buildings with wavy lines. Slight correction, some people do if they're making an artistic statement, but I think it looks horrid. So yeah.
Well, I guess I have a different perception of the world than you. I mean,
have you got any evidence? What is your strong? If I wanted to be a flat earther, what is your strongest evidence for the flat Earth?
there's all kinds of evidence. It's
well, just the strongest. The one point that stands out highest. If it was you're like top 10 or something.
Top 10.
Well, yeah, just one though. The best, or even one out of the top 5.
For me, it was water, but I wouldn't call that the best proof.
No, give me the best.
I think the fact that all airplanes assume a flat, non-rotating Earth is a pretty good indication that it's flat.
Okay, so you're ready. If that point,
I've already heard all the rebuttals. I mean,
yeah, if that point can be proved wrong, would you reconsider your position then?
If what point could be proved wrong?
If the point that you just said could be proved wrong, would you reconsider your position?
Or proved wrong satisfactorily to your understanding?
No, because there's a whole lot more evidence than just.
All right, I want you to understand what you just said there. If this one point, which is the strongest proof of flat Earth, could be proved wrong, you still wouldn't believe. Is that because you want to believe in the flat Earth more than you want to believe in a globe?
No, I didn't have any. Honestly, I didn't care one way or the other.
And you've heard the rebuttals to that, and the fact that fuel calculations are actually required because the distance that you travel on a curve, given flight plans that do have airways that deviate direction, you actually have to account for the fact you're traveling more distance on a curve, right? On a globe. That's how they do fuel calculations to be efficient. In other words, if it was a flat stationary plane, then you'd land with a shit ton more fuel than they do.
I think that probably has to do with the jet streams, and it's not because of the rotation of the Earth.
Oh no, it's nothing to do with rotation. The rotation is relative, and they're flying within the Earth's atmosphere, so rotation's got nothing to do with it. I'm on about distance. The distance across a curve when you're making a change in direction. So, for instance, a flight from Florida, a non-stop flight from Florida to London, has to fly and make deviations in course to stick to air traffic routes, and also some safety guideline that says it can't fly outside of X number of miles of an airstrip that it can make an emergency landing at. So therefore it has to go up the east coast of the United States and then start turning to go across, heading towards Greenland and Iceland before arcing down to go across Ireland and then into Heathrow in London. That's made almost I think it's a 75-degree turn. Now, that 75-degree turn on a flat plane is a hell of a lot shorter than that 75-degree turn and flight path on a globe, except to do fuel calculations, they have to plan for a globe, or else they'd run out of fuel. You know that, right? Has someone told you that before? The distance is longer on a globe. And you could do this with a flight planner on I think Bob the Science Guy's references flight planners all the time that actually take this into consideration.
he uses flight vector.
Yeah, that, and
That's a
then
really good
and
one.
because of the distance and burn rate of the engines, that it has to calculate it on a globe, or else you'll run out of fuel. Because airlines operate on very small margins of fuel tolerances, where you might have one or two divert options, but they won't stock fuel above that, because carrying fuel around and burning fuel to carry fuel costs way too much money when you do it in the thousands and thousands of times per day that they do operate. So what's the second best? What's the second best argument?
You know, there's just, for me, there's a whole lot of little pieces. You know,
Okay.
It's like, for an example, when I was in school growing up, basically they taught us that the Earth was a globe. Okay, and that there was some rock solid evidence that they gave us, right?
Mm-hmm.
One would be circumnavigation, right? You've heard of that one, right? Sailing around the Earth. Okay.
Oh yeah, based on star charts. Yes.
That was one thing.
That has to be a globe, or else you get lost.
The people seeing ships disappear. Okay.
Yep. Over a horizon. Yep.
Back in a time when they didn't even have telescopes to be able to see.
Oh no, that'll be angular size, but telescopes or optics were invented a long.
The point is, when they decided that the Earth was a globe, they saw ships disappear, and they didn't have any optics to pull them back into view. Okay, that's a fact. Now, another proof that they gave us was the shadow on the moon during a lunar eclipse, right?
Yeah, that's a good one.
Well, it's really not, though.
It really is.
It's really not. It's really not a good proof, because sometimes the shadow that appears on the moon is in the totally wrong position for it to be the Earth causing the shadow.
Are you confusing an eclipse with moon phases?
Yeah, like tonight. We're already looking at
lunar eclipse.
The phases of the moon aren't caused by the shadow of the Earth.
I didn't say that.
Yes, you did.
No.
Yeah.
Well, if I did, that's not what I. No, I didn't. That's not what I said.
Have you no? So wait a minute.
I
Deception.
said.
Have you?
I said
No, you got it wrong.
During a lunar.
Have you got an example?
Yeah, I got a bunch of them.
Yeah. Just give me one.
An example?
Yeah. Just a link to an image that couldn't exist on a globe.
Well, I'm not. That's not what I said. That's you're putting words in my mouth.
Sorry. Okay. Sorry. Is there any tangible evidence for your claim? Is my question then.
That the shadow on the moon isn't caused by Earth?
No. Yes. Is there any tangible evidence that leads you to believe that is the case?
Yeah. There's a
What
bunch.
is that evidence?
It's called selenelian lunar eclipses. They only happen.
Does that happen every time?
No, it doesn't. It only happens 10% of the time.
Right. Do you understand why?
That 10% of the time, though, the shadow is upside down. Okay, it's in the wrong orientation from where it should be.
Yeah, but you do know that the sun and the Earth's ecliptic around the sun, and the moon's ecliptic, as in orbital plane around the Earth, has precession and offsets. So you would expect to see differences over time, right? Have you got one image example and a date? Because these will, I promise you, these will all be explainable. And if there isn't, then I'm very.
I just made a video about it. It's on my channel, and it has about, I think, six or seven different examples of what I'm talking about.
Wait a minute. Can you paste something in the side? Oh no, wait a minute.
You can put a link in the group chat.
Yeah, I just need to go to your channel. I've not, because you've not typed anything in the chat. I can't find your channel.
There's a couple the last 2 links I put in the side chat.
Ah, right. Yeah, I got it. Yeah, I got it. That just looked like one big link to me.
Yeah, I'm gonna put his
the bottom bit.
Share his.
No, that's Life is Short. Wait a minute.
Here it is, right here. This is his channel right here.
Okay. I'm gonna have to go make a few more calls in a sec. Well, actually now, but I'm just gonna have a look at this, and I'll subscribe to you as well. How's that?
Yeah.
Yeah.
I just put it. In
which one? Too. Which one was it? Deception? Was it?
It's the newest video. It's
6 days ago.
It's called 23.
Yeah, got it.
Yeah, we got it.
Okay.
Why do you have an FBI warning?
Yeah.
Oh,
that's awesome. I don't know why, but that's awesome.
That's my copyright thing.
His brand.
No, it's my copyright. It's my copyright. In case I used anybody's.
Okay.
You know, for sharing it.
Wait a minute. That eclipse that you're showing there, the lunar eclipse, is quite plausible.
It shows no, I know it shows a couple regular lunar eclipses, and then it goes to the ones that don't match.
Dude, this is like longer than a movie. Can you give me a timestamp for the ones that don't match?
I know.
It's
how am I going to zip through this?
Well, you guys should watch it. It chops eclipses up.
Listening to it. Listening to it and then just reading out the.
Oh, wait a minute. Go to 20, 21 something. Wait a minute. 22. Wait a minute. Here we go. I've just seen something. But it's, here we go. 24. Go 24. I think this is the concept. So you've got a problem with the penumbra and umbra of shadows as well, based on distance and light scattering.
That's a second part of the video, but the first part should be within the first couple minutes. Here, I'm gonna go to it right now.
I'm just gonna make some calls. I'll be back in a sec.
Okay.
Let me see. Oh shit.
So what's the best timestamp to look at?
That's what I'm trying to work out. I went to 24, but it just went into a explanation that was visual, but I couldn't understand it. 23, 24, it starts.
It should be within the first 10 minutes, I think.
The first 10 minutes? No, I looked at that. I couldn't see anything in the first 10 minutes. It doesn't start till 24. There's actually a video footage of the actual moon itself, like real footage. All this other stuff.
No, there is. Hold on. I'm going there.
There's something linked that we can watch the moon doing what it's saying. You're saying it's doing, and well, then we'd understand what you're saying.
I know. Hold on. I'm trying to get there. Hold on. On my
Okay.
my
Exactly
TV.
2240. It's showing the moon. It looks like it could be an eclipse of the moon. Which is normal. What you would see.
Well, while it's finding that, what do you think causes an eclipse?
You know, honestly, I don't know. It's a good question, but even like NASA says that the moon glows in the dark.
That's penumbra type effect.
No, the moon glows in the dark. It's called photon luminescence of the moon.
So do you think the moon is a solid object or a...
You know, I don't know. I think it's possible that the moon actually goes behind the sun when it's like a new moon.
No.
Huh?
It's called planet shine. And it's the albedo. It's the albedo at which the surface of a planet emits. Says planet shine is the dim illumination by sunlight reflected from a planet off of all or part of the otherwise dark side of any moon orbiting the body. It is also known as moon's ascend glow, or the new moon with the old moon in her arm.
So there you go.
That means.
You're getting tired.
I am a little bit.
Yeah.
Okay, I see what it is.
If you just go to like,
I'm sorry.
If you go to like 3 minutes, okay, it starts detailing it at 3 minutes and some odd seconds, and it'll show where the sun is, not in all of them, but in a couple of them. It shows where the sun's at, and the sun is 180 degrees on the other horizon. Okay, but the shadow on the moon is in the wrong place.
Oh, so this is not eclipse. This is just showing.
Yes, this is it. No, this is lunar eclipses.
Hmm.
Are you talking about something like this, Fight Deception?
What?
You're talking about something like this?
Hold on.
Right, yeah. Oh, there.
I can't see that. Why can't I see that? All I can see is me. Stupid looking kangaroo staring at me.
I click on Sean's icon.
I should be presenting.
Yeah, but you got to click on Sean's icon with your mouse. If you're on a computer.
I'm not on my phone.
Oh, there we are. Got it. Thanks.
And if you double click, it goes back to. If you double click, it goes to everybody as soon as we talk.
All right.
When I was done.
Okay.
Yeah, just like that. Oh no, but that's opposite. That's a regular
That's
one.
just Earthshine reflected from them. Oh, you're talking about Earthshine reflected from them. Yeah, that's not an eclipse.
Yes, these are all lunar eclipses.
No, what Sean was showing is showing not lunar eclipse.
That's Earthshine.
Yeah,
Oh,
that's just the normal moon phase.
Right. What I'm talking about is eclipses, lunar eclipses.
But I can't see what your problem is with them.
Are you watching the video?
Yeah, I'm watching it.
Because the shadow should be on the bottom of the moon.
Okay.
The portion that's closest to the Earth, because the sun is rising from behind. Okay, it's going to give you. It's going to give you an example. It's going to show you the moon, and then it's going to turn around and show you the sun on the other horizon. Several examples, and you're going to see that from where the sun is and where the shadow is on the moon, it's in the wrong place. Okay, according to the heliocentric model, anyway.
Well, to give you an example, when we're looking at the moon tonight, there's probably sunrise over your way by now. But where the moon was, it was lit up on one side of the moon compared to me. So that means the sun was in two different directions, if that's what you're saying. Because the moon was lit on one side to me, but it was lit on the other side to you.
Well, no, it was lit on the same side. It's just from where you're looking.
We just went through all this before with Shawn.
Okay, it's almost like looking at if you take a paper plate and you draw, if you draw a crescent on it, okay, and you pin it on the top of your ceiling, and you sit on the floor by the door, and then you have someone else sit across the room from you, okay, and you both take pictures. One looks upside down, and one. It's just from the perspective of where you're looking at it from. You understand that?
Yeah. So if a person was on the other side of the Earth looking at the eclipse, or no, eclipses are local. Yeah, eclipses are local. Yeah.
Well, not always. The last lunar eclipse.
But do you know there's an issue with the fact that to have a lunar eclipse, the sun would then have to go below the horizon on a flat Earth, and that's doesn't go with what's observed, because during a lunar eclipse, people can still see the sun, still see the moon, and nothing drops below horizon out of our sight.
What do you mean?
Okay, so a lunar eclipse is when the Earth is in between the sun and the moon, right?
Are you watching the video?
No, I'm not. I didn't get the.
You should watch it because it shows basically it shows my whole argument. It has about 7 or 8 different. Start at 3 minutes.
Which one is it?
It's called 23. I think it's called Dispelling 2,300 Years of
Eclipse Revealed.
Yeah.
Yeah, okay. Something like that.
Okay, yeah, I see it.
And actually, if you go to 9 minutes, or actually, is it 5? Let me see. Yeah, 9 minutes and 50 seconds. Okay, now you'll notice that the shadow on the moon is on the top part of the moon, not the bottom. Okay.
And the sun's setting.
I'm gonna go back a little bit. I want to see it.
No, the sun is rising, and the moon
Okay.
is setting.
Okay. But you can't see the sun yet over the horizon, but yet the moon is lit.
Yeah. Yep.
Okay.
But it's lit from the wrong side. Okay. It's lit from. It's the part of the moon that's closest to the Earth, closest to the horizon. I'll say is the part that's closest to the horizon is lit. Okay. Did you hear that?
Yeah, yeah.
Okay. So this guy's gonna try to explain it.
No, visuals do better than explanations.
Okay.
I'm
It's
sorry.
gonna show that. It's gonna show it again. It's gonna show it again. You can't see it very good in this video. Okay, but there's from the same day on the same eclipse. There's another time lapse that's gonna show you. It's gonna show you the moon. You know, it shows it here too, but not as good as this other time lapse from the same day.
Well,
Well, the only bit I seen was the sun was about to rise, and the moon was lit. That's all I've seen so far.
Okay, well, you
That's all.
miss
That's all it's seen.
you might have missed it. It just flashes for a second. Oh, there it is, right there. See? Can you see now?
you're watching mine.
Okay. No,
Okay.
I'm watching on my TV, but
Okay. Yeah, no worries.
okay. So now you can see the sun is rising from behind. Remember, but the moon is lit on the bottom when it should be lit on the top. You understand?
Why, when the sun's behind you? If the sun's rising, the moon would be lit all over, whatever the side's facing you.
Except the part that the Earth is blocking, which would cause a shadow on the bottom of the moon. Correct? I mean, where would the shadow be? Where should the shadow be?
I don't know.
Well.
Wow. Wow. Are you guys understanding what you're seeing?
Yeah, but what I'm seeing is not explainable.
I can tell you right now, in around 26 minutes, where the guy's starting to try to show us what's seen and what
I think you guys are you're too far. You should be at like 9. You should be at like 10 minutes, 11 minutes.
Well, 9 minutes, I can see the full moon low in the sky, and then he pans around and he sees the sunrise glow, and we still see the moon lit. And at 6:55, the sun's still coming up, and we still see the moon. It's a bit blurry, but unless it's got a better setting.
Okay.
No, it might go to 720. That might give us a better. It just looks like a full moon.
It starts going into eclipse, but the shadow starts from the top of the moon, the part of the moon farthest from the horizon. Okay.
Yeah, well, if I see it in this, I'll be able to understand it then.
It should, if that's where you're at in the video, it's going to come up in just a second.
Okay, so I'm at a part where it says what you saw and what you should have saw or should have seen.
That's what I'm trying to work out. All I'm seeing is a bloke talking, and
okay,
that's at 6 minutes. At 6 minutes,
and then 10:51, it cuts away to an image, and then it comes back to the video footage. So that's not really all in one shot of him looking at the moon and showing us the effect.
Well, it was filmed. It was filmed with the it was filmed with a phone camera, and so it was,
yeah,
just trying to enhance the footage. It was actually there.
Well, that makes it disingenuous because you're doing a cutaway of something.
I have a question.
It's just zoom in. I mean,
I've got a question on this.
Hang on. I got a question. So where I'm at right now, I'm at 6 minutes and 13. You have the what you saw and what you should have seen. How did you get that image?
That's Photoshop.
Rotated, yeah. I can see on the right, it's actually rotated. You can see a block that's.
Well, I didn't know that's because
that's just a.
But wait a minute.
That's just to illustrate what's going on. The sun is rising from behind.
Yeah, but there's a bias. Wait a minute. There's a bias here.
Where it says what you saw, where it says what you saw, you said it was the sunrise, but why is it dropping?
Huh?
In a lot of the pictures, and a lot of the images I'm seeing, the footage, I'm seeing it drop. Am I seeing it differently? Am I seeing it wrong?
That's the lunar eclipse taking place as the sun is rising from behind.
Okay. I get it now. That's why I was asking. Thank you.
Right. So there's one massive mistake that's been made here. Distance. So if you go to 626, yeah. This has got a big problem of distance. Yes, given this conflated, contrived diagram that does not represent scale or distance, yes, it's impossible. What you see right there is impossible. Absolutely. 100% guaranteed. Now move the moon out 230,000 miles away from the Earth, and move the sun 90 odd million miles to the left.
Oh, okay. I see what you're
move the moon.
Yeah, it's not the scale.
Below that umbra bottom line, and you get what you see, and you can see exactly that there's no contrived effect here unless you say local sun and moon.
Yeah, that's what I was trying to figure out.
It's absolutely a piece of piss, and 100% predictable on a globe Earth model to a T, and it will tell you when this happens as well. It's really, really simple. It's just based on distance. The moon is not that close.
What's predicted on a globe model?
This, along with this lunar and solar eclipses for the next 60 years.
Eclipses are not predicted by globe Earth, okay?
Yes,
they not.
No, they're not. They use serocycles.
No.
No. Yes, they do.
No.
Dude, come on.
There are Do you do software development? Because I do.
Hey, spell that serocycles. I heard that. Who was explaining that? That's the one where it's like hang on, never mind.
So what it is how can I tell that there is going to be a full eclipse that I can travel to in 2027, I think it is, in my country, when none has ever happened there before in recorded human history? How?
You're saying that there's an eclipse that
there will be when I'm much older than I am now, and actually I think I'll tell you when it is. I think it's 2029 or something. I have to travel 40 miles, but I can be in the full shadow. But it's never happened there before. It's based on a prediction system that uses no historical data. The only data that it has is the elliptical orbits, the ecliptic planes, the size of the spheres involved, and the motions, and it can predict when this crap is going to happen tens of years into the future, but you can also, with no historical data, test eclipses back in the past and look at historical records for the time in that local area if there's any information to actually verify it. And it doesn't use any historical data. It uses geometry, and that's it. No historical data. I could build one of these systems quite easy. And the point of that eclipse that you're showing on screen, yes, it will never happen in that diagram that is at 626. But move the moon 250,000 miles away. That's what, 10 times, oh no, wait a minute. So 50 times the radius of the Earth away from it, and move the sun millions of miles to the left, but make it probably about 5,000 times bigger than it is in that diagram, and you can get the effect that you are showing in that video quite easily, where one side of the Earth is shadowing the moon that you can see because of the distances. It is that simple. There's no magic here, and it's predictable on a globe model, but not on a flat Earth one.
Fight the deception. Do you agree that we can predict lunar eclipses?
Well, I know NASA uses serocycles, so.
So do you know when the next eclipse is going to happen?
Yeah, there's eclipses reoccur. That's why I'm kind of perplexed.
It'll be on July 16.
Hey, Shawn,
this year,
can you turn the volume
visible
down
in
on your,
South America, Europe, Africa, Asia, and Australia.
Say again.
Can you turn it down? I'm hearing his voice and the video at the same time, and it's kind of fucking me up.
I think you must have your volume on, pal, because I'm not getting it.
Yeah, I'm not hearing the echo.
I'm not hearing it.
I have everything muted.
Are you watching the stream as well, Deception, in the background? Maybe?
Never mind. I got it. I figured it out.
Yeah, no worries.
No, I have a Roku that I'm controlling from my phone, and so I didn't notice it has a little option to use headphones, so it was playing both.
Oh, okay, yeah.
If you go to 14 minutes, let's see, 14. I mean, it's showing a bunch of examples here. 14 minutes, and you know, it even talks about it being
yes, but the problem. Sorry, the problem there is that the moon is not. Wait a minute, are you ready? The moon is not. Wait a minute. So 60, 70. I don't know. Wait a minute. The moon is not 6,000 kilometers away, or 8,000 kilometers away. The moon is 250,000 miles. So that diagram is wrong. The sun is not.
The diagram.
Wait a minute. The sun.
Diagram.
Yeah,
that's
the sun.
NASA
yes,
diagram,
I know. The sun is not 24,000 miles away. It's 96 million. The sun is not 4 times the diameter of the Earth. It's 1,500 times bigger.
You're getting off track here, bud.
No,
not off track.
I'm talking about the shadow being on the wrong side of the moon.
Yes. Yeah. Now, if you move that moon, even in this diagram, if you move that moon out to where it says, below, so it's got the shadow on the right side, you plant yourself in America, but now move that moon 250,000 miles away, suddenly it's above your horizon in the northern hemisphere. It's that simple.
That diagram you got, if you have a look perhaps around that, it will tell you that it's not to scale.
No, I understand that. I'm not talking about the diagram. I'm talking about the actual. I'm talking about the actual lunar eclipses that happen upside down. They're called daytime lunar eclipses. They're very rare. You guys obviously aren't looking at the. You guys obviously aren't looking at the.
Yeah, you're able to do a quick draw, and Dean, in a bit of a not to scale, obviously, but
I could actually reproduce this to scale, but just give me a sec. I'm a bit busy.
It's what you guys aren't understanding is the shadow on
No,
the
we
moon
understand what you're
that's
saying.
Yeah.
caused by the Earth is on the wrong portion of the moon. The light would have to literally be going all the way up underneath of the Earth on the opposite side where it's nighttime, supposedly, and should be shining upward onto the moon. It's I don't understand what it's so hard to understand. And the thing is that they say the official explanation for it is refraction. Okay, it's refraction. Somehow the light refracts all the way up underneath somehow to light up the wrong portion of the moon. Okay.
Well,
But the thing is it can be predicted to happen. So obviously refraction isn't even part of the, you know.
When you're dealing with refraction on a planet size scale, yes, it's quite, you can actually predict that. And the fact that you're saying NASA can predict this, my clear question is brilliant. What shape of the planet does NASA think it is?
NASA uses flat Earth, geocentric Babylonian tablets to calculate, to predict eclipses.
Have you got any evidence for that?
Yes.
Citation, please. Go for it.
NASA. Just Google NASA Saros cycles, and it'll take you to the NASA Saros website.
Yeah, they'll explain historical data on how they analyze it, but that is not how they make predictions.
Yes, it predicts. Dude, go to the website.
Show me it.
Just talk. Dude, I'm on my phone. I don't know how to share that. Just Google
I'm doing it right
NASA Saros cycles or NASA Saros, and it'll tell you all about how the eclipses are predicted using Saros, which are, you know, tablets. They're old, thousands of year old tablets that have been charting the way that eclipses take place for, you know, they've been able to predict eclipses a lot longer than heliocentrism has been accepted.
But this doesn't. Does this actually explain why and what we see?
Explain why.
Wait a minute. Really quickly as well. Have you looked at the data? The data is inconsistent and has precession, something that you need to calculate. You cannot predict, or you would not have been able to predict. So no single eclipse is the same.
Yeah, they pretty much are, and even the Antikythera mechanism predicts eclipses down to the hour anyway. You guys heard of the Antikythera mechanism?
I mean, I'm reading at the moment. Give me a sec.
There's even a little spot down at the bottom of that site, that NASA site, where you can type in a time and a day that you want to, or I'm pretty sure a time and a date, or there's a way to look up any for the last like 5,000 years. And also forward for 5,000 years, I'm pretty sure. Now there is also another way. There's a book called, it's a book by Alexander Gleason, the guy who made the Gleason's map. And there's a way that I've never tried it personally, but it was the book was verified by the.
Right, are you ready? Wait a minute. Sarocycles cannot tell us the time and duration with high accuracy. It is not possible to determine the path of a solar eclipse, and they cannot predict the first eclipse in the Saros cycle series. And by the way, multiple Saros cycles can happen simultaneously, which makes it even more conflated. So you cannot get accurate results. You cannot get accurate results out of this. You could not trace a path on the planet with the Saros cycle. You just know that somewhere it's going to happen, and you might have an approximate location, whereas we can tell it to the mile using no historical data.
That's not true.
It absolutely is.
Where are you getting this information from?
I'll link it to you. It's actually on Metabunk, and it gives you the actual calculations to determine it in Python. I think actually,
use the NASA website
because there's actually an explanation of why flat earthers point to the NASA website, even though it's actually a little bit ridiculous, and that's not what they use. That's an explanation of how people used to predict them, not, hey, we're NASA, we use this. It's absolutely not. No.
Bullshit. Read the site. Read it.
Where does it say that they use this currently? Go on. Because I've just read it and it doesn't say that. It's an explanation of what it is. Yeah, it's not saying we use this. It's information of what it is. It's an ancient way to predict eclipses, but not with any accuracy, because they precess. You know that one is going to happen across, like, let's say, in northern between Australia and Asia in 1955, in 2009, and in 2063, but you cannot tell where accurately. That's not what this system does, and they're even saying it in the article. So no, this is not how we can determine that it's going to be here within a mile. We use that based on geometric data, ellipse-based orbits, and ecliptics of those orbits. I'm really sorry, but that is the case. And if
I think NASA have brought out other documentation that's similar to that in that context, where they get something and they just put an article about it. Doesn't mean to say they're using it.
I can hear someone's playing something.
Yeah, not me.
Me too. I hear it.
Might have been True Blue listening to the cricket.
No, I'm muted.
Okay.
I'm trying to make some raisin toast. I'm hungry.
It's light in the background. It's not that bad.
I had a couple of sandwiches for dinner.
I've got to fix a actual bug with a live app on the Apple App Store at the moment, so I am going to be somewhat dispersed.
And here I was waiting to look at some drawings.
I know I had actually loaded them up, but this bug kind of takes priority.
Yeah.
Because it's actually with a live client. Well, it's actually an upgrade. It's a live app that when you upgrade it crashes, and we've got it in test at the moment, but I just need to replicate the crash and fix it.
I was going to pick your brain when you had time to talk and listen while your fingers were doing something else.
Oh, I can multitask.
When Windows 10 comes in January, is there any way I can get around this? Because I missed out.
Wait a minute. What do you mean Windows 10 comes in? What's that mean?
Well, I thought Windows 7 is stopping in January.
Well, support is ending.
Yeah, but I want to upgrade to Windows 10, and I missed out on I think it was a free upgrade or something, and I missed out on that.
Oh, you can buy keys for like It's $10 or something. It's not even worth.
Or if I can get somebody that's got a disc with a key, it'd be even better, wouldn't it?
No, I'd just buy always buy a key, because you don't want that shit going wrong, and you don't need a disk. You can just download the installers from Windows. They're just freely available.
Okay.
Or you can just do a search for Windows 10 install ISO, and it'll take you to the Windows site, and you'll be able to download it. All you'll need is actually a key and to choose the right version. You could try your key to see if it works, but if not, honestly, just $10, and it will be 10 Australian dollars as well. So, what's that like? That's like half a cent or something, isn't it? Then you'll be able to.
Well, thanks.
Yeah, and then you'll be able to do it. It's always worth having, an actual key.
Yeah, I never thought my key may work. Yeah, I never thought of that.
Because you didn't have to. I've got a load. I had a load of Windows 7 keys, and when that free thing came out, I just got the key upgrades for all of them, but kept on Windows 7 for a bit. So my keys were registered as Windows 10 keys on the servers. And then I just chose not to update for a bit.
Well, my computer friend told me not to upgrade at the first instance of when it came out for the free upgrade or something. He said something about wait till the bugs and everything got ironed out or something.
Well, if you did that, you'd never install it. It's that simple.
That's what happened. Yeah, I let it go too long.
Still got bugs.
Well, I've never had any trouble with Windows 7 yet. Touch wood.
I actually learned something for the first time. There's two types of RAM in a computer. There's error correcting RAM, or ECC memory, and then there's standard memory. The standard memory you just have in your home computers, but the ECC RAM,
a hard drive,
they have in servers. And the reason they have it is they correct for particles, electromagnetic particles that make it from the sun through our atmosphere. It's the same thing that passes through astronauts when they report to seeing lights in their eyes.
Yeah.
Those particles can actually travel through the capacitors on a memory module and inside a chip, and actually cause errors. And the ECC memory is to correct anomalies like that. So we, on our consumer computers, suddenly get a blue screen of death and we don't know why. Whereas a server says, yeah, that's just solar radiation. I'll deal with this shit. I found that interesting.
Yeah, that is interesting.
I get the blue screen of death every other week or so.
Yeah, it's because you're installing spyware from porn sites, Shawn.
No, it's because I overclocked my computer a while ago.
Oh, so it's overheating?
Yeah.
Oh, Jesus. Get a water cooler for it, isn't it?
Not yet.
Yeah, I haven't gotten that.
I'm about to do a serious upgrade on my computer probably in the next 3 weeks or so, 2 or 3 weeks. Graphic cards, processor, the whole night.
Yeah, well, that's what I'm wondering about when if I go YouTube from my Discord, what's gonna happen.
Oh, get a if you're gonna build a new machine, Shawn, get a Ryzen.
Ryzen. Right.
Yeah, AMD. They're just trouncing Intel at the moment.
See, I'm using the NVIDIA graphic cards and motherboard, so I want to get away from it. I used to like it. Now I think it's low on the totem pole of computers.
Sorry, you're using what? Sorry.
NVIDIA, my NVIDIA graphic card.
Oh, NVIDIA. Right. Okay.
Yeah.
Hey, I was curious. I've got my computer going right here. It says, and I went to the NASA Ceros cycle, and it says NASA Eclipse website. So, do they have another site?
Yeah, that use models to predict it accurately.
No, do they have another site for eclipses that's not using Ceros cycles?
Yeah, their prediction model will not use serocycles because serocycles cannot give you where it will occur accurately or what time and its motion.
No, but
as defined in that document and the definition of those cycles.
Do they have another Do they have another website for eclipses besides the Saros website?
I don't know. I've never looked. I've looked at the I've looked at other solar eclipse things. I've never gone to the NASA website to look at.
Well, I mean, that's how they predict eclipses is Saros cycles.
No, I've just told you they don't predict the path or accurate location.
That's how they used to think it would work.
Yeah, it's a description of
No,
what that was
that's
in ancient times.
bullshit. It says the periodicity and recurrence of eclipses is governed by the Saros cycle, a period of approximately 6,500.
No. Stop. That is not in
wait a minute.
contention. That's not in contention, though.
No. Yeah.
That's fine. What you're saying is absolutely true. What you're not saying is it will give you the distance. It will give you where that eclipse is going to occur to a very accurate degree. It does not. It will tell you the path that it's going to take. It does not.
Will you let me keep reading here?
Yeah, go.
It says any two eclipses separated by one Saros cycle share very similar geometries. They occur at the same node with the moon at nearly the same distance from the Earth and the same time of year. Because the Saros period is not equal to a whole number of days, its biggest drawback is that subsequent eclipses are visible from different parts of the globe. The extra 1/3 day displacement means that Earth must rotate an additional 8 hours or 120 degrees with each cycle. For solar eclipses, this results in the shifting of each successive eclipse path by 120 degrees westward. So what they do is it's gonna occur 120 degrees different than it did last time. That's how they, that's what.
Yes, but based on the ecliptic of the orbit of the moon, I can't actually believe we're arguing this because this wouldn't even happen on a flat Earth.
This is using Saros cycles. They believe the Earth was flat, dude.
Like the deception, that would be similar to saying that barbers will still do bloodletting because they have a pole that's red and white outside.
Yeah, there's nothing that says equates the Saros cycle with flat at all either.
No, that's what I was just going to bring up. Yeah.
Well, the people who came up with the Saros cycles, the Babylonians, yeah, they believed in the flat Earth.
Well, they also didn't have the tools or equipment to believe anything different either.
Geocentric, I know, but they still had it good enough that NASA uses it today.
No, again, they don't.
NASA has it on their site. It is not, and they use terminology that is similar. They don't use the same thing.
Yeah, the human race as on Wikipedia has the cure to any illness as leeching, except that's just historical information. That is not what anybody uses today.
Well, I can't go down the chemist and get a bottle of leeches.
You can try. Depends where you are, I guess.
Okay.
I mean, we used to treat ghosts in your blood with cocaine. I mean, come on now.
Hey, I'm down for that. That needs to be brought back. That's
so
a happy go fun
I
time.
can go and buy a work made by Holden for a steam engine. That'll fix my.
I wasn't muted. My bad.
All I can do is hear Shawn yawning.
Yeah, I forgot I wasn't muted. My bad. I do apologize on that one. I did it right into the mic too.
Ah, Sasha's here as well.
Yeah.
I just noticed that.
What's up, Sasha?
Hi, Sasha. And you're muted.
Wait, hang on. So I'm on that NASA site. Let me show you guys because Fight to Deception, you keep referring to it as proof of flat Earth, but it's right here. It says the key catalog of solar eclipse Saros cycles. But
hold on a second. Hold on a second.
It says
Hold on a second.
Sequence number. It says sequential number of eclipses in a Saros cycle. Links to global map showing region. Everything in here says globe. So why is it saying that and not flat? Especially if the rotation of the period of Earth.
You guys all are forgetting what the whole entire argument was that it's predicted using Globe. Okay, but it's not. It's predicted using serocycles, and they don't have anything to do with the globe.
They don't have anything to do with the flat Earth.
Which is an outdated way of doing it, which is why NASA does it different now.
So do you guys have a link to the actual NASA Eclipse website then?
I don't. I'm on my phone currently.
I'm on. Well, seems like it. It says catalog of solar eclipse series.
Okay, so tell me, if why is NASA on their official eclipse website? Okay, why is it showing the serocycle and not the way to predict it using Globe?
Because I typed in NASA serocycle.
Yeah.
Okay, no, that's what I'm saying. Is there another NASA Eclipse website?
Yeah, that's what I'd type in, just NASA Eclipse.
And does it go to the Ceros website or not?
It shouldn't.
Does it?
Yep.
Oh,
okay.
It does. I typed in how does NASA predict eclipses, and the first one is the NASA Eclipse website, and it goes right here.
to the Ceros website, right?
Hang on. No.
So it's a different one?
Yeah, it doesn't. It's not talking about the serocycle. It's just talking about the eclipses and when it is. It just. I apologize. It looked like this. It looks exactly like the same site, but it's not.
Oh, they're just links, are they, underneath? Underneath the header?
Yeah.
Yeah.
Eclipses of the sun, main directory for NASA solar eclipse page, and then some popular links below. So for we're talking lunar eclipse, so I'll click on that
lunar
one.
eclipse. Popular links below.
Yeah, it's not. Doesn't take you straight to the serocycle. You have to type that in to get to there.
Yeah.
Otherwise, it doesn't. So it shows eclipse type. It shows serocycle, umbra, magnitude.
I'm looking for the method that they use to determine that.
Hang on, I'm gonna get there. That's why I typed
and
in. See if I can figure
not
out
only that, but how eclipses could reoccur nearly the same. It says right there on NASA's website already that they occur nearly the same, despite being 120 degrees, shifted. How they can remain the same for thousands of years, randomly flying through space.
That's actually explained by the moon being tidally locked in and not gaining much distance away from us at 250,000 miles.
Well, explained. I mean, that's a theory, right? I mean, that's not proven.
No, it's proven.
All right.
What's proven?
It's a theory because it's a theory, which it's not that it's proven. It's that a theory has the best supporting evidence and explanation. And saying just a theory is incredibly disingenuous, and also that's another spot on the bingo card, so everybody drink.
Okay, so theory is different than a law, also. Or, no, I mean, theory is different than a hypothesis. Also, we have retroreflectors on the moon, and we can measure the distance. And we can measure so we can send lasers up there, measure the time that it takes for them to get there and bounce back, and calculate the distance using that.
Because with known speed of light, that sort of stuff.
I don't think there's reflectors on the moon.
Well, okay, you can test it. You can. You can go with a laser and point out the moon and it will bounce back.
I can tell you right now exactly the answers you were asking before Fight the Deception. You are saying that how does NASA predict? They use. So I'll read it. It says, although not well known, Hawley also made important scientific contributions to studies of eclipses. He is credited with the first eclipse map showing the path of the moon's shadow across England during the upcoming total eclipse of 1715. He also rediscovered the Zero cycle of 18 years plus 10 or 11 days, depending on the number of intervening leap years over which eclipses seem to repeat. The Zero cycles used by Chaldeans and Babylonians and later Greeks are simple lunar eclipse predictions, but it was unknown in Halley's day. Using Newton's theory of the moon's motions in the Sirius cycle, Halley made a series of calculations to identify the ancient eclipses in the literature. It doesn't say anything about it being flat. The only reason the Sirius cycle is even discussed is that he discovered one of the cycles and figured out how it works.
Did you just cite Halley? Halley,
yeah.
He's talking Howley.
The guy that thought we lived on the inside of a globe.
Doesn't matter.
In 18... so you guys are always complaining when someone uses a reference. You guys are always complaining when someone uses a reference by somebody who believes in the globe, but you're referencing somebody who believes they live on the inside of a globe, concave Earth.
Okay, but listen to this. In his time, it didn't matter because obviously it works. Look, when Sir Isaac Newton first published his revolutionary theory of gravitation in the Principia of 1687, he laid down the groundwork for the prediction of planetary motions throughout the solar system. And then Edmund Halley played a pivotal role in motivating Newton to develop his mathematical description of gravity. In fact, Halley was financed much of the principal policy costs. I don't even know what that part was for. I don't know why I read it. Regardless, like, I don't even get where you're coming from on it. First of all, let make this real clear.
And it says
lunar
early
eclipse is impossible on a flat Earth.
And it also says at the header there, early predictions, not present.
How is it impossible on a flat Earth?
Okay, I'll show you. I'll make a little diagram
on a flat Earth. Listen, flat Earth, obviously, it's created by God, right?
No.
The only way it wouldn't be impossible if it was if the sun and moon were projected lights on the dome.
I've never seen a line across the moon in an eclipse.
You wouldn't see it. You wouldn't. I'm not even saying that's not even the Earth's shadow that's causing it.
Well, what shadow is it? You answered before. You couldn't tell us.
There's in my video.
Yeah, which we looked at. Yes, we looked at it.
Well, but you're not looking at all the little parts that are in there. There's a part in there that actually shows some, objects moving behind the moon.
What
and it's
objects?
like, okay, I don't know. They're just dark. I would call them dark bodies. I'm not sure. I mean, look at the moon. It's not visible half of the month. There should be, okay, if the moon reflects
the moon. Are you saying the moon is visible during half the month, or it's not in total visible?
Don't interrupt me, please. Okay, let me finish.
I'm trying to clarify. You said it's not visible half the month. Do you mean it's only partially visible for a large portion of the month? What are you saying?
Well, yeah, technically the moon is only visible half of the month because it's going through phases and you don't see the rest of the moon. That's what I meant by that. But
not everybody on Earth.
Okay, you mean partially visible? Gotcha.
But listen. This is my point. If the moon can reflect light onto the Earth, okay, reflect quite a bit of light onto the Earth, then the Earth should also reflect light onto the moon. Okay, would you agree with that?
Hold on, Albedo reading.
Did you guys hear that?
Do you know how much light the moon reflects back to us?
I could tell you.
Enough to light it up. See.
About 8%. That's about how much of the moon's light is reflected back to us.
Okay, so why doesn't the Earth reflect light onto the moon? We should see the moon during a new moon phase. The light from the sun would be reflecting directly off the Earth back up onto the moon.
Okay, let's put it this way. If you were on the moon, would you see the light?
Yes.
All right, I'm going to share
Would you
my
see the
screen,
light
and
from
I'll
the
show
Earth?
you right now exactly how it's impossible. You ready?
Obviously, you would if you can see the moon's light on the Earth.
If you're looking from
Think
the
about-
moon, can you see the moon's light shining on the Earth?
All right, can you see my?
I don't know. I don't
He
know.
was
That's a good
talking
question.
about the sun- He was talking about the sunlight. The sun's in the sky while the moon's in the sky.
Can you look at this real quick? I want to show you something. You see how you see the sun, Earth, and the moon, right? The shadow.
Hold on a second. Do I got to click on your icon?
Icon. Yes, click on Sean's icon. It should show what he's presenting. I'm not sure how to do it on a phone. People with phones are above my technology.
You know, I don't think you can actually present from your phone, except from your camera.
Oh, I could see a little tiny.
Well, here, I'll just. It's pretty easy, regardless. I can just explain it. No matter what, the shadow that's produced on the moon, on a lunar eclipse, is produced by the Earth. Am I wrong?
What?
When we have a lunar eclipse, the moon is in between the sun and the moon, or the Earth is in between the sun and the moon, correct? Earth in the middle?
No, not always.
Wait, what
these
is
type
the
of
shadow?
eclipses
What
that
is
I'm
the shadow? What is the shadow on the moon
you guys
during a
don't-
lunar
You
eclipse?
guys don't listen.
No. Just answer the
There's
question.
these. If you guys have not listened to anything I said the whole time, or what? It's
I
called
have.
a selenian lunar eclipse. It's a daytime lunar eclipse. Happens when both the sun and
Yes,
the moon
and
are
that
both
is on
above
the
the horizon.
It's not possible on a flat Earth. Okay, let me show you
They're
right now.
both
Ready?
above the horizon.
Are you ready?
I don't think he's debating about the flat Earth part, are you?
No,
Look, see this?
I'm just talking about these eclipses. Basically, if you remember correctly, this all started when I was talking about the, proofs that they gave us in school, and this was one of the rock solid proofs that, in my personal opinion, having seen, a bunch of them, and have actually seen it myself personally, witnessed it. It doesn't add up. It doesn't add up to, and you guys, I'm sure you guys probably have never seen one personally, and that's why you guys are not understanding what I'm saying.
Can you not do the genetic fallacy?
What?
I understand how eclipses work, but I'm trying to see what.
Okay, and I understood how eclipses work too. Okay, until I saw this particular kind of eclipse, which they call impossible, because
No,
they
it's not
say
impossible.
celestial.
It does happen.
Well, they call it impossible. Okay.
Ooh.
It's.
If not for other factors, yes, it would be
the
impossible. The only problem is that we have other factors.
The official, whoever makes up the narrative, it's agreed upon. I mean, they say that celestial geometry can't explain it.
Well, we need a citation.
Well,
from
come
some.
up with refraction.
First, let's get to we weren't talking about this the celestial eclipse. We were actually talking about lunar eclipses and the way the shadow was produced on it.
Yeah,
that was originally what we were talking about. And again, and we'll talk the normal eclipse, because now you're trying to move to an eclipse that is rare. Let's talk normal lunar eclipse. What
No,
produces?
I was talking about this the whole time.
Okay, what produces the shadow on the moon during the normal lunar eclipse?
In the globe model, it's
No.
shadow.
I'm just saying, period. So what creates the shadow on the
moon?
Moon?
I never claimed that I knew what creates the shadow. For all I know, it's a chemical reaction.
Okay, but doesn't it seem odd that the globe explanation works? Doesn't it seem odd that the shape of the shadow that we see on the moon during a lunar eclipse fits the globe model explanation? Doesn't it?
No, not during these other.
Okay, again, I said normal lunar eclipse, because we see normal lunar eclipses far more than we see these rare ones you keep trying to talk about. Let's talk about the normal ones, the ones that we can explain, the ones that will show you exactly the shape. So what is the shape? What is the shadow we see on the moon, and why is it shaped like a globe?
That's basically just cherry picking, right?
No, it's not. It's
no cherry
down.
picking. Cherry picking would be what you're doing using an exception versus a rule.
Exactly. Let's talk about the ones that happen all the time.
It can't be a rule. It can't be a rule if there's exceptions.
Okay. If there's a rare occurrence or event, that's one thing. I want to talk about. Listen to me.
It's pretty good proof that it's.
No, it's not proof.
Wrong.
No, it's not proof, because if it was proof, it'd be something that wasn't rare. It would be explainable.
Also, if it were proof, it would be math.
So again, I will ask this very simple question. During normal observed lunar eclipses, what causes the shadow on the moon? Okay, you don't want to answer. That's fine.
Well,
now, understand something.
I can answer it, because
it's not officially. That's the problem I'm having right now. You're word salading, so you don't have to answer the question. The answer is the Earth. The problem is, on a flat Earth, there is no possible way for a lunar eclipse to happen, because the sun is seen throughout a lunar eclipse on a part of the Earth. If it was flat, the sun or the moon, well, actually the sun, would have to drop below the flat Earth horizon, which means no one would see the sun. The sun would not be visible during lunar eclipses at all for anyone, but it is.
That's if.
Guys, can I present something? Because I can I've done a diagram that shows exactly what he was actually arguing with.
Yeah, Dean was going to do this for us, Shawn.
Right.
You're presenting.
So let me do this. So what I've done, and I'm going to have to hide all my work crap. First, which isn't porn. I was just going to mention that because I want to show you the render view. As well as the other things. Right, so I'm going to share my entire screen, and yes, the screen is 4K, but it's actually projected in 720p through the fantastic thing of Hangouts. So anyway, this is my moon. And this is the shadow that I've got on my moon, which is quite awesome. Now, over here, wait a minute, where are we? There we go. We have the Earth. Behind the Earth, we have the sun. Now, this is absolutely to scale. This moon object is 250,000 miles away from the Earth, which is 92 million miles away from this huge ball in the distance, which is the sun. Now, if I go to the Earth, so we can see the Earth here, we've got one side illuminated, which is fine, and morning on this plane, on this line here, which I have via this camera. I can still see the moon. However, the moon is actually shadowed from the other side of the Earth, which gives us the effect that you're on about. Now, if I look at this camera, oh, by the way, just so that you're aware, just for informational sake, if we actually did go and get this big, huge thing and shove it next to the Earth, this is how big the sun is next to the Earth, just so that you're aware.
Oh shit! I just got sunburnt.
Of why people use this scale and scale diagrams. So anyway, let's have a look at this camera, which is on the Earth's surface at the point where the sun is visible, quite high now, and the moon is visible. But the interesting thing here is on this, I think it's that one. Yes, on this one, if I render this view, we can see the shadow, and we'll have to wait for it to render because it's going to take forever because I've not plugged in the accelerating GPU box.
What do you call it? Music we need?
Yeah, elevate music.
That's it, yeah.
Yeah, you can see
You
that
gotta assume the size of the sun, though.
Sorry?
You can't prove that the sun is that far away or that big.
Well, yeah, we can radio range it, but you don't accept that, but that's up to you. Modern day science and the rest of the 7.6 billion people accept that we can radio range things. And we use it day in, day out as well for radio ranging other things, including, you know, Doppler radar for weather systems, ground-based as well. So
Hang on. I'm sorry. I got to say this. Hey, Matrix, you need to understand the difference between using globe logic to debunk flat Earth and just talking with being able to explain things and things that make sense. If things work on the globe model, guess what? That means you're just denying reality to make your reality sound okay. But if you can't explain anything that you believe, it's just a fantasy. Go ahead, Stingray. I apologize.
So
no, that's okay. We need the wasted time to wait for this to render.
yeah, I
the
think
4K render, huh?
Well, no, it's not 4K render. It's doing a little 1080p thing, but I'm going to actually have to crash it, I think.
Oh no.
I know. It's all right. I will actually open it back up again because I saved the damn thing.
Yeah,
but the takeaway point here is the side of the Earth that I am not on is casting the shadow, and it does it quite easily because of the distance. Now, the only way that a flat earther cannot get their head around it is they do not realize they are stood on a huge sphere.
Is that to do with that S word, like scale?
Yes. So if you look here, we can see we're looking from the viewpoint of this moon right now. Wait a minute, let me just take away the background so that we can see a little bit easier. We're looking from the viewpoint of the moon. We can see that from the viewpoint of the moon, we're seeing the sun on the right-hand side. Yeah? However, the camera that I've got is actually here on the left-hand side relative. But when we go to this camera, from this camera, we can see the sun and we can also see the moon. So based on the distance there, that's what's happening. So from this vantage point of being able to see the sun and the moon, if we travel straight towards the moon, which is here, we can see that it will be shadowed on the left-hand side because it's seeing the sun from the right-hand side there. So this side of the Earth is exactly how we would think in that photo that you originally saw. It's only the distances that got messed up. When you're trying to describe it when things are really close, then yes, it's impossible. When you're trying to describe it at the radio range distance that we know that they are, it's completely possible and easily explainable, but never on a flat Earth.
The shadow would be going in the wrong direction.
Sorry, say again.
The shadow would be going in the wrong direction.
No, I've just showed you that it wouldn't. So wait a minute, let me just do this again because it crashed. So I'm doing this now.
I'd say put the camera back on the Earth where you see.
Yeah. I've got to change this to be a spotlight with a very tight cone influence. And I've got to change it to be a ray traced shadow. That'll do. Ray depth 1, light radius will do.
So basically, if we can show him what he's seen in that video, in this rendering, then you can go from there, I'd say.
Yeah, so we can see. Do you understand, Deception, that this is correct at the moment? This camera here is on this side of the planet, and let me turn off the cloud layer so that we can see the Earth a little bit better.
So the sun will be behind you guys.
Yeah, so we're looking here, and we can see that in this direction we've got the sun, and if we move over here to the sun, to the moon, sorry, we can see that the shadow, and hopefully if I save it and render it now, give me a second, not Arnold, Maya software, Maya, turn on ray tracing, we can see that, bloody render this time. Yeah, we can see that the shadow is actually shadowing it above our viewpoint. So we're looking at the same viewpoint. If I zoom back here all the way, we can see that we're looking at it from the right-hand side. But the shadow is also on the right-hand side because it's been shadowed by this side of the Earth. It's the distance that allows us to see both of them. It is that simple.
Now, what part of the moon had an eclipse on it in that video?
Yeah.
Was it the top part of the moon or the bottom part of
If you guys have never seen one yourself, then
but just so that you're aware, look at
hold it against you.
Look at the distances involved here. This is the Earth. And then this is wherever the hell the moon is. Wait a minute, where are we? I've actually lost the moon.
It's there.
It's somewhere. There we go. Yeah, really tiny. There we go. Oh no, that's a camera. That's not the moon. I've lost the moon.
You lost. Oh no.
I know. Damn thing's too tiny. Wait a minute. It's in that. Yeah, there we go. Clever. Like it. So yeah. So even though my camera again is on the opposite side of the planet, we can see there. This is the Earth in the background, and we're looking at the moon. The moon is being shadowed by the other side of the Earth. So it's completely plausible with two spheres and completely impossible with a flat plane and a sphere. I rest my case.
Yeah. Now, obviously, if the sun and the moon were a lot closer.
Oh yeah, you won't be able to do it.
We'd have completely.
But like I say, just one more time. Just one more time. This is the scale size of the sun next to
ignoring
the moon and Earth.
I honestly can't even see you.
What's
Sasha, you sound like you're talking through a pillow.
Or a balaclava.
Yeah. Even if you ignore the fact that even if you just look at the crescent instead of trying to imagine this with an eclipse or something, just the crescent shows that it would only work on a globe Earth because you can't get that because there's nothing to create that shadow on the flat Earth if you just have the sun and the moon and nothing in between to obstruct and make the crescent shadow.
The moon does that itself every month already.
Jesus Christ. Yeah, like the logic that comes out of your guys' fucking mouth is so irritating right now.
You see phases of the moon that are the same
and I'm dealing with Fight the Deception. I need you guys to understand something. Do you understand that shadows don't just happen without nothing? Like, there's no such thing as a shadow that's not shadowed by something. You understand how shadows are created?
Of course, and I see shaded parts on the moon all the time.
Okay,
so
now
seeing
get a ball.
shaded
Now
part
go
of
get
the
a
moon.
flashlight. Go get a flashlight. Just point it at a tennis ball, and that will prove to you why moon phases happen. Now, A lunar eclipse. What
wait, Shawn,
causes
Shawn,
the shadow?
wait.
No, stop. What causes the shadow on the freaking moon? And if you say I don't know, guess what? We do. And we can explain it better than you. So therefore, how are you saying we're wrong?
So just,
Well,
I'm just going to do this. I'm going to do this.
Itself.
I'm going to do this once more in conclusion. Am I still presenting?
Yes.
Yeah.
Right. So here I've got that camera again, and this time we're going to look through it. So we can
Hey,
all.
I can't see it. I haven't seen it any of the times you showed it before. There's there's something on my phone that says you're already in a call that's covering up the whole screen. So
go scroll down from the top of your phone where your notifications usually are, and click tap to return to call.
Returned call.
Thanks,
Typical kid knowing how technology works.
Yeah, that's what I was going to say. I was going to say thanks for somebody, a young person that knows how these phones work.
Well, of course, Sasha assumed that he was using an Android device.
Okay.
Yeah, I don't even see that option.
It is a shame that you're not seeing what I'm showing, because it shows you that what you presented originally is only predictable and works on a sphere.
What you should do is you should take a flashlight, a tennis ball, like a golf ball or something, and then just create crescents of the golf ball in between the flashlight and the tennis ball. Create crescents on that. On that tennis ball. You can't do that with just the flashlight and the tennis ball.
You can do it with two. Matter of fact, the lunar eclipse looks like two flat discs, one flat disc going over another flat disc, because the way that shadows work on a sphere. Okay, my video addressed all this stuff, but you guys are too busy to watch it.
No, you're too busy to watch what he's been presenting.
We literally spent about 45 minutes going over one of your eclipse videos, and it only led us to me to go, hey, guess what? Again, a lunar eclipse is impossible on a flat Earth.
And actually, I'm going to work out.
That's making several assumptions. That's making the assumption that the sunlight is always causing the light on the moon.
It is. Show me different. Okay. Give me one bit of evidence that says different.
I just did. But this guy comes up with somehow the light of the moon, the sun and the moon are both above the horizon, and yet the light is shining all the way up underneath of the earth. But not on the top of the moon.
Let's play the realization game. You keep referring to these rare occasions of something that I don't even know about. So, and you can't explain. So I don't trust what you're going to say about it. Let's talk normal lunar eclipses that happen on predictable dates.
Because you guys don't want to talk about these ones,
you're right. I don't care about the rare occasion one. I'm talking about the one that happens all the time. I want you to tell me how it happens. And the moon does not illuminate itself, because if it did, in the parts that are reflected of the sunlight, the craters wouldn't freaking have shadows.
Well, NASA says the moon glows in the dark, so.
No, they don't. That's called the albedo.
Yeah, they do.
You need to learn what they say and stop just making up shit.
It literally says that.
Show me. Show me.
Okay, go to. I'm not on my computer right this second, but go to Google Scholar.
NASA says. I'm gonna type in. NASA says, moon glows.
No, it'll take type in what I tell you. It'll take you to a NASA site where you can download the PDF and read down there a little ways. It says.
Wait, we already did this. It's called Earthshine. Sorry, buddy.
No, it's not Earthshine. They say it's from cosmic rays. Yeah, they say it's from
I'm on right
cosmic rays and SEPs.
I'm on Star Child. gsfsc.nasa.gov website. Is that okay?
No.
Okay.
No, you gotta. It's a NASA technical report. You can find it on Google Scholar. That's where I find it.
So anyway, I want you to watch this stream back. I've just reproduced the image that you showed, and I'm on the opposite side of the Earth that is casting the shadow.
Wait. So I can't type in.
And I'm kind of done.
I can't type in NASA says moon glows. That won't work.
You can actually probably type in the moon literally glows in the dark when there's no sunlight or earth shine present, and you'll probably find it.
Okay. Well, anyway, I typed in why does the moon glow? It says the moon gets its light from the sun. In the same way that the sun illuminates the Earth, the moon reflects the sun's light, making it appear bright in the sky. Have your child hold a fruit at arm's length away, pointing at the light.
There's a logical problem here as well, and that is when is the moon devoid of the sun's light ever? And the only time that is when it's and when it's sat in the shadow of the Earth.
Hang on.
How can I share a link?
Just put it in the side chat, and I'll or
but
copy and paste it.
I'm not sure. Okay.
Or
the rest of the time,
in here
well,
or
wait. We can debunk this in 5 seconds.
I already have 10 times.
The moon. Just look at because the moon phases, they form crescents, and part of it's shadowed. That shadowed part isn't bright like the other parts.
That's because the moon is smart.
Because the only light that it receives is the light from the sun. That's the only part that glows bright.
But it can actually bounce off the Earth as well, back on.
Yes, but that's not as bright. It's not as bright as
shine. We
you guys know
that earlier.
You guys know what photoluminescence is?
Yes.
Why don't you just hang on? No, I want to stay with lunar.
What is photoluminescence?
I want to stay with lunar eclipses because you still haven't explained to me how it's ever possible on a flat Earth.
That is a fair point, actually.
And you can keep bringing up that rare case of lunar eclipses all you want, but then you know what? We'll just look and see how those occur. But then I'm going to go back and say, hey, on the normal lunar eclipses that are predicted, how is it possible on a flat Earth?
These are predicted too.
Again, how is a lunar eclipse possible on a flat Earth?
How is it predicted on a flat Earth?
No, how is it possible?
How does it work?
It's possible because it happens. Basically, what I think, and this is speculation, that the moon periodically, for certain reasons, goes through all the phases of the moon in one night.
What?
What?
Do you understand what the moon? Wait! Stop. How do the moon phases occur?
And then
how are moon phases occur?
Because of the distance, because of the angles from the sun and the moon.
Okay.
They wouldn't create crescents though.
Well, if it's the sun.
So you're saying there's not a crescent during a lunar eclipse? It's never a crescent.
But that's not what I said. I said I'm just talking about like normal moon phases. It wouldn't create a crescent if the sun if there wasn't a round object in between the moon and the sun.
It does all throughout the month. What are you talking about?
Yeah, but that's because the Earth's in the middle.
Yeah, but
No,
we're talking
it's
about
not in between.
No, we're not talking about the lunar phases, the lunar eclipse phases. We're talking about just moon phases in general.
Yeah, that's.
It's the angle from the sun, right? And we can also depict this by getting a ball, or getting a tennis ball or a golf ball, and just go outside. When you see the moon during the day, go outside, get a ball, and hold it up. And guess what you're going to see? You're going to see the exact
So
phases of the moon on the ball, which is how we know look, that's one way we know that the phases are done by the angle of the sun and the moon to each other. Now, the
they don't always
lunar
match up,
eclipse we know is the Earth in between the moon and the sun. Now,
how do we
explain to
know?
me
How do we know? How do we
how?
know? Yeah,
Huh?
how do we know?
Oh, it's perfect because when we're on the side that sees the lunar eclipse and we see this big shadow come across the moon and cover it, well, the other side of the Earth, they're staring at the sun and it lines up. Pretty simple,
but
huh?
except for this other 10% of the time that you don't want to talk about, right?
Oh, okay. Wait. We'll talk about that, but I wanted to talk about the 90% that it happens.
Yeah, first we've got to get the moon phases and the moon and eclipses first.
If your model explains 10% and our model
Yeah.
explains 90%,
No. That's even better. That 10% doesn't explain shit for flat Earth. But let's talk about the 90% that says the flat Earth is impossible. Or do you want to avoid that one? Yeah, I would want to avoid that one too.
To me, it shows that the moon is not being lit by the sun. Right? I mean, you have to experience one for yourself, I guess.
I've seen one. Now explain how the sun does not light up the moon.
Well, you can see during these eclipses that the part of the moon that's facing the sun, the closest part to the sun,
You're talking
is
about
not
the 10%
lit up.
one again?
Yeah.
Okay, talk about the 90%. The 90%, the one that says flat Earth is impossible, because you can. How are you talking about this rare 10% when the other 90% debunks where you think you live?
Well, in my opinion, the 10% that doesn't go with your model debunks your model.
Okay.
Wait a minute. What is this 10%?
Yeah. That rare eclipse that happens with both the sun.
Happen only 10% of the time.
Mm-hmm. And so you're saying that it's not explained for the globe.
You just explained something about that a minute ago, didn't you, Dean?
Oh, wait a minute. Yeah, is that the example that I just showed? Yeah.
Yeah,
It's completely. Yeah, you need to watch the video because I've just shown you how it is only possible using 3 spheres: a really damn big one, really far away for the sun, a moderately sized one for the Earth, and then a smaller one for the Moon, a fair distance away. And I showed you that based on being on the right-hand side of a, or let's say, being on a easterly directed sphere on an ecliptic plane, looking at a moon that's behind, away from the sun, I can see both, but the opposite side of the Earth is casting the shadow on, is causing the crescent on the moon, even though I can still see both the sun and the moon. That is only possible using 3 spheres, how I showed in the video. If you can find a way to watch video, I will do it again. If not, I suggest you look at Shawn G's stream later on because I showed it perfectly.
That's not even the official explanation for it, though.
Oh my God! Wait! You show me where the official explanation for it is, then. Because if you don't have one, guess what? We do.
Hold up. Okay, let's get the record straight. We've shown how lunar eclipses work 100% of the time.
Well, the 10% one that he was mentioning, we've already figured that one out. Okay.
So yeah, 100% of the time, we can explain it.
You did? Oh, so fight the deception. Your 10% no longer works on a flat Earth.
Wait. His 10% might still work, but then he has 90% that doesn't. So we have 100% that works, and he only has 10% that works.
Well, let's work on the 90%, just normal eclipses then. How they work.
Yeah. Because look, you're not. You wouldn't try to. You wouldn't try to explain. Fight the deception. You don't try to explain You don't try to explain everyday observations by only explaining eclipses. So we wouldn't say how long is the sun up during the day in the summertime in the northern hemisphere? I don't know. How many? Let's talk about the 10% of the time when there's no sun at all. You don't do that. You understand? Because see how that worked? The fact that I said there's no sun at all is this only works on a flat Earth. It doesn't even talk about a flat Earth, and it just was explained using a globe. Therefore, the 90%, the one that is everyday occurrence, basically, explain to me how that could possibly work on a flat Earth. Please stop avoiding answering that question, because the 90% is what it would be explained before that 10% would ever be explained.
It happens the same way moon phases happen. It just,
no.
I mean, yeah.
No.
I've got a question regarding
Wait,
that,
wait,
because
wait, wait.
I've got a flat Earth model.
Hold up. Wait. Could I just want to say this: in the rest of the world where the eclipse, we don't observe the eclipse. The sun and the moon appear to move at the same rate that they always do.
Yep.
So the sun's not moving any faster, the moon's not moving any faster, so they can't go for the phases quicker.
Oh, and the sun is always
They
seen.
don't move at the
It
same
would have to be below the horizon to happen, which is why a lunar eclipse is impossible on a flat Earth. I don't assume. That's just the way it
Earth
is.
is between.
No.
That's an
Okay,
assumption.
fine. Are you assuming that the Earth doesn't create the shadow on a lunar eclipse? Yes. So what makes your assumption make any sense compared to my assumption that is actually able to be observed?
I'm not making any assumptions either way.
Okay, I said.
I'm not saying that
you
it
are.
is the
You are.
Earth.
You said I was assuming that the Earth is what is in the middle, or you're assuming that it's not. So what is making the shadow? What causes a lunar eclipse then? So go ahead and tell me your assumption on that, because you haven't observed anything that would be different from what is explained already. And that's called a fucking mic drop.
Yeah, you guys just
We just don't want to believe enough. We've got to disregard logic, reason, and evidence.
I'm trying to look at the whole entire, spectrum of the evidence.
And we've proven that it all works. The entire spectrum works on a globe. You've only proven you've proven that 10%. You've proven that 10%
by the globe. It's not predicted.
Yes,
works.
it is.
It
Why
is,
do you keep
and yes,
saying
it's.
that?
Wait a minute, really quickly. It's not predicted by you on a globe because you don't believe in it. But everybody that does has 100% success rate, 100% of the time predicting anything on the globe. It is yet to be invalidated.
Okay. So let's set the record straight. So we've gone over that, and we've shown that everything works on the globe. You've gone over that, and you've showed that 10% of that works on the flat Earth. So now it's up to you. Now it's up to you.
I never said it proved flat Earth.
No, I didn't say that. I said it works on the flat Earth. Now you have to show that 90% of that the other 90% works.
Don't even give him that, because nothing has worked on a flat Earth yet. No, I'm not putting anything in your mouth. I'm telling you right now, you are wrong.
I never said that eclipses prove a flat Earth.
I know you didn't. I agree. You never did. Because guess what? There's nothing in any observation or anything that would ever validate that. But we can validate the crap out of it on a globe, and you're just not willing to admit it. Wait, so you're telling me the globe can't? It can't. It never has predicted eclipses.
Eclipses are predicted using cycles.
Okay, whatever. Does that mean flat Earth? No. But guess what?
They believed in the flat Earth.
No.
Yeah,
no.
They believed it
Please
was
understand something. You do not are you purposely not answering the question?
I don't think they knew that Earth was flat back then. 3,000 years
ago. They believed that the Earth was flat.
Okay, how about this?
Research the Babylonians.
No. Show me your evidence for a lunar eclipse working on a flat Earth. Go. Can you do it? Just say yes or no.
I never claimed to.
Perfect. Guess what?
I was just pointing out the problems that I found.
We can show you, whether you care to look or not, we can show you how a lunar eclipses are possible with the globe, and then we can show you how they are impossible on a flat Earth. So if that is the case, doesn't that mean flat Earth is not possible?
But can I?
Wait a minute, I was just going to add something. And I spent 10 damn minutes making a scale model to show you the one exception that you said didn't work,
and Dean,
showing
I'm
it
going
that
to
it
use
does
the crap
work.
out of it.
Well, I mean,
also-
honestly, I'm assuming that you have the sun really far away, the sunlight somehow shining under the Earth to cause the light on the moon,
You do not want
right?
that Earth. You don't want the sun or the moon to get any closer, because then it doesn't work at all.
Yeah, I mean the issue is, and I'm being serious now, Deception. I've created a flat Earth model, and I put the sun and the moon in there, and I've tried to make it work to the point of inventing new types of physics to make it work. I came up with the concept of fractured light. I came up with the cubic fall off of energy over the inverse square law, just to solve a few things. But there's two things I could never solve. One is eclipses, and two is that if they were local, I'd be able to see a different side to the moon in South America, as opposed to Florida, as opposed to Washington. And we don't. It's tidal locked. And the only way that can happen is if it's a long, long way away, because we only see 5 degrees deviation, not 30 or 40, which would happen on a flat Earth.
Here's my 2 cents. Here's my 2 cents. You can't say I have problems with some of this explanation. If first off you don't know the explanation, and second off you don't have a better explanation.
What do you mean that I don't know the explanation?
You obviously didn't understand it because you said it didn't work, and then he had to explain it to you, and you still don't understand it.
I do understand it, and it doesn't work on these certain times. I mean, you can't call it science if it doesn't always happen, dude.
Wait. First of all, that has nothing to do with each other. First of all, second of all, why do you keep fixating on 10% when 90% is better? So
but
why
not
don't you,
only that, I spent a lot of time doing that for you. You need to watch the stream because I've showed you that it works.
Please, someone, Dean.
Sorry.
Dean. We get it. I'm going to go back into my archives, and I'm going to clip out your model, and I'm going to use it as my own. Thank you. So you know. Don't worry, it will be seen numerous times.
Okay. It's not going to go to waste.
And I just want to say now, Jason, I'm going to kick you in your nuts. Concave is not real.
Fuck.
Although, just so you know, a flat Earth would present concave given standard atmospheric refraction.
I hate you, Dean.
I don't even want to go there.
Man, there's a guy that mathematically proved that the Earth is concave, and fuck, I can't remember. His name was Muhammad Abdul Qadir, and he mathematically made a model that works. And the sun is only 2.5 meters.
Yeah, because those assholes,
in diameter,
because those concave assholes, all they did was take our shit and turn it inside out. That means all you gotta do with the equations are flip them around.
Yeah, that's.
But again,
well, it still doesn't completely work.
Regardless of concave being as ridiculous as Santa Claus wearing a green suit using turtles to fly, flat Earth, less possible.
I don't even see how concave would explain gravity and air pressure and.
They call it universal compression.
Yeah, they're retarded. I hate concavers.
They say the ether.
Or I'm sorry,
they say
I hate concaver, Jason.
They say that all the stars and all the sun and the moon and all the planets are all a celestial sphere that's in the middle of this inside out globe. It's just
it is a ridiculous thing. But do you know what's even more ridiculous? A flat earther trying to explain a progressive crescent shadow on a lunar eclipse progressing across the face of the moon. That's actually ridiculous when you hear about it. How can an object that gives it light have an invisible object casting a shadow between it. It's a bit ridiculous. But so is a sunset on a flat Earth. So there you go.
There could be unseen bodies that are.
Oh no, totally. There could be unseen pixies, fairy dust, and unicorns as well. Except they've never been proven. So why assume that? Unless you can point to something and say, "Hey, here's an example of this unicorn or this invisible object casting a shadow." Why would you ever go there? Because you can't. Wait a minute. Let me just finish this. You cannot choose an example that has the same traits as something that doesn't exist and you made up. I'm really sorry, you cannot.
There is an example in my video. It's not my footage, so I mean I can't validate that it's legit, but it shows
of an invisible object casting a shadow.
4 objects move behind the moon during the lunar eclipse.
Are you on about lens flare or spherical lens flare effects or something?
It's not lens flare because the camera isn't moving.
Give me a time. I've still got your video up. Give me
I'll say this right now. Any flat earther listening right now, I've issued a challenge. I've put it in the chat. I want you to go tell all your friends. Find that idiot Riley who basically starts all these stupid fucking ideas of how things work, and let him know my challenge. Someone explain to me how a fucking lunar eclipse works on a flat earth. I'll delete my fucking channel and you'll never hear from me again. Until then, I'm getting sick of these word salad, blah, blah, blahs. Here's the reality of it. Lunar eclipses debunk flat earth. And, hang on, I'll do it in sign language. Thank you.
Maybe you should watch that video.
I don't need to. Maybe you should do what Dean keeps begging you to do. Go back in this stream, look at his explanation so your 10% is ruled out, and then think about how the 90% of the lunar eclipses are done, and then realize, my friend, it's a globe. Trust me, fight the deception. I will welcome you with open arms when you come back to the globe. Thank you.
Yeah, and remember, Shawn is like a skeptic. Shawn's not one of those shills. He looks for the truth. He tries to understand things. He's not like die hard one.
And if anyone thinks I'm a shill or indoctrinated, bring your asses onto my panel and let's do this. Hey, all you got to do is explain it. I'll be gone forever.
It has to be a plausible, realistic explanation. It can't involve made-up things that
I made that clear.
Have the same traits as made-up crap. That's fantasy.
And my best friend Blue in the chat made something very clear, and it made perfect sense to me. I can presuppose that globe all the frick I want. Want to know why? Because when I break down the evidence of it, it works. When you do it with the flat earth, which is 100% presupposed, nothing works.
Pretty much your opinion, but
No, it's not my opinion. And if it was my opinion, you'd be able to show different. No? Anybody? Any flat earther in the chat? Do I need to put the link out there again? I can do it.
Shawn, it's just my opinion, but you seem to have woken up a little bit.
Oh,
I like this.
Yeah. This is sleep. This is sleep deprivation and reality working together.
It's adrenaline setting in now.
He's in stage 5.
It's on
You
the
guys ever
hunt.
seen the movie Crank?
Yes.
Yeah, I need to keep going now. So the rest of this day, you're going to be hearing a militant, let's do this, flat earth, Shawn. When's Jose going on? I got shit to say.
Do a 24-hour stream, Shawn. Just do it.
Welcome to Open Discussion. What's up?
I don't know. It sounds like everything's up at your place.
Yeah, it sounded like
My kids.
Demolition.
Don't worry, I was just kidding. I'm messing with you.
Yeah, that's what 3 kids sounds like. Demolition.
Yeah.
Yeah, I can explain eclipses in a flat Earth.
Do it.
So, if you ever heard the story of the dodo, back in the day, the decapitated tree alive being reflected, like a kaleidoscope. Anyway, sorry, I can't explain it.
This is not the one with about the leprechaun.
No,
that's a different story. Oh,
that's a 3-toed gnome. So we're still waiting for a fluffer?
Yep.
You ready?
Well,
I don't want you to delete your channel, Sean.
I'm gonna delete
I'm
it.
gonna show you how. I'm gonna tell you how it works.
Okay, let's do this.
Have you heard of Planet Nibiru?
I'm gonna fuck you up too. Sasha, in about 2 minutes, Sasha, I'm gonna need you to get off this hangout so I can start expressing myself.
How do I pick that person?
So Planet Nibiru is cloaked, and it's casting a shadow, but you can't see it because it's cloaked.
Okay. Sasha,
Can
plug your ears. And Max, I need the number of where you get your stuff.
Is it cloaked?
There's three letters. There's 3 letters in my equation. It's called DMT.
Thank you, sir.
Dynamite.
So the issue with cloaking technology, which is actually semi-real, by the way.
Yes, it is.
You cannot. It bends light. Light is the thing that gives the shadow. So if it bends light enough, then there is no obstruction as it's passing the light around it. Hence, it doesn't have a shadow.
How would you know? How would you know if there was anything out there if it was in between you and the sun?
What's it called? What is it? Gravitational lensing? What the hell is that thing called? What is it?
No, but I'm saying like during a new moon phase, you don't see the moon. During a solar eclipse,
too bright.
Exactly.
Different.
So
Completely different. If it's not aligned, the reason why a solar eclipse happens is because the moon is perfectly aligned with the moon and in line with us. That's why when we get a new moon, we don't see it because the sun is way too damn big and way too damn bright. Ooh, damn, explained by the globe again. Damn, I'm on a hot streak. Bam!
But also on a flat Earth,
if there was objects there, you wouldn't see them because the sun's too bright, right?
No, we'd actually see the absence of what's behind them.
Yeah.
So the other thing here as well is
Then how come you can't see a new moon? How come you can't see a new moon?
I just explained it.
Have you ever tried to look at something with the headlights in your eyes and somebody standing in front of it?
No, I totally understand it. I understand the concept of it, but in reality, what you're saying is there couldn't be anything out there because we don't see anything, but we don't see the moon.
In reality, let me just add one bit of.
Shut up, Dean. Yeah, that's how I feel. First of all, buddy, during a new moon, which happens a very short period of time compared to the rest of the moon phases, we would see something throughout the month, but we don't because we can see, and we're not blind, and we're not guessing, and we're not predicting based on nothings. So guess what? The reason we know the moon doesn't disappear and go to Disneyland during the new moon is because at a certain angle, you would be able to see it. You would be able to see an object in the sky in between the sun and us. That's called a solar eclipse. Now, if you go somewhere else and have the right angle, you're probably going to see a piece of something that seems weird, but it's the moon being where it's supposed to be.
You don't think there should be a silhouette?
Only if it's aligned perfectly.
Yeah, and it only lasts what, a couple minutes or something.
But here's a bigger thing for you to
The new moon
reconcile.
phase?
But here's a bigger thing for you to reconcile, because all of that is kind of minuscule and thin end. All you have to think about is if the moon was local and we had a half crescent looking at it from Washington, in Florida, it would be not a half crescent, it would be less. And then down in Argentina, we'd get the inverse of it and also be able to see a different side of the moon. So that must by itself let you know that this thing is not local, it's far away, since we all see the same side of it.
But to me, even that seems impossible to me. That if I can see it on the horizon, setting, say, and someone else can see it rising for them, the angles that they're both looking at, they should be seeing different parts of the moon.
Yes, they are by a factor of 5 degrees, because it is 238,000 miles away, and those two observers are only separated by about 7,000 miles.
Yeah,
it all works out.
Yeah. In Fight the Deception, what you're saying would only be possible if it was local. But the problem is nothing that we observe says it's local. Why? Because for one, we can measure the distance, and with multiple tools that are used in 2019, and because shit wouldn't be possible if it was local. This whole idea of a lunar eclipse would not be possible. Do you understand this? Even if it's a globe and everything's that close, it's not possible. It has to be further away to make the shadows and the phases that it does. Everything is explained. And guess what? And this is to everyone, I presupposed the globe. But guess what? All the evidence that I have compiled to fact check my presupposed idea of a globe works.
Well, I guess, I mean...
It does. I'm sorry. It does work. You can't say it doesn't, because guess what? It does.
It doesn't work for me, but...
Oh, no. It doesn't have to work for you, but when it works for when it works for everyone else... Who do you think? Okay, I have a better idea. It
doesn't work for everyone else.
Are you smarter than science and scientists that work figuring all this stuff out? Are you saying that you're smarter than all of them?
No, I never said I was smarter than everyone.
No, not everyone. All of the scientists that got us to where we are today.
Yeah, I never said I was smarter than any of them.
Okay, then what makes you think you have it figured out and they are wrong?
Well, then, basically they'll tell you that, they can't prove that we're not the center of the universe.
First of all, yeah, has nothing to do with my question and or the topic we're talking about.
Well, to me, it is the same topic, but
no,
is it not important to just address that thing? You said it doesn't work for you.
It doesn't work for me. No,
yeah, but
I've seen
what bit of it doesn't work for you, and don't say the bit that I explained fully for everybody else but you, because you didn't look at it, because that would be annoying.
There's a whole lot more stuff. I mean,
just one, the biggest one that doesn't work on the heliocentric model. Go for it. Go for it. Just the biggest one, or the second biggest, or third biggest, but one of the top 3.
I'll take a 10th biggest.
Well, it all works out on the heliocentric model because that's how they've.
No, stop right there. Stop right there.
Basically,
we agree so far. This is a really good conversation.
Basically, the heliocentric model is unfalsifiable.
Cool. Awesome. So curvature.
It means that no matter what arguments are presented, there's always a counter argument that is unprovable by anyone. That doesn't have $52 million of data.
Nope. We have not discussed anything today that has anything to do with any observations or tests that we ourselves could not have done. everything we've talked about can be observed without 50 blah 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 $million.
Which isn't a lot of money, by the way, per day.
Well, for any one of us, it is.
It's like the distance to the
individually.
stars. Distance to the stars. Okay, so I'll use that as an example. Distance to the stars. It's unfalsifiable because, you know, Polaris stays in the same place in the sky basically all year round, even though we're supposed to be moving 31 million miles a day.
What's this Polaris you're talking about? I don't see a Polaris in the night sky.
You need to install the transparent Earth mod.
Sorry. Sorry, you just got me confused. I just never heard of
You
this
might
Polaris.
not be able to see it. That doesn't mean it's. I mean,
where is it?
It's
where is it?
Fixed in the same position.
Where?
Even though we're supposed to be moving through space.
You've got a guy that definitely
Orbiting the
can't
sun.
see it. You've got a guy that cannot and has never seen it.
Yeah, because it's out of his range of vision.
Wait.
Isn't that a forward?
Fight the deception. Have you ever seen one of those eclipses you keep talking about? You know, the 10% ones?
Yep.
How many times?
Just once.
When?
Personally, just once. So I've
When?
seen a bunch of them filmed. It was
Wait, a bunch of them filmed?
2000.
Oh, I thought it
Yeah.
was rare.
A bunch of them.
Yeah,
It is rare. It's only happened 52 times in the last 500 years or something like that.
Okay. And when did you see it?
It was 2018. I think it was January. Was it January 28th or?
Wait, just the recent big eclipse, basically.
2018. I'm talking about the lunar eclipse.
Okay, I see.
I thought we were talking about the 10% one.
Yeah, that's what I was talking about.
Yeah, me too. This was one of those times.
Let's find out.
I could be wrong on the date. It was 2018. I'm pretty sure it was January 28th or 31st, maybe, or maybe it was 20th and 21st.
Yeah, can we get back to this this four-wheeled Odyssey thing that you can drive around on the beaches and in the farms? Where you see one of them things? Polaris, that's what they are.
Oh yeah, that's a manufacturer. Yeah. I just got that then.
Sorry. Well, that's the only one I know of.
Yeah, jet ski manufacturer as well. I like it.
Oh, they call it the North Star.
Yeah, the problem there is a lot of people on the planet cannot and have never seen that.
Yeah, because it's
what?
out of their perspective.
No.
Huh?
Yeah.
What?
Perspective is not defined as it's away, you know, it's so far away that you can't see it because of the light intensity.
Yeah, but I'm only
we already know that happens.
Well, I'm only a few miles away from you guys, so if you can see it, why can't I?
Because you're out of perspective. It's just like looking at street lights going into the distance. You don't see every single street light past a certain point.
But wait a minute, what if those street lights were hundreds of thousands of meters up? Do you know what trigonometry is?
Yeah.
Do you know that you can work out the distance given an angle and a distance, or two angles, I guess?
I don't think you can accurately do it because of refraction. All the different layers of gas have different refraction levels.
No, wait a minute. You don't have to deal with different layers of gas. The gases do not separate in the atmosphere. If you think that is true, please give a citation. It is not.
Helium rises until it gets to areas where there's a bunch of helium, right or wrong?
Brilliant. And what's the refractive index of 100% helium? And it will give me a particle count as well.
I don't know the exact
approximate, just approximate.
I have no clue.
All right, so you're saying you have no clue about this source that may or may not separate, but you can't demonstrate it with no citation, which is the reason why. Is that what you just said? Because that's
Are
weird.
you trying to argue the fact that heavier and lighter gases? Well, I don't understand what you're saying then. Are you saying that there's helium? Are you saying we
is
breathe in helium?
mixed.
Do
You
we
do
breathe
not
in helium?
breathe. You do not breathe pure argon. You do not breathe pure carbon dioxide or pure oxygen or pure nitrogen. You breathe a combination of all of them, no matter whether you are at sea level, halfway up a mountain, or at the top. Are you telling me you don't believe in that?
I would believe that helium would rise. I don't think there's helium down here.
No, there isn't. Are you telling me you believe that what we call air separates into component gas parts? Is that what you are saying?
To a degree, the ones that are similar in density obviously are going to be closer to each other.
So what's at the ground then? Which gas is heaviest and what's at the ground?
I don't know which one's heaviest.
Do you think we could survive without oxygen?
Sulfur hexafluoride is pretty heavy.
Do you think we could survive without oxygen?
I never said that, and I don't know why you're.
So is oxygen not at the? Because if we don't have oxygen at ground level, we die. It is that simple.
Oxygen, yeah, and the higher you go, the less oxygen there is, right?
No.
The less gas there is, because the less molecules density we have, the higher we go. It's not that they separate into component parts. We have oxygen, nitrogen, carbon dioxide, argon. These are all the atmosphere that we breathe.
So you're saying that up 120,000 feet that there's a bunch of oxygen up there?
Yes.
Oh my God, yes.
It's just less. It's less than what it is here.
Yeah, parts per million is less, but the quantity ratios are probably pretty much the same.
And
I don't know how they'd react to cold, but yes.
I thought we were talking about polarity.
I got a question.
Oh, okay.
How come I can't find any of, in 2018, any of those types of eclipses happening? Solarian or whatever the frick it's called?
Selenium.
Yeah, how come I can't find anything on that?
It's a good question.
Because there's a conspiracy to hide it.
Ah.
They don't talk about it much.
How do you
can
hide
find it
something that's already happened and everyone saw?
Can I get back to my stuff?
They do it every month. They do it all the time.
Every month?
No, I
misspoke. Okay, no worries.
I didn't mean to say that.
No worries. Go ahead, Terry.
Well, Polaris can't be the only star in the night sky that's visible, can it?
Whoever said that? I don't understand. You guys using
How come if the Earth is flat, how come we don't see the sun 24 hours a day?
Because of convergence
of perspective, right?
Yeah, but this is what I'm trying to get at. If I can't see a certain star because of reasons, but yet I can still see other stars as well, why can't I just see this one particular star?
I already explained that. If you, it's all dependent on the distances to the stars. If you go to a long road with a long row of street lights, each street light gets closer and closer to the road from your perspective. Correct? But even though they're all the same elevation above the road, they look like they're getting closer to the road until they meet at the horizon.
I can still see the light.
They meet with the horizon eventually, correct?
Yeah, but it's the light I can still see.
So why would you be able to see? I mean, you just can't see. You just can't see that far.
Wait a minute. You're creating a very contrived, local, tiny example that does not actually purport to reality, given the scale of things, right? You do know this.
Given the scale.
How high is your sun? How high is your sun?
I already said I don't know how high the sun is.
Let's call it.
For
They haven't
someone
been
who
lying
doesn't,
about
how do you tell anyone things work away or not away, and you don't even know how anything works yourself? This doesn't make fucking sense to me. You don't know where the sun is, you don't know where the moon is, but you know why shit works the way it does. You know it's flat, but you don't know anything else, but you know it's flat.
And on the ground, I know you can see light for a long distance.
Yeah, until the convergence doesn't allow you to see that far. It's just like looking down a hallway. Everything converges to a point, even though the hallway isn't infinite and it's on a flat, and it's flat.
No.
I mean,
Show me a flat
But
hallway.
I see the same stars
What?
at night time as what everyone else does.
You guys throw that word flat around way too much. I don't think you guys even understand flat level
well,
drainage.
the farther you get away from a certain star, the more it goes towards the horizon, just like street light would.
Wait a minute. Are you ready? Are you ready? So if the sun is 3,000 miles high, for it to disappear and converge to the ground, based on perspective, you would need to be looking at it 171,000 miles away. So it might work if you could get about, partway distance to the moon away from it, but it would never disappear on a flat disk with a radius of like, what is your radius? Probably 12,000 miles. You would have to get 20 times that distance away for the sun at 3,000 miles high to disappear. It would never disappear. That's only to get it within 1 degree of visible angle from the horizon. How weird is that?
I thought the flatter sun was like a torch somehow.
No.
It only directs the light down in one spot at a time.
Wait a minute, I'm gonna do another one now. Let's have a look at this.
I'm trying to learn something here. I'm getting.
Right, here we go. So to get it actually down to the horizon line within 1/10 of a degree, you would be looking, are you ready, at 2,005,350 miles. That's 2 million miles you'd have to be away for it to get to the horizon. If it was 3,500 miles high and the Earth was flat. That's how simple that calculation is. That's trigonometry. You get taught this at school. Basic math.
It's ignoring refraction.
No. Okay. Brilliant. Stop there. I am ignoring refraction to aid you. Can you please explain to me what refraction is?
Yeah, please explain.
If you think I'm ignoring it, what is it?
It's basically the behavior of the in the atmosphere that
I don't know. Try it.
Refract from light, and
I don't know. I'm waiting for someone to tell me.
Right. Okay. Are you ready? Do you want to know what refraction is?
Yes, please.
It's based on Snell's law. You have 3 components to it. You have an angle of incidence, you have a normal of the surface, and then you have a reflecting inner angle based on and the ratio or the fractional reduction of light speed is based on the index of refraction, and it actually has inputs into Snell's equations that give you the output. The important thing here is it always bends down. Always. Unless you get mirage.
Actually, what's more important is that he's able to explain it.
You're talking about light refracting like in a pool of water, like in a fish tank, and you throw a laser beam through it, and the light.
Well, yeah, but we see that in the atmosphere. There's no difference between water and gas. They both work on what you call the interaction is always governed by Navier-Stokes equations, and
Fluid.
they can both run off fluid dynamics. Yes, correct.
Yeah,
It's just about different densities. So
yeah.
yes, water will refract downwards. That's how fish develop evolutionary skills to compensate for refraction when they shoot bugs from plants. They're not actually shooting at the bug. They're shooting not optically where the bug is at all, but they instinctively know based on millions of years of evolution. But
same
the point here is
with eagles when they attack.
Yeah,
and
the
eagles
point
are
the
cool.
point here, yeah, eagles
Yeah.
are pretty.
Okay.
The point here is
And
it bends
Aborigines.
downwards. Deception. It bends downwards. Do you know what that does to objects in the sky? It moves them up. Light bending downwards through less dense to more dense mediums move things up. I am leaving out refraction because it hurts your flat Earth cause. If you want me to put it in, then that's fine. But then the sun gets even further away from the ground. And that's not what I was trying to demonstrate. I was trying to demonstrate, given ideal circumstances with no refraction, we have to be 2 million miles away if the sun is 3,500 miles high.
I never said how high it was or how big it was.
Give me some figures. Let's see if we can make it work, but we won't. And the daft thing is, it doesn't actually change angular size either, so you've got a problem there.
It changes a little bit.
Over the course of a year, yes, to the tune of like a fraction of a percent or something stupid.
I still want to know what
But do you want to know what's weird here? Is the moon with the heliocentric model, the ecliptic plane, and the orbit during minimum and maximum distance from the Earth, given that elliptical orbit, change size 14%. And this is observable, predictable. You can measure it yourself. And it's predicted by the heliocentric model, but not by flat Earth. So go figure that out.
I've actually never heard of that.
Yeah, well, a solar cycle is 27.5 days, and then you've got the maximum and minimum distances from wherever you are, and you can see the moon. If you take a fixed focal length camera, point it at the moon, and take a photo on these days, you will get a size difference of about 13.8% or something, depending on where you are. I know from where I was looking at the survey data. And that exactly matches a heliocentric model and the ecliptic plane of the orbit of the moon and its distance.
From full moon or what?
No, just the moon. You can actually see the moon all the time if it's in view, depending on what camera you have, because you can actually add filtering and then digitally boost exposure to actually find the silhouette of the moon almost all the time if it's in view. The only time you won't be able to see it.
So you can see a new moon?
If it's in view where you are on the planet, you can actually, and at night time, you can actually expose to a point where you can discern where the moon is, yes. You can't see it with your naked eye because your naked eye just sees a whole load of black. You can see an absence of stars, I guess, if you looked, maybe. I don't know.
I've never seen any pictures or anything of that.
Well, yeah, well, I guess you've never seen a cesium clock measure the time dilation difference between elevation of a meter from the ground. But in today's technology, we can do a hell of a lot. And that proves Einstein's general theory of relativity and space-time. And we can prove that now because of technology. It's that, it's incredibly simple, this stuff. Technology. That's why I don't understand why people go back to experiments hundreds of years ago, when they could only measure things to the 100th of a second or thousandths of a second, whereas today we can measure 1.1 quintillionth of a second accuracy. So why not use technology?
I've never seen it.
Doesn't mean it's not true or real.
Do you have a link for that?
For what, a cesium clock?
No, a picture of the new moon phase.
Wait a minute, let me have a look. It depends where from. Because you need obviously you need to capture it based on a cycle.
From anywhere. From anywhere. I just want to see a picture of one from anywhere.
Moon phase.
I mean, as far as my research has shown, I've never came across that.
Well, I haven't personally looked it up, but I'm pretty sure you can boost ISO or get hyperspectral imaging to show you it, and there are handheld cameras that do that now. But give me a second.
We're talking about the moon in the daytime, when the sun's in the sky and the moon's in the sky. Is that the same
A new moon phase.
No, you won't be able to see it then because of the atmosphere.
So you
Yeah, actually, no. So, sorry, you would be able to see it through.
I've seen it.
Yeah, you would be able to see it through. Yeah, but a non-illuminated version of it. You might be able to see it with a hyperspectral camera, but not through the atmosphere when the atmosphere's got loads of diffuse light running through it.
And there's some days I can see a faint, almost full moon in the sky in the daytime.
Yeah, I've seen full moons in the daytime several times.
Hey guys, so Jose is live or is about to go live if he's not live already.
Yeah, he is.
And I you know how I roll with that. So I'm gonna end the stream, but I'm going live instantly after he ends. Because this fucking hey, listen, this
No, you're not. You're gonna be.
You want to bet?
You're saying it, Sean.
You want to bet?
But in about 3 hours' time, you're gonna be there snoring on your back.
No, because I'm
dribble
about to go
down your face.
I'm about to go over to Jose's. I've already asked Jose for 5 minutes to issue this challenge to any goddamn flat earther. I'm doing the lunar eclipse challenge, motherfuckers. I want you to get me to delete my stream, period. Because you won't be able to. And that's how everything is going to happen today. I am going on a rampage today. A rampage. I'm debunking flat earth today, people. You're going to see me everywhere today. And I will be live.
That's not,
and I'm
that's
gonna go
impossible.
Live, and I'm going to go live after Jose just to prove Dean wrong.
Yeah, but if you do that, what are we all going to do tomorrow?
I don't. Touche. But I'm putting the link in the chat right now. Everyone go over to Jose's. I'll be over there in a second. I'm going to get on that damn panel, and that's what we're going to be talking about today. Lunar eclipses, and prove it to me so I can delete my channel. But it's not going to happen. Why? Because no one can explain a lunar eclipse on a flat Earth.
I'm going to bring the leash and hold you back a bit because I know you'll go head first straight in.
That's right. I'll see you guys over there. I'm ending this link so I can get over there now. I'll see you over there. Hey, Fight the Deception. I do appreciate you being here. I do appreciate the fact that you're not an asshole flat earther. So you are more than welcome on my panel anytime you want.
And Sean, we'll appreciate you not getting any sleep.
Yeah. I'm not sleeping today. I'm not sleeping today. I'm debunking flat Earth today.
Oh, Fight the Deception. You should join the 3-day debate.
Oh, okay.
Yeah, you guys talk about that. I'm ending this, so I'm going to do my outro so I can get over there.
Yeah. Fight the Deception.
Yeah, like I said, guys, going over to Jose's. I'm going to try to get on the panel ASAP. And I'm dead serious. Tell every flat earther you can freaking find. Explain flat Earth, your flat Earth version of a lunar eclipse that makes sense. And I'm going to delete my channel. Because otherwise, I'm going to either concede to the fact that a lunar eclipse would never work, or continue to lie. See you guys over there.